Hi guys, welcome to C# Programming, a practical applications approach. And in the subtext, I like to call the course Introducing Teens to Software Development. Hi, my name is Charlie Shirelli. I'm a recently retired computer science teacher with over 35 years experience. And for the last 7 years, I was teaching programming to high school students primarily online. And what I wanted to do in this course is give a real basic introduction to computer programming using the C# language. On this site and a number of other sites, I always see courses that are supposedly called Introduction to C# Programming, Java, whatever, and I look at the topics and I go, holy smokes, these courses are simple at the beginning, maybe for the first 4 or 5 lectures, and then they take off too fast. So what I wanted to do in this particular course was develop a very basic introduction to a programming language and show you some very practical applications for all the different concepts we're going to cover, so you can see how it's used in everyday life. And as a little carrot at the end, I want to finish up this course with some sample games. Okay? Now, I call it Introducing Teens to Software Development, but really it's for anyone who has little or no experience using a computer programming language and wants a thorough but basic introduction to, in this case, C#. Now, having said this, you can watch me all you want, go through the demos, but until you get your hands dirty and actually do the material with me, go through the exercises, you're not going to get anything out of the course. So even though it's a very basic course, you still have to get in there and actually do the material yourself too. So good luck and on to lecture 2. Welcome back. This is lecture number 2. In this lecture, we're going to take a look at some of the software you need to install in your machine to do the rest of this course. So let's start off and take a look at the first thing you're going to need to install. Visual Studio Express. That's what we're going to use for the majority of the course. And when you get to this screen, when you come into the site every day, you should see these 4 tabs up here. And what you should do is get into the habit of pressing the second one. What you'll see after you press the second one is a brief little synopsis of what we're going to do in the lecture. Then below that, you'll see some downloadable resources. Most of the times you'll see that. Some lectures there won't be anything there. And also you'll see sometimes some external resources that are places you can go on to the internet and get information, or in this case, software. So as I said, we're going to be using Visual Studio Express. So let's press this. This will take us to the Microsoft site. Now when you get there, they will try to push you to download the Community Edition 2015. But this is overkill for us. It's about 30 gig, too much for what we need. I just want you guys to download the simple Express version for now. And we're going to do that right now. Now what you'll get is sort of a small file which will then connect to the server. So let me first of all save this to my hard drive. Once that's on your hard drive, you would double click it, and it would take a good half hour, maybe more, maybe less, depending on how fast your machine is, to install the software. Now, how do you know if it works and if it's doing the right thing? Well, after you install it, somewhere in your programs, this is Windows 10 I'm using, you will see it, and I've put it already as a little icon here. Here's what will happen when you start it up. Okay, so now this is the look of Visual Studio Express, and just for fun I'll show you what we're going to be doing in the next couple of days. We're going to press New Project, and there you'll see Windows Form Application, and in a few seconds C# will install, and you'll have the basic setup of the form and all your tools that we're going to use for the majority of the course. Okay, now we're not going to go any farther in this for now, but that's what it should look like, and if it does that, it's working and you're ready to go. Now, the second thing you need is sort of an unzipping program. I'm going to give you a lot of demos over the next little while that are compressed. There are a bunch of files that I put into one sort of massive file. So you need a program to uncompress them. So WinRAR is the program I recommend. When you get to the site, download the one that's appropriate for you. This will put an executable on your hard drive. Then what you do is, once it's downloaded, is you double click this and install that program. This can be done within a minute. It's a very quick install. Once that's installed, now you have access to all the samples I'm going to give you, and you can unzip them and then get to the examples that we're going to use in the course. Now let me give you an example of what I'm talking about. So for instance, in this one right here, this is, if you pressed it, an entire zip folder. Now this is a huge folder. This has every one of the demos I'm going to do for the whole lecture series. And if you're looking down here at the bottom, you'll notice it's 321 meg. It's a fairly large program. And when you uncompress it, it'll have every example. Now, that might be overkill. I actually rather that you do it a different way. And just to show you what I mean, I'm going to go back to our dashboard here for a sec. And let's pretend we were on this lecture 9, for instance. Or let's start with lecture 7, actually. Let's press this here. When you get there, as I mentioned before, you have a little review of what you see, and then there are some sample files that you can download. I'm going to download this one very quickly. This one won't take as long as the one that's downloading now. This is a very short one. So when you go to your temp drive or wherever you decide to put it, there is the one that I just downloaded. Now, how do you unzip it, so to speak? Well, what you do is you right-click on it, and this might be a little bit off your screen, but there is, when you pop up right at the very top, there's one that says extract to, and then we pick the name of the file, and in a matter of seconds, it'll make this folder. Inside this folder is a bunch of other folders. Okay, so let's take a look at pizza for a second, just for fun. So after you would unzip it, depending on the lecture that day, you would go in here, start up one of the demos. Alright, and this is what it would look like. It would start up your C# program, Visual Studio Express, and this is a little fictitious pizza interface for a store. I'll even run it for you just for a second, just to show you what it does. Okay, so you order a particular pizza and how many you want to order, and it calculates the bill. So something simple like that. So that's going to be the process we're going to be doing for all the lectures. So 1, make sure you download Visual Studio Express. 2, install WinRAR also, and those are all you need to get you rolling. And then in the next lecture, I'm going to show you some examples of what we're going to be doing over the course of these 50 or so lectures.
Welcome to Lecture 3. This is the final lecture in the introductory section. And what I want to do in this lecture is show you what you're going to learn. Now, the focus of the course is learning C# through practical application. So what I want to do over the next couple of minutes is show you some of the examples from a number of different fields, from business to science to mathematics to games. Let's start off with this first one here that you'll learn near the beginning of the course. This is just a simple application that simulates kind of like a cafeteria or a cash register for a cafeteria. So let me just run it for a second. And what you'll do in a program like this is basically create these little things over here called text boxes and then radio buttons, and then you'll allow a user to press the particular food category that they want to buy a certain thing from, and the numbers appear here. Then we have a little button here to calculate the bill. So this is one type of application that you're going to work on during the course. A primary focus of the course also is how you interact with a user. So once you feel comfortable doing some of the mathematics and creating a user form, what you'll do is create multiple user forms. So you'll have a main form. This could be for a doctor's office. And then when you press a button, another form appears that you've created yourself. These are called user-defined dialogues. And we'll work with things like this. And I'll just quickly type in a few things here. So this could be a secretary in the office typing in information about a patient and then having it stored somewhere. So we're going to use this kind of interface and create new forms with different dialogues. One of the most important concepts in computer programming is the concept of repetition. That's where you continually ask a series of questions or have the computer automatically do a series of numbers all without your intervention. Here's an example that has a little bit of both. So in this example, we ask a person for the radius of a circle, and it gives us an answer. And then it asks us again if we want to do it. And if we say yes, it asks for another particular radius, gives us the answer, and then I think I've had enough, and we say no. So this is the concept of repetition that we're also going to look at. Now, that's where I intervened. There's kinds of repetition where you don't intervene. You just press the button, and the computer cycles through a series of numbers and produces, in this case, a chart that converts from Celsius to Fahrenheit. So there's all kinds of different applications that relate to this that we're going to cover in the course also. A really powerful command and concept that we're going to learn in this course is the array concepts. We're going to look at one-dimensional and two-dimensional arrays. In this example here, I'll show you the power of arrays. What arrays allow us to do is remember people's information, and in this case, we're going to ask for fictitious marks for a number of students. I'll type in one more. And then what it allows us to do is take that information, redisplay it, put it in reverse order, and do things like statistical analysis, determine who got the highest mark. So that's something that you can't do without the knowledge and power of arrays. Now again, this was with a user dialogue. I was talking back and forth to the computer. We have examples that we'll learn also where the information is stored on a file, and all you do is press the button and it loads it in from what we call a little database. Okay, so that's another kind of application that you're going to learn in this course. Following with the idea of arrays, another really powerful concept, once you understand that, is the concept of sorting, meaning putting things in order. Smallest to biggest, biggest to smallest, alphabetically. So here's an example that teaches you the most famous sort there is, the bubble sort. And basically, I read in these files from a database. I didn't have to hand type them. And here they are in the original list. And then here they are sorted from smallest to biggest. And that happened in a matter of seconds. So that's another practical application that we'll learn in this course. A really cool application that we're going to look at in this course is determine whether you or your parents can get accepted for a credit card. And when you go to Best Buy, for instance, you have to answer a series of questions and meet certain requirements. So we're going to tell you the logic that's involved in that. And that involves this idea of selective processing where you have to make decisions. And this example here gives you a nice little application that determines a set number of people that are applying for a credit card, and it works out their status. And it gives them their status based on the salary they have, how long they've been working at the same place, how long they've owned a house. And it's kind of a neat application that incorporates a bunch of ideas, another application that you'll learn in this course. One of my favorite applications that we're going to do in this course is to determine the validity of a credit card or a product code. And you're not going to break into anything, but it's kind of neat to see how the thinking is involved when you validate things. And I'm going to show you the code first. Not that it'll mean anything right now, but in this particular example that we're going to learn in the course, I'm going to get you to test out count numbers. And a lot of them have this special thing that's called a check digit. Sometimes the check digit is at the beginning and sometimes it's at the end. And what we're going to do with this example and ones like this, we're going to do a couple of these kinds of examples, is we're going to validate credit cards. Now, I'm going to just type in one right now. May or may not be valid. Okay. All right, and I just made that up, so obviously it's not valid. But we're going to do this kind of validation technique and show you that it's not as complicated as you think. And that's one of the neat features when we do the unit on strings. Now it's time for a little bit of gaming, a little bit of graphics, a little bit of random numbers. And we'll start doing some fun stuff like this. We'll develop programs that play card games, for instance. All right, so this is the game of war, and that's you, that's the computer. I want to play a new game, and it basically figures out who wins each round. And it does a little bit of nice graphics there, and it keeps track of how you're doing. And you're not doing too good, actually. Let's see if you finally won one. All right, so we're going to develop this kind of simple little game as part of the course also. Now, as we learn more sophisticated graphics, we will develop programs that scale information and design things that will output bar graphs. Okay, and here's an example where we can make a bar graph that displays sales for certain years of a product, and we can do it horizontally or we can do it vertically. Okay, well, that's kind of neat. So it incorporates some graphics, it involves a little bit of math, and we start developing actually really neat applications that look like something like Excel. Do you like to doodle? I like to. What we'll do as we get, again, more sophisticated with our graphics, we'll develop like a little Etch-a-Sketch program where you can pick a color and you can doodle on the screen. You can change the pen size, make it thicker. You can change the background color to something else. Whoops, and everything got wiped out there. So let me pick another color and I'll draw on top of that. So this is part of the graphics we're going to learn. And you see me using the mouse, so we're going to learn how to program the mouse so the computer knows where I am at any moment in time. So that's another neat application we're going to learn in this course. Now we get closer to developing a game, and the first part in a game development is to learn how to animate objects. And the first thing we'll do is we'll learn these things called image arrays, where you store a number of images, frames, and then you let the computer cycle through those frames, and you've got a kind of a simplistic little animation. So we're definitely going to do that as we develop our more advanced versions of games. Okay, let's get that little guy to move around. So the next logical step in this animation is to make him actually move. So he's dribbling and moving. So that would be the next step, and we're going to do that in the course and learn a couple of different things. I'm going to give you a little assignment to try that makes a car race game. Speaking of the car race game, here's a typical program that some of my former students worked on related to that kind of a race. Now, they made an airplane race. And let me just give you an example of how it works. Isn't that cool? So we're going to learn how to do that. Okay, and we'll do it one more time. All right, so we're going to learn some animation. Things are moving around, and it looks really cool. Continuing with the theme of gaming, how about a slot machine? We're going to learn how to do that. We're going to show you the logic and some of the math behind determining winners for a slot machine game. Okay, you got 2 in a row, $5. Okay, so that's another type of game. Graphics aren't as spectacular in that one, but it's the logic behind determining whether you know you got 3 in a row or 2 in a row. And we're going to do that kind of program also in the course. Now, as we approach the end of the course, we start to develop a couple of games that involve collision detection, some sound effects, moving with the keyboard or the mouse. And here's the first of 2 that I would like us to work through that you're going to do in the course if you take it. All right, this is a very simplistic one. Don't laugh at the images, but it's the idea is you're going to have objects dropping from the sky, and you're going to try to hit them. Depending on the speed, you get more points for certain things. And I've just incorporated that dribbler we've used a couple of times. So you're going to learn a little bit of this. Now, even though you might find this hilarious and say that's kind of corny, the coding, even to do something as simple as this, is actually a bit more advanced than you think it is. So you're going to learn all these techniques, how to incorporate images, how to put in graphics, how to detect collisions and things like that. So that's another thing we're going to learn in the course. Okay, here's our last example, and this will give you a good idea where we're trying to go with all this code and techniques and commands that we try to have you guys learn. So last thing is to develop a fairly sophisticated space shooter game, and it incorporates a bit more music. All right, and you can go back and forth, and you're going to be shooting at these objects. Okay, so again, it might not look that great, but even to do this type of code, there's quite a bit of coding that goes behind the scenes here, a little bit of graphics that you need to incorporate in your programs, and the speed's not great, but I think I got that one. Yes, I got that one. Okay, so that's what we're going to finish up with. So hope you are interested, you're getting excited about what we're going to learn, and hopefully it'll be an interesting and fun journey. Welcome back, and now it's on to C# Basics. Now before we get rolling, let's get used to the Udemy interface, what the different parts mean and how you could use them. So when you go and do a lecture, and we are going to focus right here, we're on lecture number 4. There are 4 tabs up here, okay? So this first one basically shows you all the lectures in the course. This one here is to get a synopsis of the topics you're going to cover today and some resources if there's any to download.
This is a discussion forum where you can post questions and I'll respond to them, or other users will. And this one here is to write your own little notes for each lesson, maybe a little important idea that you picked up. Let me press on each one just to show you. And actually, let me do these two first. So the discussion forum, you can post a new discussion and I can respond to it. Here it's kind of neat. You can type in some comment about part of the lesson, a little note that you want to remember. This is the most important one, okay? This one will give you a brief synopsis of what we're going to cover in this particular lecture. And then there's usually, for most of the lessons that I'm going to show you, there's going to be some place to download a file or a bunch of files. So I'm going to press this right now just to show you how it works. Okay, so what you should get in the habit of doing is make a folder on your hard drive. Okay, so I've decided I'm going to make a folder called Lecture Demos, and all my demos that I do or download are going to be put in there. If you don't remember how to make a file folder in Windows, basically you right click and you go to New and you press Folder and then you give it a name. So I've named it Lecture Demos and I'm going to press Save. Now after a couple seconds that you've downloaded that, you're going to unzip that file. Okay, so basically when you go back into Lecture Demos, there should be now this zipped up file. And if you installed the WinRAR program in this case, and you right click, you should see a couple of different things that you can pick. And I'm going to pick the one called Extract here. And in a couple of seconds, what that's done is extracted this compressed file, uncompressed it, made this file folder, and inside of there are 2 other folders. Sometimes there's 10 other folders, sometimes there's only a couple. Okay, so let's give you a little taste now of once you, let's say, download these demos, like how do you get them to work? All right, now we're not really going to learn how to program yet, but let's just see how you take one of my examples and just take a look at what it is. So let's go into this box right here. Now, oh, there's a bunch of names here. Which one do you pick? Well, you're going to be looking for something that has the .sln at the end of it. So the samples.sln. Now, if you double click on this, which I'm going to do right now, and you've installed Visual Studio correctly, it should start up automatically as you're seeing it do right now on your screen. And in a couple of seconds, you should see the program in C#. Okay, now, what does all this mean? Well, over here on the right-hand side, you now have a lot of the components that this program consists of. It's not always one file. There's a bunch of files. And as you can see from here, these are images. This we're going to get to in a second. That's where most of the user interface is. And there's a few other files, some which are important, some which you'll need to know about, others just leave them as B. Now, the screen here is blank. So where is the stuff? So I'm going to go over here to the form. I'm going to double click on it, give it a couple of seconds, and ta-da! There is what we call the user interface form. And it consists of a number of controls. These controls came from the left-hand side here. Visual Studio C# comes with a number of controls that you can add, and when you add them to your screen, you've got things like pictures, picture boxes, okay, you got check boxes, you have radio buttons, you have scrolls, you have text boxes, you've got just regular buttons, okay, so these all come from the left-hand side and they're added onto the screen, okay? Now, great. But is that an actual program? Does it do anything? To make this program actually work, what you do is you go up to here where it says Start and you press. And now what the computer's doing, and it happened very quickly in this case, it compiles the code that was in sort of English into its kind of computer code, and now it's ready for you to run. And when it's executed, and it's executing right now, you can do things like, if you press this, certain pictures appear or disappear, okay? If you press one of these little circles, certain things happen and unhappen. This is just a scroll bar that makes the numbers go up and down, like a numeric control. This thing right here is a text box. You can type whatever you want, and if you type enough, all of a sudden this becomes active and you can go up and down. This is a button that beeps. You probably won't hear it on
your screen. We're going to get into more sophisticated sounds after. This is kind of cool. When we press this, we're going to do some computer animation, okay? And then it bounces back up. All right, so these are just examples of a program. Now, you're going, great, that's the pretty stuff, but where is the actual coding that makes all of this work? So to get to that, you right-click on your screen, and then you press View Code. And now here is all that weird stuff that I'm going to teach you in this course. These are called C# computer commands. And there's actually now like two views that you're looking at. You're looking at the design view, which is kind of like the pretty thing, and then you're into the code view, which has all the special computer codes that make all those little buttons and things work, okay? So don't worry about that right now, because this is not going to be for a couple of days. We won't learn anything this complicated for a couple of days, but at least it gives you a taste for what a computer program in C# looks like and how you're going to get it. Now, let me close this off for a second. Let's pretend when you double-clicked on this file here, it didn't start up Visual Studio, and you're going, okay, now what's going to happen? Well, sometimes for whatever reason, depending on what version of Windows you have, it might not associate it with the program, but it doesn't matter. You can still get to it, all right? It'll still be available. Now, here's the other way to get it. If you just start up Visual Studio on your computer, and if you want me to, let me just start it up from the very beginning. So when you start it up, it looks like this. Okay, so when it starts up and you want to open that program and play it or run it, you go to File, okay, and then Open Project. And now what you do is you go somewhere on your computer. So let me backtrack a bit and let's pretend I'm at the temp drive. I go in here, there's lecture demos, okay, there's intro, there's that sample program. And it doesn't show everything in this case. It hides some of the files that aren't necessary. So when you go to Open Project, it basically shows you a couple of the files that you could use to load up the program. There's the one that I want to press to load it up. I'm going to double click on it. So this is the second way to load in my demos into Visual Studio. Okay, so if one way doesn't work, you can go with this one. And tell you the truth, once you're in Visual Studio, you're not going to exit it and click on them. You're going to stay in here and just open up the new examples or the demos that you need to work with. Okay, and everything else is basically the same. All right, so there's our brief introduction to how we're going to use our routine every day to have you check for the synopsis of what we're going to cover that day. Also, demos that you need to download that you're either going to use in practical application problems or just little demonstration programs. And sometimes there'll be some other optional programs that may be useful to you. All right, now we're going to, in our next lesson, finally get to computer program. We're going to do something really simple, but at least it'll give you a taste for what it takes to write a real computer program in C#. Okay, so thank you, and we'll see you in the next lecture. Welcome back, and now we're finally going to get to write our first computer program in C#. So let's start off and load up Visual Studio. All right, and the first thing we're going to do, and we're trying to get into a routine of how we create programs all the time. We're going to get a particular routine down. So first of all, we'll go to File, New Project. All right, and there's several types of C# programs that you can write. We're going to focus in on Windows form applications, okay? There's other sites on Udemy that teach C# and they spend a lot of time doing console apps. I'm not going to do that. I'm going to go straight to the fun stuff, the cute little things that you can see on screen because we're very visual. We're going to do a lot of user interface applications. So we're going to pick that one 99% of the time, okay? So we're just going to gently click on it once first. And now I want you to focus on here. I'm going to rub out this, and what we're going to do is we're going to call this our first app. That's what we're going to call our application. And that will be the directory name. And inside of there, there'll be a bunch of other little files. And the program file that will get everything going is also going to be called first app. That's kind of like, you could change that if you want, but I usually match the folder name to the app solution name. Okay, I always try to get those to match. Next thing is really, really important. Make sure the computer is pointing to the exact folder where you want to save all your stuff.
Okay, so let me press browse for a second again. So let's pretend you were on your temp drive and then you worked your way to the folder where you want to put everything. And like I mentioned in the previous demo lecture, I've made a folder called Lecture Demos. And inside of there is where I'm going to put everything I do in this course. Okay, whether you load down the material that I've given you or you're saving your own stuff, we're going to put it into that particular folder. And then I'm going to press select folder. And what you'll see down here is that it now says every time you save something, it'll always be in the lecture demo. Okay, I think we're ready to press OK. All right, and you give it a couple of seconds, and what it's going to do is it's going to show you a blank screen, so to speak. We call that the form. And you're going to have tools on the left-hand side and some other material over on the right, which I'll explain to you in a second. So actually, let's take a look around the screen and make sure we acquaint ourselves with all the different parts. So the main screen, where you're going to put all your controls, buttons, pictures, whatever you want to put here, okay, we call that the form, okay, or the user design form, okay. On the left-hand side here, where you're going to drag things like boxes and pictures and things like that, we call that the toolbox. All right, that's where all your tools are. And there's actually a lot more tools than you see there. And later on, as we get more sophisticated in the course, I'll show you how to import more tools into that toolbox. On the right-hand side is what we call the File Explorer, Solution Explorer. Okay, and what that does is show you some of the bits and pieces, not all of them, but some of the bits and pieces that make up your actual application. Okay, so there's the form, there's the starter application, and you notice these two have the ending .cs, which stands for C#. Okay, and there's other things up here which we'll talk about as we go along. The last important part of your screen is the property settings. And again, you won't know what these mean or do until I show you our actual program that we're going to work on today, but these are your properties. Okay, so those are the main 4 parts of the screen, and we're going to use them today to create our first computer program. Okay, so how do you create a program? What are the steps? Well, what I like to do, and I like to do this all the time, is first thing I like to do is give everything meaningful names. So over here where it says Form 1, that doesn't mean anything to me. So I'm going to rename it, and I'm going to call it, and I'm going to always be kind of following some rules. So forms are always going to start with FRM, and then you can name them whatever you want. So this is our first app, so I'm going to call it Form First App. And don't rub out the .cs. That's really important. If you do that, you're going to mess up the program. Now I'll click away. The computer will give me a little brief warning, and then I'll press yes. And now what we've done is change the name of the form to Form First App. Now, let's click on the form itself. This title is not that good. I don't like that. I like to have something more, illustrative of what we're going to do in the particular example. So now we got to go down here to these things called properties. And there's all these different settings that you can change. Actually, we've changed one sort of indirectly by changing the name of the form, and here it is right there. We're going to slide down to a property called text. So this is alphabetical, and notice how it says Form 1. We're going to call this First App, and when I click away from it, now the title up here changes. Okay, so now what I'm doing is I'm changing the properties of this form. Next, let's go up here, and there's a property called back color. Let's see what that does. I'm going to pick custom, and I'm going to pick sort of a light yellow. Okay, so there's another property I've changed. Now I've changed the back color of the form. And there's some other things that you can do. You can have it so that the form, when it starts up, goes right in the middle of the screen. So there's something called startup position, and we can make it go center screen. All right, and you can fool around some more later on with those properties. You can't wreck anything. Sometimes it won't look as good as what it was before, but you can change it back to something else. All right, so now I'm pretty happy with that. Then what I do is, and I always get nervous about this when I'm doing something big and important, do a save. But not just a save, do a save all. Because as we get more complicated in these programs, there's going to be more than one screen.
There might be multiple screens. So this is the safest way to save everything. So I'll do a save all. All right, I'm just happy that every time I do something important, I save in bits and pieces just in case something happens, the computer crashes or whatever, the power goes out. Okay, now let's get used to using some of these controls here. There's several hundred of them. We're only going to use maybe a half dozen to a dozen, but let's start off and use the most basic one. It's called a label control. So I'm going to press it once, then I'm going to move over to the screen and I'm going to make a big rectangle. And labels are used for titles. Okay, and again, we're going to follow some rules. So now that the label is highlighted, clicked on it with that little dot, I'm going to go over to properties, and all labels are always going to start off with LBL, like that, and I'm going to call this one label title. Now, that didn't change anything there. All that did was name that control, that little object there. So what I'm going to do now is slide down to text like I showed you a few minutes ago, and what I'm going to do here is I'm going to call this welcome to my program. All right, so that'll be the title right there. Now, there's other kinds of things you can do to this title. You can change the font size, you can change the color of it. There's the font right there, actually. And if you don't like that font, when you press on that, it'll pop up and you can change it to a different style font. You can make it bold. You can change the size of it, and then you press OK, and now it's a different size and a different look. Next control I want to show you is the text box. Used quite a bit, and we're going to press it here, and we're going to make a little rectangle here. The text box is used when a user has to type in information. Now in this example, I'm just putting it up here. We're not going to actually use the information the person types in there. We'll do that in a later example, but I wanted to illustrate what a text box looks like. And again, let's make sure we follow the same technique every single time. We're going to name our text boxes always as TXT, and then I'm just going to say user name here. So I'm going to ask the person who's using it to type in their name there, okay? So you don't use any text in this one. Now, I guess if you did put some text in there, you could say this is like the default. If you wanted to put that in there, let's see what happens when I do that. There's a word default there, okay? If you don't want that there, you can leave it out. But that's a text box. We'll use that in a second. The most fun is when you start putting images and pictures on your screen. So how do you put a picture on your screen to make it look, you know, nice? Well, there's a thing called picture boxes, a control. We're going to press it. We're going to make a decent sized rectangle there, and that's where our picture is going to go. Now, same technique. Make sure you understand this. And when I've taught this over the years, some students say, sir, come on, please, I don't like doing this part. But yes, you have to name all your objects, because later on, as we get more sophisticated, we're going to refer to those objects, and they have to have a set name that makes sense. So picture title, we'll call it pic title, okay? And then we're going to click away for it for a second. Now here's a common mistake students do. I'm not finished this yet. I actually haven't put a picture in yet, but by accidentally clicking away from it, when I go over here, you're going, what? Where is the stuff for the picture stuff? Well, you are looking now at the form. What if you pressed here? You'd be looking at the label title. If you pressed here, you'd be looking at text. So make sure you know that you're supposed to be on this when you're going to change properties associated with that. So the most important property we need to change right now is we need to load in an image. So there's an image property. And right now it says there's no image. Yeah, that's true. We're going to press the three dots, and we're going to pick something from our local hard drive, and we're going to press import. Now, you've got to find something on your computer that's an image. I happen to know I have some images stored on this machine. I'm going to go to a folder called images, and I'm just going to double click on this one, and then I'm going to press OK. Now, don't freak out. Sir, you loaded in the picture. Where is it? Well, the picture is so big relative to that little itsy bitsy box that we need to sort of scale it down. So there's another property. We'll slide down here to size, mode, and we'll put it on stretch. And there's our image. Okay, let's finish up with buttons. And I'm going to put two buttons on the screen. One's going to do something like say hello to you, and the other one's going to exit out of the program. Okay, so there's a button. We're going to throw one there, and we'll throw another one there. And again, let's be consistent. Buttons. So this first one here is going to be my welcome button. So buttons I'm always going to call BTN, and I'm going to call this one welcome.
Now, it doesn't actually say welcome when you do that, so you got to slide down to text. And where it says text, we're going to write down welcome. That's the first button. The second button is going to be my exit button. So that one I'm going to call BTN exit. And again, that word's not going to show up on the button. So you're going to slide down to text. And where it says button 2, I'm going to type in exit. Okay, now properties for buttons, you can also change the look of them, the background color and things like that. For now, we're going to leave them alone. And I'm going to do a save. I haven't done a save in a while. And I'm going to run it. Let's see what it does. Okay, give it a few seconds to compile. This is the first time that the program's run. There it is in the middle of the screen because we have a property called center screen. Beautiful. There's the word default. I'm going to type in my name there instead. These buttons don't do anything though, okay? But this is a real first computer program. It's got a nice title. It's got a little box there for information. It's got a little graphic and a couple of buttons. Okay, now let's put some intelligence to this program. Let's make it think and then react, okay? Now when you react to something, that's called an event. And one of the first events we're going to look at today is called the click event. So I'm going to double click on the welcome button. And I'm going to go into the underground. Now here, you got to be careful, okay? Don't go driving around anywhere else. You landed right here, stay there and start typing there. Don't decide to type in here. Don't decide to type up here because it won't work, all right? So wherever it puts you, stay there and start typing. And I'm going to teach you a couple of words now. These are special computer words, C# words. The one we're going to do right now is called message box dot, okay? And what follows is one of the special things that belong to the message box command. And the one that we're going to use is called show. But then you need a bracket. What we're going to put in there is the word welcome. And here's the thing that's going to drive you crazy in this entire course. Each C# command needs to finish up with a semicolon. If you don't put the semicolon in, it's going to be a mistake. Now you're in the underground, so to speak. How do you get back up to the top? Well, here you go up here and you're back up to the top. And you can do a save again, always be consistent, and then we press start to run the program. There's our program again. You can type in your name in there again. And this time when I press welcome, look at that. That is called a message box, and it's got the word welcome on it, and press OK to stop it. Okay, let's finish up and program this exit button. And again, how do you get to code it? Because we have to go into the underground, into the code. So you double click, and this event that we're doing is called the click event. And I probably didn't focus on it enough in my first example, but notice how it has the word click there, click. So we're using the button click event. There's other events. There's a button mouse over, and there's other ones I'm going to teach you this semester. But right now we're focusing on the click event. And again, don't go walking around crazy. Stay where the computer puts you. And the way that you tell the computer to exit out of this program, this is one of the ways. There's several ways. This is the first way I'm going to show you, is you say the word this dot close, and it'll close the program. And again, let's go back up to the top, into the screen, do a little save all, okay? Try to get into good habits. Press run. There's our screen again. Type in whatever you want. You can say welcome again. That's still working. You can press exit, and it exits out of the program. Now, if you've been following along and you got everything to work, congratulations. But even myself, things go wrong. Things don't always work out. So let me give you a couple of for instances that might have happened while you were doing this little example program. Let's double click in here. This is the most common thing that can go wrong. The infamous, you forgot the semicolon. Okay, so let's pretend you forgot it. You pressed start to run it and you get this message. Okay, don't freak out. There's an error. Now, what it'll do is it'll say, would you like to continue and run from the last successful build, which means, I know you screwed up here, but you want to go back to the one that worked and run it? No, I don't want to do that because I made a mistake. Let's see how we fix it. So press no. Now, sometimes it'll be nice enough and highlight the general area where your error is. In this case, it does. And then you fix it. And then you press start and it works. Okay, so we're going to talk more about what is called debugging as we get more sophisticated in the program, but that's basically what you should do if that happens. Another thing I've seen students do over the years is accidentally make things disappear. And I'll show you what I mean. Somehow they accidentally come over here and then, oh, it's gone. And you go, oh, sir, where's my properties? I'm trying to set properties. If that ever happens to you, don't worry about it.
go up to View, and these are all the little things that you can add on to your thing. Now I'm looking for properties. Properties, where are you? Properties. Do you see properties somewhere? There it is. Properties window, bang, it comes back there. Okay, so if you ever lose one of these screens, chances are you can go here and find it out. There's Solution Explorer if you lose this little thing here. Okay, there's Toolbox if you lose Toolbox. So hopefully if you've gotten little errors, you'll be able to react to them and fix them up. So there you go. There's your first little program. And what you should do now is create one similar to this, but do it yourself. Put your own little graphics on it, different background screen, maybe make up a little different message here instead of welcome. Do what you want so you start to feel comfortable using C#. So if you got this to work out, great going. If you didn't, don't worry about it. Keep plugging away. While we're showing other little details about C#, why don't we take a look at the right-hand side and investigate a few of those little screen files and see exactly what they do. So as you know, form, that's this thing right here that we're talking about. But what are these things right here? Okay, I want to show you what they are. What makes C# and the Visual Studio environment so neat for beginning programmers is that it makes the interface, the designing of the screen so easy for you. Now, behind your back, the computer is doing some dirty work, and I want to show you a little bit of what's going on behind your back. See this thing called First App Designer? I'm going to double click on it for a sec. And right here, this is what the computer is doing behind your back. It's writing the special commands that place those controls, like the label, like the text box, like the picture box, like the buttons on the screen. So this is how it's being designed for you behind your back, okay? And we just see the pretty stuff, which is okay, especially when you're just learning. In other languages, sometimes like Java, they may force you to type in some of these commands. Another command that you might be wondering about is this one right here. Whenever you load images into your project, and not just one, but 7 or 8 of them, they are stored in this resources file. Okay, so if I was to click on this, when I had 7 or 8 pictures, it would show all 7 or 8 pictures, and they get all sort of compressed and put into one file. It's kind of a nice, neat little package. The last thing I want to show you is this program right here, which you don't really touch. But what it does, it's got a line here that kickstarts your whole program to tell the computer, listen, once you get past me, now go to the form called First App and make it appear and start the program. Okay, so there's all these little files, and we'll talk more about other ones, like we're going to talk about references in a couple of days and things like that. But those are all these little files and what they mean, just so you get a basic idea what's going on behind your back. It's not magic, it all makes sense, and I wanted to show you some of the background information that you would use. Okay, time for our next application. So today what we're going to do is we're going to learn how to use radio buttons. Okay, so they're kind of neat. I want to give you an example of how they work and how we're going to use them in a practical application. So let's first of all close this solution, and then we'll go File, New Project. We're always going to pick Windows Form. This one here we're going to call Radio Buttons. Radio Buttons. All right, and we're going to press OK, and we'll get started. Now I'm going to do a bit of doodling on the screen for a few seconds, and then we'll actually make the application. But let me start off and just give you the theory behind this. What we're going to do is we're going to have these little circles, which we call radio buttons. Okay, and when we click on one of them, we want something to happen. What we're going to do is do something really simple. We're going to make like a happy face appear. And if we press this one, we're going to make a sad face appear. And then maybe these two make a picture of rain coming down from clouds. And maybe this one has lightning bolt or something. Okay. Now, you notice that these two are totally separate events. So what we're going to have to get used to is we're going to have to put these radio buttons into their own separate groups. Because the way a radio button works, when you press one of them, it unpresses the other one. Okay, which is good between these two. And when you press one of them, it unpresses the other one. But if we did not use these little groups around the radio buttons, when you press this one down, it would undo all three of these. So by putting them into groups, you separate them. So now let me, again, not doodling, but again with this idea, let me show you what I mean. So we're a radio button. So this is alphabetical, I hope on your computer too. So you press a radio button, we'll put a little one there. I'm going to grab about 4 of them just to give you an idea. Now, we're not programming yet, and you don't have to do this part with me yet. Just watch me. So we're going to put 4 radio buttons here, and we're going to start running it right away. All right, we'll drag this right here. Now here's the way a radio button works. When you press one down, it unpresses the other one, unpresses the other one, unpresses the other one. But if we wanted these to be 2 separate things, what we did here was wrong. So let me rub these out for a sec. Okay, and now what we're going to do is we're going to pick the radio buttons, but before we do that, we're going to do this thing called a group box. There is a group box right there. So we're going to make a big group box there, and we're going to make another one right here. And now we're going to put radio buttons inside of those. Okay, so I'll put one there, do another one. Okay, so they're in sort of like their own little world now. We do the same thing right here. Radio button, and one more. And now we're going to run it. Now notice what happens this time. As I press these, nothing's going on here. They're in their own little world. So these 2 are going back and forth. These 2 are going back and forth. So now we're basically done the prep. All right, so again, we're going to delete all this, and we're going to delete all this. Okay, and now we're ready to program. Now, you have a fresh screen. I don't. I've wrecked mine. So I'm going to close this out and start fresh. You don't have to. Okay, I'm going to start fresh, new project, and we're going to start off, and we'll call this new radio buttons. You keep yours the way you named it. Okay, so we got a fresh screen and we're ready to go. Okay, let's remain very disciplined. Do it the same way every single time. So the first thing I'm going to do before I get rolling is I'm going to go over here to the form. I'm going to rename it, and all forms should be called FRM. I'm going to call this radio. And then I'm going to click away. I'm going to get a little message. Always say yes. Okay. Next. I don't like that title. Okay. Pick something a bit more. So we're going to call this radio button example. Okay. I'm not going to change the screen color this time. I'm just going to leave it like that. But those 2 are ready. And then I always press save all just in case. I always get a little nervous. Okay. And now let's add some radio buttons. And actually, we're going to stop for a sec. I'm going to drop this screen down, and I want you to make sure, as you should always, you should have downloaded this right here, right? User interface, and unzipped it by right-clicking on it and zipping it with WinRAR. Now, when you go inside of here, we're going to need this folder in a few minutes. This has pictures, okay? Not that great of pictures. It doesn't matter. We're going to go specifically in this one in a few minutes, and we're going to take these images and use them in our program. So as you see me go through and grab images, you're going, where'd you get those from? They're in the resources for today's lecture, and once you unzip it, you should see that there. Okay, so if you're wondering where's he going from, it's because of those images in the icon folder. All right, so let me pop back up Visual Studio, and let's get rolling. So what we're going to do this a simple one in this example. We're going to use the group box, even though I'm only going to have one section, but it's still proper to use the group box. I'm going to make a decent size section right there. Next, we always go over and name whatever we're working on. So we're going to call this group box GRP, and then we'll call it mood. And you can also go and change the text box on it too. So we're going to say moods. So there'll be the word moods there. Okay, now we're going to go and grab 2 radio buttons. All right, and we're going to name these 2 in a second. So there's the first radio button and a second one. Okay, so this radio button right here, we're going to call it, and again, new naming convention, RDO, and we're going to call this happy. And we're going to actually type in the word happy there. Okay, and then this one right here, we're going to call RDO sad. and we're going to type in the word sad there. Okay, next, we're going to add 2 images. Okay, 2 images are going to be picture boxes, so we're going to grab 2 picture boxes, put a picture box right about there, and another one just below it. This picture box, remember, always be consistent, so we're going to call it pic happy. Okay, and we'll get the picture in a second. And let's call this one pic sad. Okay, now this pic happy, we're going to do a bit of digging, all right? So this is where you might get lost a little bit. So you got to make sure you remember where you downloaded those images for today's lecture, and we're going to go looking for them. So I'm going to move up a little bit. Okay, so remember, this is lecture demos, user interface, icons. I'm going into the miscellaneous, and you're going to go, where's the pictures? So what you got to do here, because I'm using some kind of weird image format called the ICO format, I'm going to press star.star, press enter, and now they'll appear. They're there, but they just wouldn't get picked up by this. So I'm going to pick this one for the happy, and then I'm going to press OK. Remember, you got to stretch that because it didn't come in the size of the picture box. So I'll go stretch image, and that's good enough size. Okay, this one here is going to be our sad. Same technique. Now I might get lucky because it might remember now where I was. And when I go to local resource, okay. And we'll go down and we'll pick a sad face. And again, we'll stretch it. Okay, so those are our 2 images. So what does that look like when you run right now? Goes back and forth, but the 2 pictures are still there. So I want, when I press happy, to have the happy face. When I press sad, to have the sad face. So that's what we got to do next, and that's computer programming. And actually, before I computer program, let me go over here again to the form, and I want it to start sort of in the center. It's popping up over on the left-hand side of the screen when we run this. Okay, so let's see what that looks like now. So now it starts in the middle. Very good. Okay, let's do this in stages. So first of all, when I press run, I don't want those 2 images to appear. I want them to be invisible, and then I'll make them appear by pressing one of those 2 radio buttons. So there's a property for the images. I'm going to press the first image. I'm going to slide down to the word that says visible, true, and I'm going to make it false. Okay, then I'm going to slide down to that one, and I'm going to slide down to visible, true again, and make it false. Okay, so now let's run it again. And now you notice they're not there, and when I press these, they're not showing up. So it's crunch time. We got to actually do some computer programming now. So let's go into the underground, the code, and make these appear or disappear depending on what we press. So let's double click on happy. And what we're going to basically tell the computer is, listen, when I click on you, picture happy dot visible should be equal to true. Semicolon. Okay? And you got to think about this. You press that one to make it appear, then if you were on the sad one, you have to make that disappear. So there's always a little bit more thought process than you think when you're doing these. So we're going to tell the computer to make it invisible. Okay? And we're not done. We've got to do basically the exact reverse for this one. And actually, I'm going to get a little bit lazy, and I'm going to copy this. I'm going to paste it in here. But this one is the exact reverse, right? So in this one, you're trying to make the sad face appear. So this is false. And this one becomes true. Okay, and I'm getting a little bit nervous, so I'm going to do a save all. I'm going to go back into the design window, and let's try it out. Okay, so there's a little setting that's a bit more advanced that I haven't shown you. That's why nothing's appearing yet. But let me press sad, and let me press happy. Uh-oh.
What did I do wrong? All right, let's press happy for a second. So pick happy visible. Oh, pick happy again. No, no, no. The second one is called pick sad. And this one here is called pick sad. Okay, and that's why it's really important to name your things. So I know at the beginning students say, sir, why do you name all these things? But now, as you saw through that error I made, if you don't remember what you called them, you're not going to get the results. So there's pick sad and there's pick happy. Okay, let's try this again. So this time, sad, happy, sad, happy, sad, happy. Okay, before we wrap up today's lesson, what I want to do is mention one other thing that was in the lecture material today. You see me calling forms FRM and picture boxes PIC and radio buttons RDO. So did you just make those up? Well, these are pretty well standard rules that a lot of programmers use. And in your downloads for today is this particular PDF document, which has suggested prefixes when naming C# objects. So I'm not saying you absolutely have to use these, but it's just like nice convention to follow. And here are some of the things that we've done or are going to do, like button already we've done, so BTN, and form is FRM, and a group box is GRP. So you've got a nice little summary of some of the more common ones that we're going to use in this course. And so you can use them in that format. Okay, so I just wanted to mention that to wrap up. So hopefully you got this to work, and there's other things that you can do. Dream up other things that you want to do. Maybe have two separate ones. So I did mention that you've got these things called groups. So why not make another separate group totally unrelated to this one to maybe make other objects appear and disappear when you press on the radio buttons? Okay, as your little practice for today. Okay, thanks for listening, and we'll see you on the next lesson. Welcome back, and now we're going to look at some more controls. Today we're going to do some really cool stuff. We're going to use the scroll bars first and show you some neat examples with that control. Then we're going to take a look at how to create menus. Menus like this. You can't believe how easy they are to do in Visual Studio. And we'll finish up with multiple controls, which means you'll have a screen that starts up and there'll be a button on it. You press that button and it goes to a different screen. It's almost like you have an opening screen to your program, and then you get to the main screen where you play your game or whatever. Okay, so let's get rolling. So as we always do, we'll click on File, New Project, and Windows. And we're going to call this first example Scroll Bars. And we'll press OK. And as we always do, we'll click over here. Now you'll see that I'm going a little bit faster now when we do this. Hopefully you're starting to figure out the technique. I'm trying to be consistent here. So we're going to call this form scroll bars. Okay. And we'll always try to add a little title here too to make it informative. So we'll go down to text and we'll change that to scroll bars. Now, there are two types of scroll bars. There's a horizontal and a vertical. They are programmed the same way. They basically work the same way. They just look a little different. I'm going to just use the horizontal for this example. Okay. Now, when you scroll this scroller, do you want to start at 0 over here and go to 100? What do you want to do? So you can set a number of properties related to scroll bars. So let's go over to the properties window and start off first of all, and we'll call scroll bars that are horizontal HSB, and we'll just call this demo. One of the properties is the minimum, and right now it's set at 0, which is fine, and it goes to 100. If you want to change that to 50. Another property that we're going to look at is as we slide that slider, do you want to go up by 10s, 5s, whatever? So that's the small change and also the large change. Okay, so we can set both of them. We're going to set them both to 1. Okay, so we're basically set with our scroll bar. But as you're going to see, when you run it, it slides back and forth. But so what? Unless we see some number telling us, oh, we're at 50, 49, 80, whatever, it's not going to mean anything. So we need to add another control. We could use a text box or a label. Let's stick with a label for now. We're going to put a label right there. And this label we'll call label demo. And you could rub that name out. I'll leave it in for now. I'm going to show you what happens when you do rub it out after. So we're getting there. Slides back and forth, but I still don't see anything there, so we got to program it. And while I'm doing this, let me make the form go right in the middle so you can see it better. Okay, so like I said, we're sliding this back and forth, but I still don't see anything there. Okay, so now we're ready to program. To program this, what we're going to do is double click on the scroll bar, and we're going to feed the value of the scroll bar into the label. So the way you do it, it's almost like you write an equation. So it's label demo dot, and we're going to feed it in a number, but there's a property called text. There is no number property for a label command. And then we're going to say it's going to be equal to the HSB demo dot. Now again, I'm not sure what to use here, but if we slide down, you would eventually get to one called value, which makes sense. It's the value that you're sliding back and forth that I want to feed into the label command. And then you always remember the semicolon. But I'm getting an underline with that red, which means I'm doing something a little wrong. Well, what's happening is that we are taking something that's going to be a number like 7, and you're trying to put it into a label which only stores strings, and those are things that have quotes on them. So we're going to do something kind of funny. It's the first time we've ever done it. We're going to have to take this number and add quotes to it. And there's a special command that you add to the end of this that says make it into a string. A string is kind of a fancy word for something that has quotes on it. Okay, so let's see if that actually works. So now when we press here, we're getting numbers, so we slide all the way back to 0, and we slide it all the way there, and it gets to 50. We're in about halfway, that's around 25. Okay, so there is how it works. Now let me do a little teachable moment here, because we're going to get into this in the next lecture, but this is kind of like what's called an assignment statement. And in computer science, usually the stuff that's on the right goes into the stuff that's on the left. So what's happened is you've got our screen here, which has the scroll bar, which we're sliding back and forth, and that value is going into that label. Okay, so there it is as a picture. Here it is as a computer statement. The stuff on the right will go into the stuff on the left, and that's how you got that result. Now, after I taught kids this, I show them one that it's too easy. It involves no programming at all. It's called the numeric up-down control. I'm going to put it right here. And this kind of combines this idea and this idea into one. There's no programming. Watch what I do with this one. So you just press this, and it goes up and down. Now this one doesn't have any set limit. That's the only thing. Oh, you can set it to 100 though, so watch. Maybe it does have a set limit. Let's go to properties, and it probably does have a maximum and a minimum. So there's the minimum 0. Let's make the maximum, I don't know, 250. And we'll click. Yeah, it's going to go to 250. So no programming at all. So that's ridiculous, but that's what you can also do. So you've got this horizontal scroll bar that has a bit of programming. So I'm glad I still showed it to you. And this numeric up-down control, which combines both and makes it even easier. Okay, so there's our first idea today, scroll bars. Okay, on to our second example. In this example, what we're going to do is now create menus. So I've already made a new form and I've called it menu. and we're ready to modify it and do the programming. So as we always do, I'm going to go over to here, and I'm going to call this form menu. And I'm going to click over here and type in the word menu example. Okay. Now, what am I going to try and do? Well, I'm going to make a menu up here that gives you a choice of 3 colors and then changes the background of the screen to one of those 3 colors. Kind of cool, right? So where is this menu system? Well, it's called a menu strip. Now, this is what's going to be a little bit weird about this. I'm going to drag it on like I usually drag on anything onto the form. And when I let go, it actually kind of goes not right on the screen, but it goes in 2 spots. First of all, you see something here now, and the control shows up down here as a menu strip. Okay, so if you say, hey, what happened? You've done it right if you see that up here and you see that down there. Now this is a real piece of cake to use. So right up here is going to be like our top menu. Okay, so I'm going to type in color. The sub menu underneath that, I'm going to type in a couple of different colors: red, green, and blue. You could type in other ones, and as we get more sophisticated with our knowledge of C#, you can basically, the sky's the limit. Now, let's take a look at what that looks like when you run it. Color, and then you have your 3 choices. Isn't that neat? We've got a menu already working. Now, you could add more to this menu, or type another menu over here. And these could be screen sizes. Now, I'm not going to do this one, actually, but we're going to just show you that you can make all kinds of menus that go right across the screen. And let me, like I always do, I like to have the screen size in the middle. Okay, we'll run this again. So now you've got colors, screen sizes. Okay, now let's add some intelligence to this. Let's make them actually work. So let's go to the colors, and we're going to press red, double click on it. We're in the underground, and what we're going to do here is, it's pretty easy. The way that you change the background color of the form is you say the word this, and then back color equals. Now again, this is a little bit different. Color, dot, and then red. That's it. Let's try it out. So you press color, red, and the background of the form changes to red. Let's finish up the other 2 just to make them complete. All right, and take the lazy way out, copy and paste. And then obviously this one is the green one, so you type in the word green. Let's go back to the other form. Type in the last one, and we're going to make this blue. Now, just for fun, before I make this one blue, look at the number of choices for colors there are. There's hundreds of them. And there's even more than that. When we learn some other things called RGB commands, I'm going to show you even how to do even more. But there's all kinds of deep. Let's do deep sky blue, just for the sake of doing something different. Okay, and now we're going to run it. And there's red. There's green, and there's deep sky blue. Okay, isn't that cool? And that's how you program the menu. Okay, and now on to our last idea today, multiple forms. So let's start off and create a new project again. And we're going to create a project called multi-forms. This time when I go over here, I'm going to name this form intro, just to simulate the idea of how I would use this kind of idea in an actual program. So there's form intro, and we're going to go up here and give it a title, intro page. So this might be the opening to your game, and you'd have a splash screen, you might have your name, and then a button or something to go to the second form, which would be where you play your real game. So let's add a button. And we're going to call this button welcome, and we'll just put the word welcome on it. Okay, now we have to create the second form. To create the second form, what you do is you right click over here and you go to add, new items, and you go to Windows Form, and you can call it whatever you want. Okay, if you keep it as Form 1, that's fine, but really it isn't Form 1, right? So we're going to call this Form 2, and we're going to press Add. Now, the intro is already made, but now there's a Form 2. We can change this name too if we want. We can rename it to FRM Game. And then we can change the title of this one to Game Page. And this would be where we play our game. Now we're ready to program. Okay? And to program, what we would do is go back to the intro page, double click on Welcome. And this coding's a little tricky, okay? We'll get more into the explanation of why it works at a future date, but I just wanted to introduce this concept here to finish up the lecture today. So here's how you would do it. We want the game form to appear. And we're just going to use what's called a variable, and we'll just call it X for the sake of using it, equals new form game, bracket, bracket, semicolon. Very weird, okay? What we're doing is we're almost like we're creating an object, and we'll get into this thing called object-oriented programming later in the course. Now, to make this form show up, which I've now called X, what you do is you say, X, please show up, and you actually use the word show. And that's it. That's how you make the second screen or second form appear. Let's take a look and see how it works. Okay, so there is your opening page, welcome to my game. You would press welcome, and there would be your second form, which would be your game form. Okay, so let's go to the second page for a second to finish this up. The game form, how would you close this page after you were done and go back to your opening screen or whatever? So let me make a button on this screen. Okay, and in this one, we're going to say return to opening screen or something. So we're going to call this button close or return. Let's actually call it button return. Okay, and then down at the bottom, we'll put the word return on it. And then here's the code for this. It would simply be this dot close, bracket, bracket, semicolon. So now we have our opening screen, the welcome. Then this screen appears, which is the game page. We press return, it goes back to this screen. Okay, and just because I don't like where it was popping up, remember to always set this other thing, the start position, to center screen. Okay, so that's the game page. This is the intro page. And we'll set the startup screen for that one also to center screen. Okay, so now they're going to start up right in the middle. There's the game page. You would play your game there, and then you return back to there. So that's kind of a cool application. So we've covered 3 really neat ideas today. Hopefully you're starting to see that there's all kinds of little gadgets that you can add, those scroll bars, the menus. Then we've got this idea. Next lesson, we actually get into the heart of computer programming. We start talking about how to remember information, which is called variables, and how to assign them, which we did a little bit of today also. Okay, so hopefully you're starting to get a feel for all the cool things you can do, and then you can experiment, for instance, with that menu one and change the different colors, do all kinds of little cool things that you could do. Just to finish up, I want to show you, once you get really good at this, there are some really cool things you can do, and I want to just load in one of them. And these are all the demos that you downloaded for today's or yesterday's lessons. It's in user interface. There's one called RGB colors. I'm just going to quickly show you this one before we wrap it up. I'm going to run it. And this one uses those numeric up, down, and controls. And I don't know if you're noticing, the screen's starting to change color. Okay, so this incorporates a little bit of those colors. Remember I told you, the Microsoft has certain set number of maybe a couple hundred color names, but this way you have thousands, if not millions, of potential color combinations by just changing the elements there. And this is an example of using those numeric controls. We'll get into this kind of a program later on in the course. Hi guys, today we start one of the more important concepts of computer science, the concept of
entering information, processing it, and then displaying an answer. In particular, today we're going to focus on the concept of computer storage. And in this lesson, we will take a look at what variables are, the different data types. We're going to take a look at assignment statements. We're going to create a couple of simple programs using those concepts, and we're going to finish with a concept called scope of variables. Okay, so the concept of computer storage. See, most programs, when you write them, there's always three common elements, almost always. There's always the element of you have to get information from the person. So there's this concept of there's an input. Then after you've gotten the number, the word, or whatever, there's always some sort of process. All right, you may do some math to it, you may rearrange the letters, you may display an image somewhere, and then the last step is always the output. Okay, you display the final result. You display character movement. You display a coded message. All right, so there's always three steps in most computer programs. Okay, input, process, output. And what we're going to do today is we're going to focus in on this input. How do you get computer information in the computer's brain, in its memory? Tomorrow we'll look at mathematical processes, and we're also going to do a little bit of output today too. Okay, so first of all, let's do some rules. These variables that are going to remember what you want to have go into a computer's memory. They're called variables, okay? And they can hold numbers, strings, which remember I told you is the fancy word for anything with quotes on it. Words and numbers can also be in quotes, okay? Special characters, anything like that. Now, when you name these variables, they should always start off with a letter, okay? So these are all valid variable names. The second character can be a number or a letter. All right. Now I say here, just for my sake, that you shouldn't use any name more than 40 characters, but you could. All right. Just don't use any spaces. Okay. Put it all together. Here's a long name. The other thing is don't use special words. Now, sometimes you won't know they're special words. Like console beep is a special word in C#. How did you know that? Well, when you run the program, you're going to get an error. Chances are if you've used a special command, like there's a command we're going to learn called if, you can't use that as a variable name. Okay, so these are special words that mean something to the computer. Okay, now once you have a way to tell the computer where you're going to store the information, how do you actually store the information? Well, that concept is called assignment statements. And assignment statements always have a particular format. So there's always a variable on the left-hand side. Okay, so this is the left-hand side. There's always an equal sign, all right? And then on the right-hand side, you can have a number or a string. You can have another variable, okay? And you can have an expression, like a math formula or something, okay? So for instance, name equals C, that's a valid assignment statement. X equals 3, that's a valid assignment statement, but you can't say 3 equals X. That's not a valid assignment statement. The stuff on the left always has to be the variable name. The stuff on the right has to be a number, a word, or as I mentioned a few seconds ago, you could have another variable. Okay, so those are your basic rules for what we call assignment statements. Now, these X's and Y's and whatever that are holding your information, they can hold different kinds of information. So when you are specifically saying store a person's name or store a value, you have to tell the computer ahead of time the kind of thing you're going to store in it. And these are the main ones. So int stands for integer. So numbers like 7, 0, -7, those are all integers, okay? Long is another kind of integer that hold bigger whole numbers, or as we call them, integers. Float and double, and again, I'll highlight the most important ones we're going to use in this lecture and in this course. So integer is what we're going to use a lot. Then we'll skip down to double. Float and double are the same kind of things. Those are decimal numbers, like 7.5, okay? And double is the one we're going to use. It holds larger decimals. We're going to do a lot of calculations with decimals. Money, for instance, is a decimal. And the last
variable type we're going to use a lot in this course is string. String holds people's names. Anything with quotes on them is a string. Now, are there other types we're going to use? Yes, we're going to use one called Boolean later on. We're going to use an image class type, variable type to do graphics later on. But for now, for the next 10 or so lectures, we're going to stick with those types to do those problems. Now, just to make sure you feel comfortable knowing the rules for assignment statements and variable types, let me just do a quick little recap and see if you've caught on to what I just mentioned. Okay, so here are some examples of variable names. Some of them are good, some of them are bad. So this first one here, what do you think? X9, that's good. This one here, text box 1, that actually is also good also. 2b, bad. Okay, B2 is good, but not 2b. It has to start off with a letter of the alphabet. Console beep, bad. That's a reserved word. That's a special computer command part of C#. Button.enable doesn't seem like your typical variable, but actually that's good. That's okay. We've used them before. These are control objects that we've created as a variable. Okay, so that's the first part. Now the second part is going to mix you up a little bit if you've never done computer programming before. These are all assignment statements. Some of them are good and some of them are bad. Let's take a look at the first one, okay? And if it doesn't seem too clear, let me write it over here again. I'm saying A equals 1,000. So you might say, well, that's legitimate, okay? You're putting 1,000 into a variable A. It's exactly like the rules I told you. But this guy right here makes it a no-no. Don't ever use commas when you're typing numbers in computers. All right? Write down 1,000 like that. You can write 1,000 with decimal 00, whatever. No comma. Because of that comma, this is an invalid assignment statement. You would get an error. Okay, so that one's bad, and that's how you'd fix it. X1 equals -9. Perfect. F plus G equals answer. Seems reasonable, but no, bad. Here's the problem with that one. It should be the way around. Remember, the variable that's storing the answer should be always on the left-hand side, and the right-hand side can be a number, it can be a word, or it can be a set of variables, like a formula. F plus G might be two things that hold other numbers that we're going to store in this answer, okay? So that was bad, and that's how you fix it. Text name equals Sam. Seems reasonable, but I get the impression that this is supposed to store a word. So that should have quotes on it. All right. Next one, J equals 2C. Bad. There are two solutions to this. One which I haven't taught you yet, and the other one which I have. This really should be J equals C2. Okay, because if this is another variable, it can't be 2C. It must have meant C2. The other reasoning behind this example would be that this is a math formula. Now, we're going to do this tomorrow, actually, or in the next lecture, but there is an implied that maybe it was a formula, 2 times C, like you would do in math, and that would be another solution. But this, as it stands right now, would be invalid. You'd get an error message if you ran it on the computer. The last one looks decent, but if you got good eyes, you'll notice it has a space right there. You can't have any spaces with variable names. So that says sales tax, and that's incorrect. All right, so now let's use those concepts and create a simple program to demonstrate how they work in C#. So let's click on New Project and pick Windows Form like we always do. We'll rub this out and we'll just call this storage. And then we'll press OK. Okay, so I'm just going to create a very simplistic program, but I still like to follow the rules, all right? Trying to always make sure we do this. Sometimes I'll get a little lazy, but I'd rather not. So I taught it to you this way. Let's be consistent. So form storage. And we'll add a little bit more descriptive title. We're going to call this Concept of Storage, and we'll have that as our title.
Okay, and then we'll drag a button. We might use two of them in a second, but let's stick with one for now. So we'll call that button. And we'll just put the word go on it. Actually, no, let's call it button go, and then we'll put text go. Okay, and we're ready to program. So now we're not going to spend too much time making it look pretty. Let's just get to the part where we're actually doing the programming. So here's what's going to be interesting. Now, from now on, you're going to have to declare everything you want to use in a computer program, because now we're trying to have it be remembered by the computer, and then maybe do something to it, and then print it out. So let's say I wanted to have a person's age that I wanted to work with. That's called integer. So most people, like you would say you're 10 years old, 15 years old, 17 years old. You might say you're 17 and a half, but most of the time you would give yourself's age as a whole number. Then we're going to enter your name. So your name is a word. So we're going to say string your name. And then maybe we'll say something like how much you get paid if you had a job, right? And you would usually make maybe $140.80 or something, okay, depending on your rate of pay. So that section right there is called the declaration of your variables. And I'm going to introduce another new concept. I'm going to use these two slashes, which are used to represent comments. And then I'm going to say this is the declaration of variables section. Okay, so I'm going to start declaring all these comments so that you can clearly understand. Now, comments, you can write whatever you want after the slashes. The computer only recognizes the special commands. So in here, this green part, this is not really looked at by the computer program. It's looked at me, you, so you can figure out what you're trying to do. So that's the first part. Now we do the assignment statements. And all you do there is you assign numbers to each section, okay? And you fill in, obviously, your name, not my name. And it should be an equal sign. And pay, we'll make it $130.75. Okay, so that's step 2. That step is called the assignment statements. And now we're going to display the results, okay, and then that's called output. Now, I've shown you this command, I think, once before. I'm going to add a little twist to it because now we're going to combine two ideas, but basically what we're going to use is the message box. And I'll just do it for the age right now. So messagebox.show, I showed you that before, and I'll say something like, your age is, now that's different, right? I've written in quotes a literal set of words, and then I'm going to attach it, and the way you attach stuff in C# is use the plus sign, and then age. Now, there is a lazy way out here, but I'm going to be very correct. You could go with this, and it would be basically correct. I'm going to do this other part to string, because it technically should be all one string, but it would work if you just left it as age. But stick with this, and it'll always be correct. Okay, so that's good enough for me right now. Let's give it a run. Now, you're saying, sir, what about the other two? I'm going to do those in a second. I just want to do this one first just to show you that it works. Okay, so a little processing here. And when I press this, it should say your age is 15. Okay, and the other two would be just created the same way. Messagebox.show your name is. Now this one, you don't have to say that to string because your name is already a string. Okay, so I'm glad I did this example with you. And then the last one, same idea, messagebox.show your pay is. Now this one again is a number, so you have to do the toString part. And then always don't forget the semicolon. And we'll give it a run again. Your age is 15, your name is Shirelli, your pay is $275. Now, let's focus in on this section right here, the declaration of variable section. what we've done there is what's called created local variables, okay? Which means that everybody from here to here knows about these three variables. It's almost like they all live in the same building, so everybody knows, oh yeah, I know Shirley, he's cool. But what I'm going to do as an example now to show you the difference between what are called local variables and public is add another button. Okay, now on this one I'm not going to get too formal. I just want to give you the basic idea today. We're going to discuss this over and over again throughout the course. So we've got another button here, and in this button, just for fun, I'm going to say, hey, I want to see if this building across the street knows about this guy Shirley. So I'm just going to have it go, your name is, and I'm going to type in the word your name again. Okay, so you'd think, okay, the computer sees right there that there's a variable called your name with Shirley in it, and so why doesn't it let me say it right there? Let's see. Now it's giving me this red line, which isn't good, but maybe it's good. I'll press run, and it says there's build errors. Always say no when there's build errors. Okay, and down here at the bottom, I'm going to slide the screen up a little bit if I can. There's an error warning, and I'll just make it a little bit bigger. Okay, and it says your name does not exist in the current context, which means who's this guy, your name? I don't know anything about it because these were called local variables. Nobody knew about them. So there isn't a fix, and by doing this, you make the variables known to everybody in the entire world, so to speak. Okay, so here's what you do. You basically take these declarations and you take them out of the building and you put them kind of like on the middle of the street. Now watch exactly where I put them. I put them right there. Okay, so now they're going to be known to all the different forms. All right, now let's see if that actually works. Now to test this program out, you have to realize one thing. You can't just go straight to button 1. You still have to press this button because it's going to assign the values of them. So I'm going to press here, and it's going to tell me obviously that information. And then when I press this button, it says, hey, your name is Shirley. So what's happened there is that by doing this declaration here, you've made them now what are called public variables. And the fancy word for this concept is called the scope of variables. How far do they reach? When they're here, they reach everywhere in all these other buttons that you may have on your project. When they're only in here, they're only known there. And there's advantages and disadvantages to using both those techniques, which we will discuss in greater depths as we go throughout the course. Okay, so that's the end of our little introduction to the concepts of computer storage. Input, process, output. That was the theme of our last lecture. What we're going to do today is focus in on the process part, and in particular, we're going to look at mathematical applications. So we've got to learn things like how do you represent multiplication in C#? How do you represent exponents? Okay, and then we'll learn other things like the modulus operator, which is kind of neat. And we'll look at arithmetic, like why is 5 divided by 2 only equal to 2 and not 2.5? We'll also learn this idea of casting, and then we'll finish up with a simple little program that works out your savings when you put money in the bank. All right, so let's first of all try to learn how to do your basic mathematical operations in C#. So in this little PDF file, which you should download, I've got a chart that has 2 parts, and over here on the left-hand side is your typical mathematical expression. To write it in C#, you notice that the times is represented by the asterisks. Okay, so anytime you have a formula that involves multiplication, the asterisk replaces the multiplication sign. Division is represented by a backslash. So 6 divided by 3 minus 5 times 3 would be 6/3 minus 5 asterisk 3. Okay, exponents, you're on a different track here now. With exponents, you have to resort to a special class called the math class, okay? Then .pow, and that P should be in capitals. So to represent 7 to the power of 3, you write math.pow 7, 3, where 7 is the base and 3 is the exponent. This one here always throws off students if they're not very good at math, Let me just give you how a lot of students would write this 5 plus 3 all divided by 4 minus 5. Okay, most of them at first glance would write like that. There's only one problem. You have to remember your orders of operation. So if you wrote it like this, what the computer would do is it would work out the 3 divided by 4, which would be 0.75, and then go 5, subtract 5, which would be 0, and you would be left with 0.75. But that's the wrong answer, okay? 5 plus 3 is 8. 4 minus 5 is -1, so the real answer is -8. So what you have to remember is your orders of operation. And to force the computer to do the entire top part divided by the entire bottom part, you have to use brackets. Okay, so brackets are really important when you force the computer to do certain things in a certain order. Okay, so really important example. Last example is a really crazy one, just to show you that you can do all kinds of neat things with formulas in C#. So here is the equation, and then this is how you write it in C#. So x squared would be math capital P power x comma 2, okay, minus, and notice the heavy use of the brackets. I'll try to emphasize it. See that bracket there and that bracket there. That's the top part, right? So it's x plus math.pow 3 comma 4, and then another set of brackets, 2x plus 1. And again, another common mistake students make, because when you do math, usually you assume a lot of things, but you can't assume with computers. So when you say 2x, you know it means 2 times x, but the computer doesn't. So you have to force yourself to write the asterisk in the middle. Okay, just for fun, let's try one of these just to make sure you understand how to write these as C# mathematical expressions. So let's just do the first one, and then the other ones you can try yourself too. So 6 divided by 2, remember it would be 6 divided by 2 like that, plus, and here's a common mistake. You might say, well, this is easy, just go like that. But you have to remember that you take for granted that right beside the 4 in the bracket is an implied multiplication. You can't just imply it in C# or in any computer programming language. You have to physically write it in. So 6/2 plus 4 asterisk 9 minus 3. And that would be the answer to that. Okay, I'm going to do a little bit more doodling and some things that are kind of funny, but it's true for quite a few languages. Let's say you wanted to work out some calculation, maybe stored into a variable. But let's just pretend right now we're just going to show you the math. So 5 divided by 2. Now this is an integer. And 2 is an integer. So when you take 5 divided by 2 to C#, the answer is 2, not 2.5. It basically chops off the decimal because an integer divided by an integer to C# implies it's an integer. If I had done just this one simple thing, 5.0 divided by 2, I would get 2.5. Okay, so integer division, you're still going to get an integer. Okay, so you have to do this if you want that particular answer to come out. Okay, now there's a problem. What if you have variables and you're dividing and you want to work out decimal answers? Well, that's where this idea of casting comes into play. Now, I'll do it with the actual numbers right now. So I'll type in the word cast. Okay, and that's the concept we're going to learn. And so if you had 5 divided by 2, to force this to be 5.0, you would go like this, double with a bracket. That's called casting. Okay, so what you're forcing now is you're forcing that number to become like 5.0 to get your 2.5 answer. And now I know you're going, well, why don't you just write down 5.0? Because what happens when we start doing more sophisticated programs is that we don't have a 5 there or a 2. We might have an X, and you might have a Y. And these are variables that store totals that you're working out. So now you can't just go in there and put a 0.0. So now that you know how to cast to force the answer to be a decimal, that's where this comes in. Okay, so even though you say, well, this is useless for here, I could try to sneak in a 0 and I'd be happy. But in computer science, you don't always work with numbers, you just work with variables a lot. And so this will force the answer to come out to the proper way. One more idea. Double. Okay, and you're going to cast it. But this is also in brackets, 5 divided by 2. Now, what do you think that answer is? Well, the answer is still going to be 2. It's not going to be 2.5 because the computer does the brackets first, and 5 divided by 2, because it's an integer divided by an integer, is 2. And then you double that, but it's not going to make it 2.5. It's too late. It got chopped off before double had a chance. And this one up here, double is right beside the 5, so it'll force that to be 5.0, or double is right beside the x. But when you put it in brackets, it does the inside part first and then doubles it. Okay, so kind of weird stuff. One more thing dealing with division. Did you ever do this in elementary school? 7 divided by 2. So that goes in 3 times, remainder 1. Okay, because 3 times 2 is 6, and you add 1 more and you get 7. How about 17 divided by 3? Well, that would go in 5 times, remainder 2. So there's a cool way to get the computer to do remainders in C# also. 17% 3. This is called the modulus operator. And when you work that out, the computer will write down 2 as the remainder. Okay, so a bunch of nice little cool things to show you how you use math in C#. Let's finish up this lecture with a simple example which will use some of these ideas that I just taught you. And we're not going to type this one in. We're going to use one of my demos for this one, and then you can experiment with it. Now, let me go back up for a sec. When you downloaded the documentation and the demos for this particular set of lectures, you should have one called Enter Output when you unzip it. And inside of there are a bunch of programs that we're going to look at. Right now, I want us to load in savings. Now, this program uses the basic forms that we've been taught. Okay, it has a basic form with some labels. Okay, these are text boxes. And then we've got a compute button and an exit button. So let me just run it for a second just to give you an idea what it does. Simple program. Basically, it says type in your weekly deposit. So let's pretend every time you made money at your job, let's say you made $200 for the week, you put it in the bank, and you want to know, well, if I put $200 in the bank every week and I do that for 40 weeks, what's my total savings going to be? And it says $8,000. Okay, and then exit out. So what's going on behind the scenes? Well, first of all, let's make sure we understand that when you do a program like this, you got to make sure you name everything. So that's got to have a name. That's got to have a name. That's got to have a name. Those are important. These labels, if you don't name them, it's not a big deal. But these boxes are really, really important because we're going to use them in our calculations. Let's see what we named them. So this box right here, we named text deposit. This one right here, we called text weeks, okay? And the last one right there, we called text total. Now remember those are important. So when you do programming, if you don't have those named properly, you won't be able to tell the computer what to multiply to what and then work out the answer. Okay, it's time to go into the underground. We're going to double click on compute. And like I taught you in the previous lesson, first thing you should do is declare all your variables. And these ones have been declared publicly. Okay, they're outside of the main button. Okay, so we've got deposit, weeks, and total. So those are going to be places that are going to store answers in the boxes. Okay, now this is the new stuff. Okay, that you have to understand. When you have a text box,
and you say that I'm going to put in $200, a text box actually takes that number and puts quotes on it. But the only problem is we cannot do math on quotes. Same with this one called weeks. When I type in the weeks, and I type in that I worked for 40 weeks, it actually is stored in the computer's memory with quotes, like that. And then we're almost ready to do the multiplication, but you can't times 200 with quotes on it to 40 with quotes. So you have to use, and there's several techniques, and actually I'm going to show you the best one in a second. You have to use something that takes the quotes off of these. And there's a word called convert to int32, which means convert it into an integer. Okay, and then what that does is take the quotes off, and now it puts the 200 in a special memory cell right there. This line right here does the same thing to 40. It takes the quotes off of them, and it puts it into a memory cell called weeks. And there goes the 40. This line right here multiplies those two answers together and puts the answer in here in a box called total. And obviously it's going to be $8,000. Then what we do is kind of like the reverse. Now that we have the $8,000, we have to put it back into a text box that's supposed to have quotes on it. So we need to take this 8,000 and put it back into here. But this 8,000 does not have quotes on it. So this is how, and one of the ways, I'm going to show you another way in a second. This is another way to put quotes back on. So it's kind of funny, right? So in 1 second, you're taking quotes off because you have to do math on it. And then 2 seconds later, you're putting them back on because you have to put it back into a text box. But there is the process. To really make you appreciate what's going on in this program, I'm going to do this really cool thing called stepping. And to do stepping, you press F11. And what it does is kind of in super slow motion shows you all the little commands that are going on behind your back when you run a computer program. And right now I'm pressing F11 like crazy. Okay, so don't worry if you don't understand all this, but this is like the old school way to put all those controls on your screen. And you heard me mention that in a previous lecture. So I'm still pressing F11, and this is all going on behind your back when you press run. And it takes like a second. It's taken me longer because I'm doing it in super slow motion. Okay, and then we finally get to screen. And then I'm going to type in 200, and I'm going to type in 40, and then I'm going to press compute, and then I go back into the underground. Now this is a really cool part. This is where you start to appreciate what's going on. When I hover over this word text deposit, notice that the text has 200 with quotes on it, just like I told you. Now I'm going to continue with F11, and let's see what's in this variable called deposit. Well, this command right here, convert to, took the quotes off. So notice how deposit has 200 without the quotes. Same thing here, weeks, 40 with quotes. I'm going to press F11, and then the quotes come off it and it's stored into the regular variable weeks. And then we do our math. We get our 8,000 without quotes. And now the moment of truth. We've got to take this 8,000, which doesn't have quotes, let this line do its work, convert to string, and then when we press F11 one more time, the text box has 8,000 with quotes on it. So there's the whole process from beginning to end in the underground. It's kind of a cool way to explain stuff to students the first time they start to appreciate what's going on behind the computer screen. Little bonus action here. I actually am not crazy about this command, and usually when I teach it at the beginning, I like to do an even simpler command. int.parse does the same thing, but it's a lot shorter. And same thing here. int.parse. And all that does is take whatever is in quotes, take the quotes off and store it into an integer. Okay, so that's good. Same thing here. I think I've shown you this one before, and I'd rather that you go with the one I'm going to show you. So I'm going to go right to the end here. Dot to string bracket bracket. So I like this way a little bit better. And it's shorter. So int.parse is how you take something that has quotes, that's an integer,
takes them off, and then puts it into here just as a regular number. And there it is again. And this is how you, and you've seen me use this one before, take an answer, which would be obviously in this case 8,000, and this puts the quotes back on. Okay, so it's just a little bonus action, and I better prove it to you, so to make sure you don't think I'm lying or anything. So we'll run it again, and we'll put in 400, we'll put in 20, and there again is our 8,000. So thanks for watching, and on to a bit more math. Welcome back. In this lecture, we're going to focus on one application. What we're going to try to do today is create a program that works out the averages for a set of 3 marks. And we're going to use a slightly different technique. Instead of using sort of a form with text boxes and buttons on it, we're going to use this neat new idea called an input box. And actually, we're going to beg, borrow, and steal it from Visual Basic, which isn't really the language we're learning. We're learning C#, but Visual Studio has a neat way to take things from other languages and incorporate it into C#. So that's what we're going to start doing today. And then I'm going to give you a couple of problems to try. And, you know, unless you start getting your hands dirty and trying some of these and not just watching me, you're not going to become a good programmer, okay? So I'm going to leave you with a couple of problems to try today also. Okay, let's get ready to program. Start up Visual Studio, and then we'll press File, New Project. And we'll call this project Averages. And like we always do, we'll come over here to Form, rename it to FRM Averages. And we might as well add a title too, right up here, where instead of Form 1, we will say Averages. And basically, it's just going to have one button. So if you're saying, well, where's the little boxes where you're going to put in the people's marks and stuff? We're going to do it slightly different, which is going to be kind of cool. I'm going to have just one button, which I'll put right in the middle of the screen. Okay. And like we always do, we're going to call this BTN Averages. And then we'll put some text down here to say determine averages. And while I remember, okay, I'm going to click on the form, and we're going to make the screen position right off the bat go to the center. Okay, now what's going to happen is when I run and I press there, I'm going to get this little box to pop up. And there it's going to say, please enter a mark, and you're going to type in 70. And then I'm going to have another box pop up. So I'm going to do this 3 times, and each time I'm going to enter a mark. So this is a totally different way to accept marks. This kind of thing is going to be called an input box. And it's originally from another computer language called Visual Basic, VB. So what we're going to do is we're going to beg, borrow, and steal it by referring to it. And I'll show you that in our next step. Okay, so here's how we're going to take a command that belongs to another language that's part of the Visual Studio Express software and incorporate it into C#. So what you do is you go up here to References, and you right click and you click on Add Reference. Now this might take a few seconds. I've already done this before I made the video, so this popped up really fast, but it might take a minute or 2 on your computer. And right there it says Microsoft Visual Basic. I'm just going to put a little check mark there and press OK. And now it's going to incorporate the core functionality and some of the special commands that are part of Microsoft Visual Basic. So like, big deal. How am I going to use it? Where am I going to put it? So it's time to go into the underground. Let's double click on the averages. Now think about this. We're going to ask the user for 3 marks, okay? So integer mark 1, that's going to be our first mark. Integer mark 2 is going to be our second. Integer mark 3 is going to be our third mark. Now, when you work out averages, you could get decimals, right? Like what if we had like somebody got a 70 and a 75. If you averaged them together, you'd get 72.5, right? So decimals are possible. So average is going to be a decimal. Okay, and I think that's all we need in terms of the variables we're going to use in this question. Now, we're ready to ask the person 3 times, what's your mark? What's your mark? What's your mark? So when we ask the person their mark, we're going to store their answer into mark 1. Here's the crazy one now. Just hang on for the ride. Slow down the video when you see this. Microsoft. So we're going to take stuff from Microsoft dot. And now I'm going to click. I don't want to type anymore. Visual Basic dot. And I'm looking for interaction. There it is right there. Dot. I'm looking for input box. There it is right there. And now we use a bracket. And now we're going to prompt the user to please enter a mark, comma. The next thing it's asking for is kind of a title to the input box. And we're going to give it a title. We're going to call it averages, comma. Then it's looking for a default response. Well, I've got nothing to say, so I'm going to put 2 quotes stuck together, which means nothing, comma. Now this part's a little bit tricky. What we're going to do is we're going to tell the computer where to place the input box in the screen. And there's this idea in graphics that we haven't done yet that decides that the screen actually starts at this corner up here. And we're going to tell it how many pixels over to go and how many pixels down to place the little input box. Okay, so that's kind of weird to understand, but just appreciate the next 2 numbers I'm going to do tell the computer how much to move over. So I'm going to move over about 120 pixels, and I'm going to go down about 120 pixels. And I'm basically done this command, but let's see, is it getting mad at me? What's missing? What do I need? It's getting mad because it's saying, listen, this is going to return something that's a string, has quotes on it, and you're trying to put it into mark, which is an integer. So if you remember, and I got to watch this, I'm going to try to widen this a bit here. We're going to, in a second, wrap this entire humongous line from there to there. We're going to wrap it in that command we learned last lecture called int.parse. And what that will do is take whatever this gives us and takes the quotes off. Okay, so hang on. Okay, so we got to go like this. Int.parse bracket, and I'll go way to the other end. Just past that bracket and another bracket. Now, there's a little trick that programmers use. If you're wondering, well, did I get the right number of brackets? Add them all up. If there's an even number of brackets, chances are you're probably doing it right. If there's an odd number, you're missing one either at the front or the back. Now, I don't want to type this in again. So I'm just going to copy and paste it 2 more times. On the Windows machine, I just press Control-V. Now, got to change this though, right? This is the second mark and this is the third. We're just about done this program. Now before I go on to the last part that does the math calculations, I always get nervous after I do something complicated like that. So I'm going to do a save all, just so I don't want to lose it. And just for fun, I want to see if this actually works. When I press this, yes, this pops up. But you notice it's way up here. So I could move it a bit. But anyway, that's what this command right here, this interaction input box, makes pop up. There's the word average. That came from the second little thing in the bracket. And then I type in a mark, pops up again, type in another mark, and one more, and it didn't do anything. Well, because I haven't done the actual math to do the calculation yet, so that's what we're left with as our last step. Okay, so now, how do you do the math for the average? Well, let me play dumb for a second and tell you the wrong way, and then hopefully you'll be able to figure out what I'm doing wrong. So mathematically, that sort of seems right? You add up all the marks and you divide by 3 and you store it in here. But there's two big mistakes. First of all, remember your orders of operation? Sometimes in school they probably called them Bedmas rules or Pedmas rules. The computer's only going to divide that one by 3. So if you got a 70 on a test and a 70, that's 140. And let's say you got a 90 on that one, which would be 90 divided by 3 is 30. Are you telling me your average would be 170? Absolutely not. What you forgot to do was put the brackets around the whole thing. So don't forget that when you do your math. Okay? Now, what else do you need? Well, remember, if this works out to a decimal, I want to cast it so that it gets stored there as a decimal. So what I'm going to do in front of this is put the double word. Okay? And we're down to the home stretch. We got to print out an answer, right? So messagebox.show your average is, then we attach it, so you say with the plus sign, average dot to string. And then don't forget that stupid semicolon. It always gets mad if you don't put that in. Okay, let's do another save all, and let's see if this actually works. Okay, so first mark will be 56, 57, and 60. Oh, look at all those decimals. That's pretty ugly, but I think that makes sense. That probably is the right average from the numbers I typed in. Seems reasonable. Now, can we fix those ugly decimals? Yes, next lecture. Okay, next lecture we'll learn how to format numbers. We'll make currency so it has dollar signs. We'll have these maybe to 2 decimals, maybe to 1 or whatever you want. But that's the basic setup of the program. Little bonus action here. I just found out something that's new to this version of Visual Studio. As I was typing in the input box, you notice when I press commas, it always prompts me what to do next. So it had here the positioning. But then I read here, optional numeric expression specifies in TWIPS the distance of the left edge of the dialog from the left edge of the screen. If you omit X position, and then you can't see it now on your screen, it says the dialog box is centered horizontally. I like that. All that means is basically that if you don't put in the last 2 numbers trying to guess roughly where you want that input box to show up, and I had it coming out the left-hand side, I didn't like that. If you omit those last 2 numbers, automatically it'll put it right in the middle of the screen, and that's actually perfect. Just to show it to you, here's what happens. So you've got your box, and look at it, right in the middle of the screen, perfect. So this guy gets an 80, 90, and a 77. And it's an average of 82. Perfect. Okay, so that's kind of good. Actually, I like that better now that I know that. I never knew that was possible before. Okay, another little bonus for you guys. When we do these programs together, and I do them on the screen, and you type away, maybe you don't get them to work sometimes. Okay, and that happens to my students before when I used to be a high school teacher. So every single program I do with you guys that I type on the screen and I sort of work through, try your best to do it. Try to figure out if you get a mistake. But if you don't get it to work perfectly, don't worry. I have, when you download all the resources for the particular lecture, I have every single program that I'm going to do with you guys on the computer. So let's say you didn't get this one to work. All right, so when you downloaded and unzipped the resources for today, you would have gotten enter output. Inside of there, hey, there's the average program. This is the one that I made previous to the one that you saw me do on the screen. And so you can load that one in. Look at the code, okay, and you notice that it's got the 200s in there, and it's got basically the same stuff I did with you guys. And I actually got a little extra in here, actually, that I didn't teach you. Watch what this does. So very quickly, I will type in some marks. Prints out the average mark is on one line, and then underneath it, it prints out the result. So that's this thing here. Now, we're going to talk more about this in the course as we go along, but this makes a new line, which is kind of a cool command. All right, so anyway, if you don't get the program to work out, always check my demos for that particular lecture, and 9 times out of 10, I will have a copy of whatever I was doing that day in there, so that if you don't get mine to work out when we type it together, you can refer to that. Now, it's time for you guys to practice, okay? If you don't practice, you're not going to get good at this stuff. And as part of the resources for today's lecture, you also have today problem sheet. I called it Mathematical Programming Problems. And some of them are really basic. I wouldn't do them all. But the 2 that I really, really want you to try, and in my next lecture, we'll start off by taking them up. We'll go through them to make sure you knew how to do them. I'd really like you to try question number 6, okay? And I would try to do all these questions using the input box, okay? That's the one we just did a few minutes ago. It's kind of a cool new technique. So this one says, write a program which accepts an employee's name, rate of pay in hours, and then works out the gross pay, taxes, and net pay. Okay? And the number 7 is a bit of a challenge. All right, it's going to use a command I taught you the lecture before this one. And it says, a vineyard measures the amount of wine in its storage tanks in gallons, but it must ship the wine in barrels. There are 42 gallons in a barrel. Write a program that you will accept as input the number of gallons in the tank and display a message box which shows you the number of barrels that can be shipped and the number of gallons remaining. So give these honestly a try, and then the answer will be in the next lecture. Okay, thanks for listening, guys, and hopefully things are going well. Hi, guys. Welcome back. And as promised, what I'm going to do in this lecture to start off is take up some of the mathematical problems that I left you with in the last lecture. In particular, I'm going to take a look at questions number 6 and 7. After we finish that, what we'll do is take a look at one major application. We're going to take a look at a car dealership application using all the knowledge we've learned so far on math applications. Okay, so let's focus in on question number 6 first. So it says, write a program which accepts an employee's name, rate of pay in hours worked, and then works out the gross pay, the taxes, and the net pay. Okay, so one of the little tricks I want you guys to start getting used to is after we finish a question, whether you just take my demo or you actually typed it in with me, why don't you use that as the guide to answer some of the questions I may leave you with for practice. Okay, so what I've done here is I know I've got this question from the last lecture, and the reason I want to stay in here is instead of me trying to grab the reference to the input box again, I'm just going to copy and paste this when I need it. Okay, so that's what we're going to use today. Double click on number 6 here. And so you got to ask for the person's name. So that's going to be a string. You're going to ask for their hours. And you could work 5.5 hours, okay? And so that's why I call it a double. So that's decimals, right? Rate of pay, I'm also going to make into a decimal. And now we've got to work out the gross pay. Okay? And we've got to work out the taxes. So you notice I'm making everything double now. And we got to work out the net pay. So I think I have everything I want. Okay, now it's time to input via the Microsoft Visual Basic input box some of this information. So I'm going to cheat a little bit. I'm going to grab all of this from up here, and I'm going to copy it and put it down here. So obviously the first thing I'm going to ask for is the person's name. So I'm going to say your name equals, and I don't need this whole thing because in this particular example, first of all, I don't need the mark for sure. I'm not taking a number and then having to convert it into something else. So it's a string. Okay, so just that's it. Okay, and obviously I should change this to we're working out net pay. And I'd enter a mark, but enter your name. Okay, and that one's good. Next one, you're asking for their hours. Now, hours could be decimals. Also, I'm going to take this again, but we're going to make a small change to it in a second. First of all, enter your name is going to change to enter your hours. Okay, but more than that, and you can see it's turning red on me because it says can't explicitly convert string to a double. So this has quotes on it when you get the answer, and you're trying to put it into hours, which is going to be a decimal. So you do something that I haven't shown you before. Instead of int parse, you have double parse. Isn't that cool? Okay, you put a bracket there, and you go all the way to the end, and put another bracket there. Okay, so that one was important. I'm going to widen this just a bit so you can see it a little bit better. And I'm going to copy and paste this one more time. This one's going to be pretty close to what I need. And so now this is the rate of pay, and it's going to be equal to, and I'm going to paste, and obviously I'll change a little bit of it. So we're going to rub out this, double parse, please enter your rate of pay. All right, now we're in the home stretch. We've got all the information we need. Now it's time to do some math. So gross pay equals hours times rate of pay. Taxes equal gross pay times, and just to remind you, it says that the taxes are supposed to be 20% of gross pay. Okay, so that means we're going to times it by 0.02. All right, and we'll tidy that up just a little bit. Not that it's wrong, but just to make it look nicer. And then your net pay is going to be equal to your gross pay minus your taxes. Okay, now, if you were doing this as a formal question, I'd want you to print out every single thing, all the steps, the person's name, the hours, the rate of pay, the gross pay, the taxes. For this example, I'm just going to print out one just for the sake of making it a little bit shorter, not too long-winded. So I'm going to have a message box dot show your net pay is, okay, and we'll attach net pay. Now, I'm going to give you a little primer, a little bit of a hint on what we're going to do after this homework is taken up today. And we're going to learn how to format stuff. And in this particular example, because it's money, notice how I use that to string, but I've added this thing in brackets with the C, and that means it'll display it with currency. So just for fun now, let's see what comes out. Okay, so we're pressing this one. What's your name? CC. How many hours? So I worked 10 hours, and I'm getting paid $20 an hour. That'd be pretty good, actually. And the net pay is 160. So it's really 200, but then you take 20% of 200, which is $40. So that comes off of the 200, so your net pay is 160. So that would be correct. Okay? So that's the answer to the first question. The second question is a bit more challenging. Okay? Let me try to doodle a little bit on the screen here to give you an idea what it means. Let's pretend you used 85 gallons, and you want to know how many barrels that would be and leftover. Well, supposedly 42 gallons goes into a barrel. So what you would need to do is take the 85 and divide it by 42, and that would go in twice, I know for sure, because 42 times 2 is 84, and there would be one left over. So it would take 2 barrels, and there'd be a gallon left over. So that's how you do it mathematically. Now we're going to do that in computers using a special thing I taught you before, this little percent sign. That'll do the remainder part. And to get the 2, all you do is do integer arithmetic. Okay, so let's go into problem number 7. I've already started it off. You're basically going to need to ask the person for the gallons they have, and you're going to work out the barrels and the leftover. Okay, so there's no decimals in this one. Everything's going to be whole number answers. And so you first of all ask for obviously the gallons, and this one is going to be the barrel question. So I'm going to type in the word barrels there. Okay, so let's do the math. To figure out the number of barrels, what you're going to do is you're going to take the gallons and divide it by 42. And remember, when you take an integer, and gallons is an integer, and you divide it by an integer, the answer is an integer. So that's why when I said 85 divided by 42 is 2 point something, right? But you're only going to get 2 for the barrels. Okay, now the leftover. The leftover is going to be equal to the gallons percent sign 42. And that'll work out what we call remainders. And now we're ready to print out our answers. So message box.show the number of barrels is, and then you attach the barrels answer to string. And then we're going to attach a bit more. We're going to add a little space, and we're going to add the words and the leftover is, and we'll type in the word leftover dot to string. Okay, let's see if it works. Enter the gallons, 85. So the number of barrels is 2 and the leftover is 1. So there are the solutions to those two questions. All right, let's finish up this lecture today with a nice big application that incorporates a lot of the mathematical knowledge we've learned over the last couple of lectures. Now, this one we're not going to do together. This one I've already got pre-done, and it's in your resources in the Enter Output folder. Okay, let's go in there for a second. And it's called Price Quote. We're going to load it up and take a look at it. We're going to analyze it, and then I'm going to give you a little problem to try to finish up today's lecture. So let me just run it for a second. So here is one. It doesn't use input boxes this time. It's basically back to the form with text boxes, radio buttons as such. So let's say you were purchasing a car from a dealership, and they had 3 models. Okay, when you wanted this particular model, it cost $10,500. This one costs $15,000, and this one costs $21,000. So that's kind of cool, right? As you press these, the price is changing here. Now there's some standard packages, and there's deluxe with air conditioning. Standard package is an extra $2,000. The deluxe adds $3,000. Now, when you buy a car, sometimes you have an old car to get rid of. So let's pretend they were going to give me $500 for my trade-in. And now we're ready to calculate our final price. And this little pencil here is going to be like a button, and it works all the numbers. Now, sales tax depends on what country you live in and how much, so we'll take a look at a number that I made up for sales tax there. But there's our grand total. Okay, and then new clears it out. Okay, so how do you code this type of question? Well, first of all, obviously, you have to create all the user interface, okay? And most of these are text boxes. We've got some labels here. We've got obviously radio buttons here. And this thing right here is a picture, but anything can be a button. So it's going to be kind of cool. You could make a picture into a button. Anyway, let's take a look at the dirty work. Now, the first thing I'm going to show you is something brand new. We need to have the computer remember the prices for all these different types of things. So I'm going to double click, and I'm going to go into the underground. Now, this is different. Never seen that before. When you double click not on a particular button or picture, but on the form, you go into what's called the form load event. And basically, this is something that loads as soon as you press run. You don't actually do anything. It gets done all for you automatically. So here are all the variables I'm going to use in this question. These are the packages for the different types of cars. And then, of course, we've got other numbers we have to worry about, the base price, the package, the trade-in. So those are all variables that the entire world knows about. Those are called public variables, right? Then in the form load, we actually store the prices of some of those numbers that we need to know ahead of time. We start our totals off at 0. That's kind of proper computer programming. and then we're ready to roll. Now, what do you mean we're ready to roll? Well, when we press this right there, what I want to happen is I want the number for that particular price of car to go in here. If I press this one, I want that price to go in there. When I choose these ones, I want that price to go in there. How do you do that? Well, when you double click, what you're going to do is you're going to take the base star price, convert it to currency, and put it into that text box, which is this spot right in here. Now, why do I do two steps? Well, because one step makes it look pretty with the dollar signs on it, and this step stores it in the computer's brain as a pure number, because you can't add things that have dollar signs on it. So we've basically got one step to make it pretty, one step for the real math. And that's what I do for every one of these. Exact same line, okay, except it's the base Comet price. It goes in there. And then, again, same thing here. And then when I'm in these ones, same thing. So I'm basically repeating the same steps. I'm taking the raw price, putting it in with dollar signs, and making it look pretty, and then putting it into the raw without the prettiness, without the dollar signs. Okay? Now, when it's the moment of truth, this is an image. If you double click on it, it's going to take you into the underground for that picture, and here is the code for this. Now, first thing is that this trade-in is in a text box. So what we have to do is convert it to just a regular number. Then here is the math. The subtotal is the base price plus the package minus the trade-in. In this particular case, we had 14% sales tax, and then we do our totals. Now remember, these are pure numbers. Then we finish off by making them look pretty. So we take these answers and we put them back in the text box. Now that was a pretty fast explanation. So to really understand how this program works, what I want to do right now is do one of my favorite tricks, which is to step through the program. And basically what I'm going to do in super slow motion is I'm going to press F11, and this is going to show you what's happening in the underground. Now I'm going to skip this first part fairly quickly. I'm just pressing F11 a whole bunch of times until we get to the actual program. I'm going to slow down in a few seconds just to prove to you that it does that form load where it copies all the values and stores them into the variables. So we're just about there. Okay, so all this stuff is going on behind your back. So there, we're ready. And now look what happens now. It goes to form load and it stores all those numbers in memory. And then it actually starts the program. There it is. So let's see what happens when you press this little radio button. Okay, I'm in the underground again, and it's going to take the price of the base star car, which is $10,500. It's going to convert it to currency, and now look what's in the text box. $, $10,500. This line does a pure $10,500 and stores it into the base price. Okay, so that's all that does. Let's pick Deluxe. Same idea. Takes the Deluxe price, which is $3,000, and stores it in here as $3,000. And this takes the raw $3,000 and stores it into package. Okay. Now, trade-in, I'm going to put 100, and now we're basically ready to compute. So we're going to press that little picture of a pencil, and we're down to the last stage here. So the trade-in was 100 with quotes on it, and this takes the quotes off and makes it a regular 100. This does all the math. 10,500, 3,000 minus 100. Okay, and when we work it out, it's 13,400. We work out the sales tax. We do the total. Now, remember, these are all ugly numbers. We got to make them pretty again. So what this line did is took the 100 and put dollar signs on it. This took the subtotal and put dollar signs on it. And after we're totally done, here's what we get. That screen right there, okay? Last button I want to show you is the new button. All the new button does is wipe out everything, put it all back to like zeros or nothing. So the way you make those little radio buttons go back to nothing is you use .checked equals false. Okay, and then it puts them back to nothing. And then the last part is those text boxes. The way you put them back to nothing is you make them equal to 2 quotes stuck together. 2 quotes stuck together means nothing. And once you're done and you go back to the screen, it's all back to 0. Okay, time to take a deep breath and sort of take in all the different concepts we learned. The second half of last lecture was pretty intense probably for some of you. So what I want to do is first of all recap that and give you a nice little practice problem to try today. So as a little recap, what I'm going to do is show you another application similar to the car dealership applications I showed you in the last lecture. And these all are in your demos. And the one I'm going to look at right now is called Pizza. Now, when I run it, it has the same kind of look and feel as the car dealership. You've got radio buttons here and text boxes. When you press these, and these are the different sizes of pizza you can order, the price shows up here, and then the total shows up here. Now watch this. If I pick veggie, notice how this plus that equals that, and then if I order 2 of those veggie pizzas and do a calculation, it prints out the total price of all the pizzas. And then we have new order. So it has the same look and feel as the car dealership. And what I want to do right now is give you a nice little recap of the ideas from the previous lesson, but with this example. And then after we do this, I'm going to give you a little break. I'm going to give you some sample sort of test questions to try, and then a program. And then we'll stop the lecture, give you a chance to do it, and then you can press it and watch me take up the solutions. Okay, let's take a look at, first of all, how I did this one. So again, the first step would obviously be to design this whole user interface, make the radio buttons, put them in group boxes, design all the text boxes and everything else. Now, if you remember from the last lesson, if you double click, not on any of these particular things, but just on the form, you go into the underground into what's called the form load. And in this particular example, we've got different size pizzas, different types of pizzas, and then all the math calculations we have to do. The base price, the surcharge, the subtotal, the tax, and the total, and then the grand total. Okay, so what are all those numbers and how do we set them up? Just like the last example, okay, I'm trying to be consistent here. In form load, what you do is you take the prices for everything that you're going to use in the particular application and declare them and store them right there. So when you press run, all of these calculations, these numbers being assigned are happening behind your back. Okay. Also, we need to initialize these to 0, just to start them off at 0, and same with the text quantity. So this all happens in form load. Okay, and these are your variables, and these variables again are public. They're known to everybody. All the different buttons and everything else know about these. Okay, now let's do a couple of sample calculations so you understand the mechanics. When I click here on small, I want the price to show up here, but a little bit extra. I want the total to be here. So if I press small and it's $7 or whatever it happens to be, I want 7 to go there and then 7 to go here. Now, when I press stuffed crust and whatever that extra charge is, let's say it's $3, I want $3 to go on there, but then this 7 should change to a 10 because 7 and 3 is 10. Okay, let's press one of these and see some of the mechanics behind this. If I double click small, as you saw in a previous example, a number of things have to happen. One thing is the raw value of small, which is $4.99, gets saved into the base price. And then this line right here is the pretty stuff. Instead of saying just $4.99, I want it to say $4.99. So 2 steps always happen. The raw step and then this. What makes this program so cool is that not only does that $4.99 go in here, but it goes there. And like I said, if you press this, those 2 numbers get added up to this. So every time you click on this little button, this extra thing has to happen too. It has to take the base price plus the basic surcharge and work out the total. And again, make the total pretty. Now I know what you're saying, basic surcharge, where is it? I haven't done it yet. Well, if it's not there yet, it's 0. Well, when is it there? Well, let's pick stuffed crust. There, it's right there. That's your basic surcharge. Okay? And then it also works out the total and prints it out to make it look pretty. So you'll see now that this one has 4 steps. It's a bit even more complicated than the car dealership one. So each one involves 4 steps. So let's take a look at medium, just so you understand it. The medium raw price goes into base price, and then the surcharge plus the base price get added to total. Again, this is the pretty stuff. This puts the dollar signs on those values. When all these calculations are done, you press calculate, and what it does first of all is figure out how many pizzas you want. So this value in here, which is a string, gets put into just a pure number. Okay, we times that by the total, and that's your subtotal. Okay, in this particular one, I assumed that the tax was 14%. We convert it to currency and put it in the tax. Then we work the grand total, the subtotal plus the tax, and convert that into currency. New order, like I did before, the way that you uncheck all those little radio buttons is you make them equal to false. And then this one basically puts anything you need to 0. It wipes out everything that's in the text boxes. Now remember what I told you. The way that you make these go back to nothing is make them equal to 2 quotes stuck right together. And that's called a null string. Okay, so when you're looking at this and you're going, why is he doing that? What that is a way to make the text box go back to nothing. So again, one more time. Large pizza, veggie. I'm going to order 3 of those. And new order wipes them out. And then exit, which we haven't used recently. Let me just make sure you understand how exit works. This dot close. So what do you think? You think you could handle this yourself now? Well, what I'm going to do now is I want us to take a break. Might be a 2-day break, might be a 10-minute break, but I want you to try to go through some problems. Okay, and what I have here is sort of a pretending quiz. All right, it's got some multiple choice questions that I'd like you to try to answer. We'll take them up. You can stop the video and then we'll come back, we'll take them up. And I also want you to try this problem all by yourself. Now, as you know how I work, this answer is actually in your demos, but don't cheat. Don't look at it yet, okay? I want you to try to make this program yourself. So this is for a fictitious cafeteria, and what it's going to do is it's going to have this design, and it's going to have a number of sections. And from the appetizers, you can pick a soup or a salad. So if you pick a salad, I want that number to go in here, 250. Then you go to the mains. Let's say you pick lasagna. I want $11.75 to go in here. Okay? And then from refreshments, let's say you pick a pop. I want $1.25 to go in here. Okay? So it's a lot like the pizza one I just showed you and the car dealership. When you press calculate bill, I want all of these right there, the total. I'm going to, in this example, say the tax is 13%, and then the grand total. And then, of course, new order wipes everything out. So give it a try. It might take you a couple minutes. You might come back in a couple of days. And what we'll do, I'm going to stop right now and then get you to work. And then you can restart the lecture. The second half of this lecture will take up everything that we've got in this problem sheet. Okay, welcome back. So what do you think? You think you know how to do all these answers? Let's take a look at the correct solutions. So first one says, which control will you use to enter your name into a form? So anytime you have to enter information, the best way to do it is with a text box. Okay, so that's the right answer for that one. Which property manages the text displayed inside a label control? So you know when you have titles on a program and you want to put something like maybe your name or something like that, which property does that? Well, that's the .text property, okay, which is that one right there. This one I didn't really talk to you about too much, but when you're moving from control to control, you're moving like the focus of the program. And the way that you can do that is with the tab key. Okay, let's slide down a bit. Number 4, if you want to include more than one group of option buttons, and option buttons is another name for those is radio buttons. Okay, those are buttons that you have a choice of. You need to put each group into a separate form, frame, a separate group control. So when you want to have a bunch of stuff here with radio buttons that control something, and then these ones have nothing to do with the top one but control something else, you want to make sure you put them in a group control. The syntax of an assignment statement, which means what's the basic format of an assignment statement. So is it object.property equals value, form.object, property.object, value? This one right here, object.property. So you have a text box, so that would be the object, txt sample dot property would be text, let's say, equals, and then you could make up something. Okay, so the answer is 5A. Next one, which assignment statement will display 40 in a control named label hours? Okay, so it's this one right here. Okay. Number 7, which assignment statement will display a 40 in a control called text hours? There it is right there. And the last one of these multiple choices is the most challenging one. Which assignment statement tells the computer to multiply the contents of label rate control by the contents of text hours and place it into label pay? So there is this one right here, label pay.text equals convert to inth. Oh, you know what? I don't think I see any answer that's absolutely right. This line right here actually should say dot text. And then dot int parse dot hours. Okay, so that part right, it's just that part where the dot text should be that. Okay, so just a little sampling of questions covering some of the ideas. Now, this question right here. Did you get it to work? Let's take a look at the solution. Now, as you know, everything I do, homework, assigned questions, the demos I do, most of them are in the lecture resources. So this one here is called SJB-CAF. I'm going to load it up, give it a run, and soup, lasagna, water, calculate bill. Okay, let's see how we do it and see if you were on the right track. So first step, obviously, you have to spend a little time and design this entire form. Okay, so those are labels, those are text boxes. This is a group box, and then of course radio buttons, group box, radio buttons, and then a couple of buttons down here. Now, you got to say to yourself, I got to remember the soup price, the salad, the chicken, and everything. So those are my variables that I want the entire world to know about. And then in form load, ta-da, I'm going to tell the computer the exact values. Okay, so here is where you declare your variables to the world. Everything, soup, salad, chicken, whatever. Then you're going to have the appetizer total, the main and the refreshment totals, subtotal, tax, and total. So you always got to say to yourself, what am I getting from the person? What do I got to work out? Okay, and there you see again all the initial values Here are some of the ones that we set to 0 at the beginning. And then we do our little programming. Here's the programming. When I press here, I want the pretty answer to show up there, but I also want the raw answer of $2 to be in the computer's brain somewhere else, okay? So if you remember from some of the examples we've done, this involves 2 steps. You're going to take the price of the soup, okay, which is in form load, 2. You're going to take the price of the soup and you're going to make it pretty. And you're going to store it back into the text appetizer, which is that box right there. Okay? So that's the first step. And you're also going to take the raw price of the soup and put it into the appetizer, which is just a regular variable. And basically, once you do that, you could copy and paste this to all the other ones, because they're all going to be pretty well exactly the same, except if you're in the salad part, you're going to use salad. Chicken, you're going to use chicken. Okay? All the way down. Then it comes moment of truth. You've got all your answers that you need. You've got this price, this price, this price. And now we need to do the math. Let's see how we do the math. To do the math, basically you take the appetizer, add it to the main and the refreshment, and there's your subtotal. Then you work out your tax, and then your grand total. Now these are all now raw numbers. To make them pretty, you take those answers and you put it to string, so that when they're showing in here, they will have dollar signs on them. Okay, so there they are with dollar signs. Okay, so I hope by practicing some of that, you're starting to see how an application can be used in a real business, cafeteria, library, store, whatever. Okay, so, and then we press new order, exit, and let's take a look at new order just to finish things off. The radio buttons are all put to false. The text boxes are all put to nothing, and nothing in computer is 2 quotes stuck together. Okay, and then the rest I've already gone through with you. So I hope you were able to use this as a nice little break to sort of take in a lot of the different ideas we've been learning up to now. Next lecture, we start going into another field of programming called decision making, where we're going to learn this word called the if statement. Okay, so I hope you are starting to get the hang of this and you're seeing some of the practical applications you can use with some basic programming. Decisions, decisions, decisions. One of the most important concepts in computer programming. Today we start taking a look at a special command called the if statement and how it's applied to practical applications everywhere. From when you go to a show, and depending on your age, you're charged for a ticket. Either if you're under 12, you might get charged for a certain amount. If you're a senior citizen, you might get charged a certain amount. If statements are used when you look up information on the internet to see if it matches what result you're looking for. Millions and millions of applications, really important concept. And that's what we're going to spend the next couple of lectures on, learning how to deal with those kinds of applications. Let me start by giving you a pre-made demo, just to give you an idea what kind of neat things you can do with the if statements. Okay, so I'm going to open up, and these are the demos for this next section. Okay, you should unzip them, put them on your hard drive, and they're in here. Okay, we're going to do some stuff together too that's not in here, but this first example I just want to show you. It's called guess number, and I'm going to install it and give it a run. Just a simple guessing game. Okay, we press this button to start it. Now the computer's thinking of a number. I'm going to take a stab at it. Too low, we'll go up a little bit higher. Too high. Oh, got lucky. 70 after 3 picks. Okay, so that's a guessing game. How does it use if statements? Well, you can sort of see in here already on the code screen where there's some special commands. Now, we're not going to do a program this complicated yet, but at least it highlights some of the special commands we're going to start to learn today. So what you should focus in on is this thing right here. Okay, this is checking if my guess equaled the computer's guess. And notice that funny thing there. Instead of just having one equal sign, which in computer is used for assignment statements, so not to confuse it with assignment statements, when the computer wants to see if something matches another thing, it uses two equal signs. And there's a special word we're going to learn today called the if statement. Underneath here, if it's not equal to, we use another special word called else, and then the word if again. And now this is saying, is my guess less than? Okay, if you forgot your inequality signs, that's less than, that's greater than, and eventually we're going to do a greater than or equal to, and less than or equal to. Anyway, this is saying if my guess is less than a number, then tell the person you're too low. And then this last one doesn't have a thing to say. And it's the way the structure of an if statement works. If it's not the first two or three or whatever the choices are, whatever is left is the last possibility. So if you're not equal to or less than, you must be greater than. So you don't even have to say it. You can imply it with the else statement. So that's the kind of stuff we're going to start doing today. Now, let's create our own little program right now to get us going so we understand how to type it in and do the actual commands ourselves. So we're going to take a look at an application for buying tickets for a show based on the user's age. So we're going to call this program Tickets. We're just going to have one little button in a second, but like I always do, trying to be consistent here, we're going to call this form Tickets. Okay, and then up here, we will call that form Tickets. Going to grab a button. And what we're going to use is the input box. So when this button is pressed, I'm going to make that input box pop up. And I'm going to use it as a good review on how to use the input box. So button, Tickets, and down at the bottom, determine ticket price. Okay, so there's our button, we're ready to go. Now, before we can use the input box, we need to grab it from Visual Basic actually. So we right click on references, we press add reference. Okay, and then we look for Visual Basic, which is right there, and we press OK. All right, so let's double click now and let's go into the code view. So we're basically going to ask the person for their age, so int age, and then we're going to work out the price. Now the price could be decimal, so I'll type in double for price. Okay, next. We're going to ask the person obviously their age, so we're going to say age equals int.parse bracket, and now they do that crazy thing where you go Microsoft dot Visual Basic dot interactions, where are you, dot input box, we're almost there, and then bracket, please enter your age, comma, and we'll call this tickets. We're not going to have a default, so we type in 2 commas there. And then if you remember from a previous lecture, if you don't type in the numbers, I think it centers it in the middle of the screen. Now I'm a little bit nervous, so before we get into the actual if statements, let's just make sure that this part works. Okay, so when we press the button, I want it to, and it's way up here, so we're going to change that in a second. Press it here, and it pops up your age. You type in 5, and then press OK. So let me do one more change, and then we'll get into the if statements. So I just want it to be in the center of the screen. Okay. Now this next part is very arbitrary. I'm just making this up. So let's pretend for this example that if you're 12 and under, it's going to cost you $5. Okay, now we can change these rules after, it doesn't really matter. If you're between 13 and 20, it'll cost you $6, and then from 20 to 65. So you get the idea. I'm going to sort of make up an arbitrary set of rules, but the most important part is how do you tell the computer what to do with those? Okay, so we'll double click here. And right after I ask the person their age, I'm going to use this special word now, if. And then you need to put in a bracket.
And you're going to say if age is less than or equal to 12. Now, this is the weird stuff. You're going to have to start using these squiggly brackets. And as soon as you press it, the computer puts in both ends for you. And in between there, usually you say 1, 2, 3 commands. For our case right now, all I'm going to say is price equals, and then I'll just make up $5. Okay? So that's the first if statement. Now, the next one, and every other one after this, are going to be a series of else ifs. Now this one I'm going to say you're between 13 and 20. Now here's where it gets a little funny. We're going to use this thing called a Boolean. So if your age is greater than 12, so you're 13, and I guess I could write down 13, greater than or equal to 13, and your age is less than or equal to 20, and then squiggly lines, and then you press enter a little bit, the price is going to be equal to $6. Let's continue. Else if your age is greater than or equal to 21 and your age is less than or equal to 64, just below senior citizen, we're going to charge you $10. And now the last one. Now the last one we can just say else, but I'm going to, for my sake, always put in else if. So if your age is greater than or equal to 65, you're a senior citizen, and the price is going to be $2. Okay, you get a break. Now, as we're going through all these if statements, you'll notice, okay, but where do you actually print out the answer? So now we're at the last part. Message box.show your price is, and then we add the price. And now that we know how to use currency, we're going to throw that in there too. Okay, looks decent. Let's give it a run. Actually, let's save it first. Try to remember, I like to save before I do anything. Press run. Oh, mistakes. Let's see what it says. Price, double, unassigned. So basically what this is going to tell you is that when you start doing more complicated programs like this, instead of just saying double price, initialize it. Start it off at 0. The age is not crucial, but this one that's going to store results is. Let's see if that fixes the mistake. Okay, now we're rolling. Okay, so initialize your price and you should be in business. Let's try every case actually. Let's say I'm 5 years old. $5, perfect. Let's say I'm 16. $6, good. Let's say I'm 45. $10, perfect. And let's say I'm 77. $2. So you see how everything works, and the basic structure of an if statement is as follows. Once it does one, so if I had said I'm 5 years old, it does the price is $5, and then it skips all of these. Okay, so it doesn't go through these other ones. It doesn't need to. It's got the answer, and that's it. So it doesn't funnel its way down and do the other ones. It just goes down to the very bottom and does that. And it's the same for all the other ones. If it fits that category, it does that category and then forgets all the rest. So there you see a very simple but neat application of how you use if statements in a practical example. Lots of ways and places that decisions are used. Here's a neat example. I'm going to give you a little quiz right now and see if you can do it as I go along and run it. So here's a program that asks you to type in answers, and it's going to mark your answers for you. So let's see the first one. All statements must end with that semicolon, the dreaded semicolon. Don't ever forget that. Oh, this is a math question. You got to remember your Bedmas rule. So I'm going to go 3 times 4 first, which is 12. Divided by 2 is 6, plus 2 is 8. Yes, I'm doing good. What keyword is used to declare an integer? On purpose, I'm going to type in a mistake. I'm just going to type in without the T. You know it's int, right? This one here is a bit tricky. This is the n sign. Usually there's 2 of them. And basically the way an n works is both things have to be true for the whole thing to be true. Okay, so is 3 bigger than 2? Yes. But is 4 less than 2? No.
So this whole statement is false. Okay, and we'll talk more about this Boolean operating stuff over the next little while. What do the double slashes precede? Well, those are in front of comments. Okay, let's see how I did. Not bad, 4 out of 5. So how did the computer actually do this behind my back? Well, let's double click on the grade and let's see. So basically, we're using if statements, as you probably guessed, and there's a bunch of if statements and saying, okay, let's see the answer to question number 1. If it was the semicolon, and whoa, what's this? 2 lines straight down. That's another Boolean. That means or, as opposed to this guy, which is and. Now, the logic behind the or statement is that if one or the other is true, they don't both have to be true, then the whole thing's true, and then we give the person a mark of 1. Okay? And then the other ones are pretty straightforward. So if you typed in 8 for the answer, remember the 2 equal signs. This one's straightforward. This one's straightforward. This one here again, we were worried about whether the person typed in comment or comments, so we used an or again. We would accept both of them. All right? And then down near the bottom, depending on their grade, we gave them some feedback. So that's a neat application of using if statements. Now what I want to do is leave you with some problems to try today. And again, we'll try to take them up actually before the end of this video. So I'm going to stop the video in a few seconds and we'll go through them. So first of all, I want you to pick, I would say, try to do this one right here. Okay, that kind of reviews stuff from before and after. If you want a bit of a challenge, you can do these other ones later. Okay, but I'm going to take this one up with you after a brief pause. And again, remember the trick I talked to you about a few lectures ago. You can use one of the previous programs and just use that as your guide. So what I would recommend is go back to the one we did a few minutes ago, this one right here. I don't know where you saved it, but I called it tickets. Load that one in and just add another button to it and solve that particular question in there, okay? So we'll take a break and I'll be back in a few minutes to take up that answer. Okay, we're back and now it's time to take up the average question. Now remember, what this one wants us to do is to write a program which accepts 4 marks and works out the average. Once the average is determined, display you have a passing grade or you have a failing grade, okay? And what I told you, and I will tell you all through this lecture series, try to use ones we just did that hopefully work for you. So I'm going to use the ticket example as the basis of my answer. I've already added the button, and I'm going to double click, and I'll show you all the code that was involved in finding the solution. Now we're asking for 4 marks, so we declare 4 integer marks. The average could have decimals, so we say double average. Then what I did is I went up here and cheated a little bit, and I copy and pasted this because I knew it worked, and then I just repeated it 4 times. And remember to change the names of marks to 1, 2, 3, and 4. This is how you work out the average, and I like this question because it forces us to review casting. It forces us to remember orders of operation, so make sure you put that in brackets and divide by 4. This in here I threw in a little twist. Never seen this before, right? A few days ago I introduced the C, which is for currency, and will make you display stuff with, in this case, 2 decimals. If you put 3, it would be 3 decimals. So kind of another cool formatting that you could use to your advantage. And now we're down to the last part, which is today's material. If your average is less than 50, then you failed. Else, if your average is bigger than or equal to 50, you passed. Let's test it out and see how it works. Okay, so I'll pick really good marks, 77, 88, 99, 87. So your average is 87.5, you passed. So far, so good. Let's pick some really bad numbers, 22, 33, 44, 11. Your average is 27.5, you failed. So there you have a simple but practical application of using if statements. Okay. Now, if you're up to it and you have some time, you could try some of these other questions. You could try number 1 or number 3. In our next lecture, we will focus in on practical applications that involve utility pricing for gas companies, hydro bills, and things like that. So don't go past number 3. So if you want to, you could try those other ones too. So thanks for listening, and we'll see you in the next lecture. Welcome back, and we continue today with another lecture on making decisions. And today we're going to look at a very practical application from the world of utilities. Utilities being your gas bill or your hydro bill or your telephone bill, okay? And there's numerous if statements used in those kinds of calculations. In our main example today, we're going to take a look at how a gas company could work out your actual bill. And it involves what's called tiered pricing. Let's take a look at the actual question. If you remember the sheet that I gave you last lecture, we actually went through and took up question number 2. Let's focus in on number 4. And actually an important part of my lecture series is actually to teach you a bit about problem solving too. So sometimes I'm going to give you questions, and not just the programming is going to be important, it's understanding how you develop the program. All right, let's take a look at question number 4, which is a question to deal with working out your gas bill. And this gas company, it measures its gas in hundreds of cubic feet, which they call CCF, and it charges them according to the following schedule. The first 8 cubic feet is 50 cents each. So if you use 4, it's going to be times 50 cents each, okay, which would come out to $2. Now, more than 8, it's an additional 30 cents each. So to understand that, let's pretend I used 10 cubic feet of gas. Okay, so if I use 10 cubic feet of gas, the first 8 are charged at 50 cents each, which would be $4, and the additional 2 to make up the total of 10 would be charged at 30 cents each, which would be an additional 60 cents, for a grand total of $4.60. Okay, so that's the math behind it. So if you don't understand that, you can't actually program the question. So what you always try to do when you're given a problem like this in real life is start doodling on a piece of paper, figuring out, all the different numerical possibilities before you generalize it into a computer program. Now, once you have that in your mind of how it works and the mathematics behind it, you are ready to program. Okay, I'm going to use my favorite trick again. I'm going to use a program I've already worked on, use some of the information already in there to help me do the next question. So remember that ticket price one we did last lecture, and then we did the average program as we took up some of the assigned work. Well, we're going to use that, and I'm just going to add another button. And inside here, I'm going to call this button, we'll call it gas. So we'll slide this up here. And we'll add the word BTN, and we'll call this gas. Okay, so we're ready to program it. Now, the first thing we're going to do is we're going to ask the user for the amount of gas they used. So let's assume that's in integer. We are then going to work out the bill. And we'll initialize that to 0 because I know one of the previous questions we did with if statements, we needed to do that. Now we're going to ask the user for the amount of gas they used, and we can beg, borrow, and steal from one of these. It doesn't matter which one. I'll take this one right here. Okay, and I'll put it right there. And of course, this isn't tickets anymore. We'll call it the gas bill. Please enter your gas usage in CCF, okay, cubic feet. And obviously that's not the word age. We're going to change it to gas. Okay, and I'll slide this over a bit so you can see it a little bit better. So now we're ready to do some if statements. What we're going to do with our if statements is we're going to basically say, listen, if the amount of gas is less than or equal to 8, we're going to charge you the amount that you used times 50 cents. Else if your amount of gas that you used is greater than 8, we're going to charge you, now here's where it gets tricky, because it's not just 30 cents. Okay, if you go back to the question, more than 8. So it's like it includes the first part and the second part. So it's almost like got to invent an equation or a formula. So the amount of gas is going to be, well, since you're over 8, you use the entire 8. Okay, so it's $4 there, no matter what, plus. Okay, and this part, now we have to figure out a way to say to the computer, listen, if it's 10 and the base was 8, the difference is 2, and that's the extra cost I want to charge you. So the way you say that is you say gas minus 8, and then you times that by 30 cents. Okay, let me give you a for instance. Let's assume we did use 10 cubic feet of gas. That's what would go into this variable, right? So obviously 10 is bigger than 8, so we don't even do this formula. We go to this formula and we take the full 8 amount of the 10 and times it by 50 cents. And then we take this 10 number and put it right there. And 10 minus 8 is obviously 2. And then we times that by 30 cents to get our 60-cent total. Okay, so this formula works. And this is the kind of thinking you have to do when you're a computer programmer. If you're only looking to do 1 or 2 specific questions, then it's useless to write a computer program. But when you want to make it work for any possibility, you have to generalize your solution so that it works for all the different possibilities. The last step in this solution is then to print out the actual bill. So your gas bill is, and then we will attach the actual amount, and it's money, right? So we're going to type in to string with currency on it and semicolon. Okay, let's give it a, well, let's do a save. I always like to save. Okay, and then we'll do a run. And we'll do 2 scenarios to make sure they work. So the first scenario is going to be we use 5, which is under 8, right? So this would be 5 times 50 cents. Let's see what happens. 250. Very nice. Okay, let's do that 10 example. Okay, so I think the answer we worked out from before was 260 or something like that. I can't remember, but let's just see what happens. 460. I'm sorry, it was 460. Okay, so that's correct. So that's the logic when you do this thing called tiered pricing. Now they get a lot more complicated than this. Some utilities, like the one I'm going to let you try in a few seconds, has what we call multiple tiers, 2, 3, 4 levels of pricing depending on your gas usage or your hydro usage or whatever else. That's the kind of logic that's going to be involved. And what we're going to do is I'm going to get you to take a look at this question. This is number 6 for a hydro. Okay, and I'm going to stop the recording for a few minutes, give you whatever time you need. When you think you've got it or you've given up, restart or start the recording at this spot, and we will take a look at the solution. And again, don't create a new program fresh. Stay in this. Okay, add another button, call it hydro question or something, and then use this as your guide to see if you can do it. Okay, good luck. All right, let's first figure out the actual math behind how this hydro bill is calculated, because if you don't understand that, you won't be able to program it. So let me start doodling a little bit here and go through each of the 3 levels of pricing. This one here, you have to understand, is a flat fee. So the first 12 kilowatt hours or less, it's $2.80. So what that means is if I use 7 kilowatts, it's $2.80. If I use 12, it's $2.80. So for the first part, it's always $2.80. Now, above that, and the way they word it here is the next 78. So really, if you're at 12 plus 78, so all the way up to 90 kilowatts, then what you're going to do is be charged 8 cents for that amount over 12. Oh, and then it gets even crazier. So you're at 90, but now what about if you're over 90? You're at 91. Well, then you're charged the first level, the 280, plus the entire second level at 8 cents, plus the amount over 90. So if you're 91, you get charged 1 times 6 cents. So you see how people get crazy with their hydro bills. There's, in this one, 3 levels. And again, I've made up the prices, obviously, but this gives you an idea of what we call tiered pricing. So let's start to computer program this now. So we'll drop this screen down a little bit just to get us rolling. And like I said, I've used this program again. We're going to beat this one to death because it's got all kinds of neat stuff. And a lot of it's already set up for us. Now in this particular case, we're going to ask for the kilowatt hours. And we're going to work out the bill again. And we'll initialize it to 0. And again, we will steal this line from above. Okay, to make it easier for us. Put it right about there. And of course, we're asking for your hydro usage. Okay, and then I will call this hydro bill. And again, this is not exactly how they do it, obviously, but we're trying to show you the math involved. And we're about the word gas, and we're going to call it kWh. And now we get to the mathematical part. Okay, so first if statement's going to be like if you use less than or equal to 12. And again, let's double check that to make sure we're doing it right. So first 12 or less. So that does include 12. It's going to be a flat charge. So we add the squiggly lines. Don't ever forget the squiggly lines. And then we say the bill is equal to 280, which I know sounds kind of weird. That's called a flat charge. All right. No matter what you use up to 12. And now else if your kWh is greater than 12 and your kWh is less than or equal to 90. Okay, so that's what we think of as the next 78. So if you're at 12, the next 78 brings you all the way to 90. Okay, and again, we got to work out a bill, but this is a bit more complicated formula because at each level, it takes into consideration the previous value. So it's 280, that's from before, plus, now I don't know how much. All I know is kWh minus the base of 12, okay? And let me times that by, and we'll check what we have to times it by, 8 cents. Okay, so this one's times by 0.08. Now let me give you a for instance before I continue. What if I had used 14 kilowatts of gas? So the first 12 would have been at 280, okay, a flat charge. Now I used 14, right? So I'm 2 over 12. So if I put 14 there where that kWh is, take away 12, I get 2. Yes, this formula is going to work, and it's going to work for any possible combination within those constraints. All right, now we're down to the last one. The last one's going to be the craziest one because it's going to take into consideration everything. So if you're over 90, here's what's got to happen. The bill is going to be equal to the original 280 plus all of the second level. Now, all of the second level, how much is in the second level? Well, there's actually 78 kilowatts in the second level because from 12 to 90 is 78. So we're going to type in 78 times the entire 8 cents plus the difference above the 90, which is going to be written like that, times 0.06. And now we're ready to print out the answer. So we're just going to put a little message box down here and we're going to display the results. Your hydro bill is, and we'll attach the bill. And of course, now we're getting good at this. We're going to put it in currency, put a little semicolon there. Okay. And then we'll save it and hopefully it'll work out. Let's just give it a try. Make sure we don't have any errors. Okay, so let's pick the easiest one first. So if you use 1 kilowatt, it's still going to be 280. If you use 10 kilowatts, still going to be 280. And if you use all the way to 12 kilowatts, it's still going to be 280. Now it gets a bit trickier. Let's say I use 13 kilowatts, okay, just 1 over. It's going to be 280 plus the 8 cents times 1, which is 288. Makes sense, okay? So we're doing it well. And the last case would be like if you used 91, which would take all the different combinations into case, and it works out to $9.10. So there you have a more complicated example of tiered pricing and how the computer programs use if statements to handle those types of answers. Okay, so now you've got a decent idea of a practical application from the business world, the utility world of decision making and if statements and how it's used. Okay, so kind of neat, and this is the whole focus of this course. Every time we learn a concept, I just want to teach you the concept for the basic idea of the concept. I want to see where it's applied in real life and how it applies. Now, it gets more technical and more advanced than this, but we're just starting off, and this is not a bad way to start off. Okay, thanks for listening. We'll see you in the next lecture. Welcome to Lecture 15. What we're going to do today is take a look at dialog boxes. And this topic is kind of sandwiched in between our last topic, selective processing, and our next main idea called repetitive processing. What I want to do today is create a way to interact with the user in a more friendly way. Instead of using the traditional input box, what we're going to do eventually is create our own custom input box that can have multiple input entries. Okay, so, and there is a flow. It does use some ideas from selective processing, so you'll see where it all factors in. All right, let's create a little demo to go through some of the concepts on these dialogues. So let's rub this out, and we'll call it the dialogues. All right, and we'll go over here. We'll change the name of the form to the dialogues. Then we will go over here and we will add a little title to the top. Dialogue demos. Now let's grab a button. We're going to put a little button there. This button is going to demonstrate a built-in dialogue. I'm going to call it button message. You'll see why in a sec. And then I slide down to the text. And we'll call this the message box demo. So yeah, you've been using already special dialogue. You've been using MessageBox actually quite a bit. And just for an example, we'll remember how it goes. MessageBox.show. Now here's where it gets different. You've been using only one of the versions, and I'm not sure which one we've been using, but there's 21 of them. I want to try for fun number 7. Okay, and basically it says start off and say something, like some quotes. I'm going to say, do you understand this? With a question mark, comma, and then it says in the next part here, string caption, so we're just going to write down the word dialogue. Then comma, now here's some new stuff. Message box buttons and message box icon. I haven't seen those before. So first of all, let's type in message box buttons dot. Oh, no, there's all these choices. Now I said, do you understand this? So I'm going to pick the one that says, show me the yes, no button, comma, message box icon dot, and look at this, there's all these different icons that will pop up in the box. Exclamation, asterisk, information. I'm going to do this one. I'm not sure what it does. Oh, question. Yeah, let's do that one. Okay, and then put a little semicolon at the end. And there is our first sort of pre-built message box. Let's see what it does. Let's do a save all first. Okay, it just finished compiling. It's way up here in the top corner. I'm going to press this. Dialogue. Question mark. Do you understand this? So see, this is kind of cool. Before this, all our message boxes were kind of very generic little thing in the middle of what you wanted to type in. Now there's even 2 buttons here. Yes, no. I'm going to press yes. Big deal. I want to press no. Big deal. That's our next step. This is where I incorporate now the material I showed you before this lecture to this one. So after you come up with this cool built-in, comes with C# message box, or we call them dialogues, how do you know what you pressed? So this is kind of neat, and this is our next idea. So there's this thing called dialogue result, which kind of makes sense. It's a good name for it, dialogue result. And I'm going to call the variable that represents the answer R, and it's going to equal, and actually, you know what I'm going to do? I'm going to sneak it up here because I don't want to type out the line in again. So I'll do it right to here. And what this is going to do now is when you respond to that dialogue, it's going to remember which of the 2 things you pressed, yes or no. And
I'm going to do a little if statement because that's what I taught you guys in the last lecture. I'm going to say if r equals, now what do you actually type in there? Let's see, dialog result dot, and there's a bunch of choices. So let's see which one we want. Yes. Okay, so if you press, then, is that the right way to do an equal? Remember what I told you? When we do equals now in C#, you have to use double, okay? Because one equal will represent the assignment statements. So with two equals, you have the proper one. So now we type in message box.show you pressed yes, just to prove that it actually is intelligent enough to figure it out. Else if, and this again you could have just said else, but I want to remind you how to do this. Result.no, I'm assuming there is a no, yep, there it is. Squiggly lines, message box dot show you pressed no. So you can see now how today we're going to get a bit more sophisticated in our interactions with the users. We're sort of making it a little fancier version of the message box. In a few minutes you're going to see a fancier version of the input box. Okay, so let me press start. Okay, so message box demo, we press it. Do you understand this? Yes. And I press yes, and you what I pressed. Press no, you press no. And so there is our first attempt at what we call dialog boxes, and this one is a built-in dialog box. Okay, now the custom stuff. That means you're going to define a dialog box and have it pop up, have whatever you want on it, and accept whatever information that you want or need. Okay, so let's first of all make another little button here. Okay, and we'll go over here and we'll call this one button custom. And we'll slide down and we will change the text to custom dialog. Okay, now, so when I press this one, I'm going to have another screen appear with whatever I want on it. Okay, and only problem is, where's that other thing? Well, now you got to remember some other stuff from before. I'm going to press on the dialogues. I'm going to go to add, new item. Okay, and we're going to pick a form, and it doesn't matter what you call your form. I'm going to call this form FRM user, and then I'm going to press add. Okay, so there's the form user. Now, this form could have whatever you want on it. For now, we're going to leave it blank. I just want to make sure we remember how to make this form pop up, and then we will kick it up a notch and actually customize it to our liking. So let's go back to the dialog form, and actually let's go to the top first here, right? So we'll double click, and do you remember this stuff? Let's see, form user, and then you had to say something, okay? And I'm going to call it F equals new form user bracket bracket, and then to make this show up, I just gave it away, you type in this. Now, this show is not that great. There's a better one than this, but I just want to show you right now that this actually works. And actually, before I do that, because I hate when it pops up over on the left-hand side, let me go to this form, and I'm going to go down to start position and change it to center screen. Okay, I think we're ready to try it out. So when this pops up, there it is. Yeah, it works. Now here's the problem with this one. Press it again. Another one. Press it again. Press it again. That's not good. When you have a form pop up and you're waiting for a person to type in an answer, you shouldn't have a guy goofing around and pressing it 7 or 8 different times. So how do you fix that? Well, what we're going to start doing today is using show dialog instead of just show. And this will make it kind of a modal form. It'll be stuck and say, if you don't give me what I want and you don't press it and then press close or exit, I'm not going to go back to this main screen. So let me show you how you do that. So it's pretty easy. Instead of just f.show, you say, and I'll rub it out from the beginning there, dot show dialog.
bracket, bracket. Whoops. Okay, now watch what happens when you run this one. So when I press this, there's the screen. Now I'm going to press it. It's not letting me get out. It's not letting me make 10 different copies of it. And when I press this, now I've closed it. I'm going to do a more formal close in a minute. Press it again. There it is. Won't not let me go and make another form. Okay, so that's a very important idea. Okay, now for a bit of advanced stuff. I hope I don't go too fast. You can watch the video over if you get a little bit confused, but watch what I'm going to do. I'm going to go over to here now, which is the form user, and let's start off and put a label on it. So I'm going to put a little label here, and I'm not going to formally name the label, but I am going to put the text in. And I'm going to say the word name. Okay, and I'm going to slide it over here. Then I'm going to grab a text box. This is important though. This one I have to name. Okay, this one you have to do the right way. So that's going to be a place to put a person's name. So that one is going to be called txt name. Okay. Next, I'll grab another label, and we will ask for the person's age. And again, I'll get lazy with naming it, but I'll definitely put something there, age, and we'll grab a text box again. And this will obviously hold the person's age. So I'm going to call this one text age. Now in traditional, and if you don't get it yet, what we're making here is our own custom input box. Remember when we did input boxes, they have like a simple little word and one little space. That's it. Can't do any more. So if you want to make it more enhanced, you got to leave Visual Basic, which was kind of a cheating way for a couple of lectures anyway, but now we're using a more sophisticated way. And in the bottom of most homemade, built-in, whatever input boxes, there's always two buttons. There's an OK and a cancel. Okay, so we got to throw those in. This button I will call, obviously, button OK, and I'll put the word OK on it. This button I will call button cancel, and I will put the word cancel on it. But a bit more has to happen beyond this, and this is where it gets a bit tricky. Okay, when we actually press these, we need to tell the computer that these are the formal, even though we've made them in a pretending kind of way, these are the formal OK and cancel buttons. So there's a couple of different things that you can change. So OK, cancel, there's different things. And one of them is called the dialog result. And we have to change it to the formal OK. Let's go to cancel. We have to change that one to the formal cancel. Okay. And the last thing you do is for the form, you set the accept and cancel button just in case they press escape or press OK. So accept button will be automatically, the accept button, let me slide up a little bit. The accept button will automatically go to button OK, and the cancel button will automatically go to button cancel. We're just about done. Let's run it. It's not going to be won't look any different to start off with, but there it is. Nice, eh? And it comes back. Nothing's been pressed or anything yet, but we got one more stage to do. Now, I hope you didn't find that too complicated, but now we are going to get a little bit crazy, and this uses some advanced techniques that we're going to revisit again when we do this topic called object-oriented programming. But for now, we're going to have to go into the code view now, and you're going to have to do this thing where you declare to all your forms a certain settings. Okay, so you're going to have to say the word public, string, and username. Let's call it the person's name, right? And then squiggly. And what we're going to do here is we're going to use a special command called get, and then more squigglies. And what we're going to do is we're going to return, when the person presses OK in this form, the text name.text. Little weird, right? Very weird command. I know it's the first time you've ever seen it. And then you would do this for every box that you have. I've only got one more box, right? So I'm going to say string user age, and then squigglies, and then get. So this is a special command that will get whatever the person typed in for his age and return it to the main screen. So without getting too complicated, these are called properties when you do object-oriented programming. But for now, let's just make sure it works. So if we run it and it doesn't yell at us, we must have done something right. Now, again, nothing's going to happen yet. We're almost there, though. So when you press OK, it comes right back. No problems so far. All right, time to tie all these ideas in together and actually have the results that were typed into the sort of homemade input box show up now on our screen. So let's double click in here. So this is how you tell the computer you're going to create an instance of that form, and this is how we make it show up now. But we learned some new words at the beginning of today. Dialog result are equals. So I'm going to make that sort of like an equation now, or an expression. And what's going to happen is this is going to make the screen appear. When the person presses OK or cancel, that result is going to go in here. Now, if R equals dialog result dot OK, that's good. And what we'll do is a couple of things in here in a second. Else, and we won't even have to do it because it's either one or the other, we're going to say message box dot show you pressed cancel. Okay, now if they didn't press cancel, why don't we print out or display the people's ages, marks, whatever. You could do whatever you wanted to, and I'll show you some neat examples after. So message box dot show bracket your name is, now here's where it gets a little bit crazy. The form, the object is now called F. So F dot, and on the other form, we called that person, I think we called him user. Yeah, hey, where'd this come from? User age. No, we want username though. Okay, so that's the person's name, and then message box dot show your age is F dot user age. Now let's see if this works, and we'll do a little recap. So first of all, now what we're doing in this lesson is what are called homemade user-defined dialog boxes. So instead of the simple input box, we are now trying to create our own. It gets kind of tricky. We'll revisit this several times over the next couple of lessons. So there it is, beautiful. We've made our own custom form. Okay, so what we're going to do is we're going to type in our information and our age, and then press OK, and then it tells me my name and it tells me my age. Now, once you feel comfortable replacing the generic input box with these custom dialog boxes, you can do all kinds of complicated things. And in the demos for this lesson, I want to show you another example. Let's go up a level. So we're in user-defined dialogues. So let's say you worked in a doctor's office and you needed to enter patient information. Here's one that I did for patients. Okay, and again, it'll start off the same. You'll have a main form where you say welcome or enter the patient information like I have here. Then another screen appears, and there again is a custom made input box if you want, or we call them dialogues. And you type in the information. I'm just putting in some garbage, obviously. And when you press OK, the computer remembers everything you told it. And again, just to go back, the information, once you've got it in the computer's brain, so if you called it, in this case, we said the object is called P, it'd be p.patient, address, postal code, whatever happened to be the situation for that question. And over here, you have all your different input boxes, and let's look underground. This is the weird stuff that you'll see over and over again as we get more into the lectures. You declare publicly to the entire world, these are the variables that I want to use back at the other form, and you have to get them by returning with the results. Okay, so a little bit crazier this time, but hopefully you got a basic idea of how to make your own custom made dialogues, and now you're becoming a more professional programmer. Welcome to the next lecture. In this lecture, we look at the concept of repetition, or as we call it, looping. what we're going to do is take a look at several of the different kinds of loops that you can work with. In particular, we're going to look at the while loop structure and two facets of it, a user-controlled repetition and a counter-controlled repetition. Now, why would you want to use loops? What makes them so special? Well, here's the why. If you didn't know loops, and for instance, you wanted to work out the average age of maybe 100 people, from what we've known so far, you would need to write an input type box and ask the person for their age, and somehow remember that number and add it to a total, and then ask the next person for his age, and the next person, and the next person. And these would be all at least one line, two line types of code where you're asking for an input box and then doing some sort of math. And you would have to have 100 of these. Now, if you needed 300 of them, that would be gigantic. What loops endeavor to do is, since you're basically asking the same question and maybe doing the same formula over and over again, is you repeat this in a construction that's maybe 2 or 3 lines instead of hundreds of lines. So at first glance, one of the major uses of loops is to reduce the amount of code that you use when you're repeating the same kinds of concepts. And we're going to go through a couple of examples right now to show you. All right, so let's just do a little simple practical example, and then I've got a nice demo that's a bit more polished than this, but we'll start off with something easy. So we'll call this rep, and we'll press OK. And what I'm going to endeavor to do in this example is just give you the basic concept of what a loop is, what it looks like, and how you can apply it. Okay, and I'll call this rep intro. Slide down here. Okay, and I'll add a button. And we'll call this button BTN rep. And we'll put a nice title on it. Okay, so let's get going with the actual code. So the basic command that we're going to use the most of in this particular lecture, and for most of the lectures in this entire series, is the command called a while loop. So basically what's going to happen is we're going to have the computer repeat things over and over again, and the command that does that is a command called while, and I'm just going to put the word true in there for now, and then squiggly line all the way down. So what's going to happen is anything between this word all the way down to that squiggly line will repeat itself over and over and over and over again. Now this one you'll see in a second. I don't want to give it away. This is our construction of a loop. Let's just run it for a second and see what it does. So when you press the button, this is a test, great. This is a test. This is a test. This is an infinite loop. It's not going to stop. We're going to try to break out of it this way, which is not the very elegant way to break out of it. But this is an example of an infinite loop. In and of itself, it's useless, okay? We got to get a way to get out of it, all right? So the next step in this process is to, after it's displayed whatever it has to, we ask the user, listen, do you want to exit or not? Now, to have the person ask the computer, hey, stop, we're going to use an input box. So let's quickly grab the input box from Visual Basic. I don't want to spend too much time making those dialog boxes. We'll do something quick and dirty right here. So I'm going to add a reference to Visual Basic. Okay, and right in here, I'm going to ask the person the following. And I'm going to need it to be a string. So I'm going to say string response. And it's going to be equal to Microsoft. And again, we'll try to cheat a little bit. Dot Visual Basic. Dot interaction. Dot input box. Bracket quote. Do you wish to continue? Yes or no? And then we'll add a comma. And I'll back this up a bit. And I'm going to add just that. And we're going to add a semicolon. So we're not going to tell the computer exactly where to put it. So this puts it in the center. And we're not going to put a title or a default. Now, once I get that information, yes, I want to continue, or no, I don't, I'm going to do the following, because I got to get out somehow eventually. So if the response equals, do you wish to continue, yes or no? If I say no, okay, so if the response equals no, now we could use squiggly lines because it's only one word. That's kind of like the easy way out. If you have more than one set of commands after an if, you have to have them in squiggly lines. So let's see what this does. So rep app, this is a test. Do you wish to continue? Yes. So it says this is a test again. So it stays in this loop. It continues to go through the loop, loop, loop. If I say no, and I press OK, it stops. Okay, so now what you've got is something that's a bit more practical. It's starting to get an idea of what it should do. So we've got a loop. This is an infinite loop, but it's controlled by the user. So it's called a user-controlled loop, and you decide if you want to continue or stop. The other kind of loop is called a counter-controlled loop, and what I'm going to do for that one is I'm going to make another box or another button. Okay, and slide this back out here. This one we'll call, and I'll slide this a bit more out. This one I'm going to call button counter. You'll see why in a second. We're going to call this a counter loop. All right, and we'll go inside of it. Now, this one's going to have the same basic setup, except at the beginning, I'm going to have a variable called counter, which is going to start off at 0. And I'm going to have the while loop again, but this time I'm not going to say while true, which is an infinite type loop. I'm going to say while counter is less than or equal to 10. And then I'll use the squiggly lines, and I'll do message box again. This is counter, and I'm going to say counter to string. And you'll see what it does in a sec. Now, after we print out the counter is 0, 1, 2, 3, whatever, I've got to get a way to get it to that number. So when it's 0, great. Is it less than 10? Yes, and it's going to print this message out. But now how do I get it to go a little bit closer to 10? Well, counter is equal to counter plus 1. That's how you make the counter go up one more than what it was. Okay? And let's see what that does. So counter loop. This is counter 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it should stop. Okay, so that's called a counter control loop. Kind of neat, right? And again, these are kind of useless questions right now. We're going to show you some practical examples in a second, but this is the basic idea of what I'm going to cover today. This is basically an infinite loop, which is user controlled, meaning that you can do this forever and ever until I say stop. And the way you stop it is you use the command break. This is a counter controlled loop. So the computer counts, and when it gets to a certain number of times that it's gone through the loop, it stops. Now we'll talk more about these things right here in a future example, but this is user controlled and counter controlled. And what we're going to finish up the lecture with now is a practical example of where these types of things can be used. Okay, now I've got a very nice polished demo that I'm going to use. And in the next couple of lectures, you're going to be asked to solve some problems. So use this as the base solution. So keep this here and then add to it. The examples are in the demos you should have downloaded. This one now is repetition, and I want you to load up rep apps. Okay, and I'll show you the screen. A couple of really neat ideas here that I want to talk about before I show you the code. This is a text box, and I've added a couple of properties to it. So you notice scroll bars, vertical, because we're going to show a whole bunch of answers here. And then there's another line that's really, really important also that a lot of students always forget if they use this, multi-line true, which is going to allow a bunch of answers to show up here. So many answers that they're going to go way below the text box, and then it'll activate this scroll bar and you can go up and down. Okay, so realize the properties I had to set to make this work. Okay, let's take a look at what these programs do, and then we will talk about the code of each one. Here is the first practical example. So in this particular example, we're going to ask the person to enter the radius for a circle. So if I type in 2, it'll tell me the area of the circle, 12.56, and then it'll say, do you want to do this again? Yeah, I got another question I want to work out. I want to know what the area is for a radius of 6. Okay, good. I think I've had enough. I'm going to stop. Okay, so there's our first practical application of repetition being controlled by me, the user. Let's look at the code. Okay, so first off, we're going to ask for a radius and we're going to work out the area. And we're going to need to use pi because the formula for a circle is pi r squared. Here's a brand new kind of declaration. This is called a constant, which means this number never changes. Okay, pi is pi is pi. So that's a new thing. Here is the stuff that I was just talking about. This is the first kind of loop that I demonstrated a few minutes ago. This is kind of an infinite loop. It goes on forever, and then you decide when you want to exit. So first thing we do is we ask for the radius, and we convert it into an integer. Remember, I like to also use that one called int.parse. Okay, it's up to you. There's double dot parse and things like that. But this is also valid, convert to. This is what we call a bit of dummy proofing. What if the person types in -7? Well, there's no such thing as -7 radius. So I have a little if statement here that says, no, no good. Else, this is the formula for the area of a circle, pi r squared. And then what we do is we print out the answer. Then we say, listen, do you want to try this again? Okay, you saw me do that a few minutes ago. And if the response equals no, we break. So there you are. You have the first example of how you use repetition to solve a practical example. On to the second example. This example is really cool. Just watch what it does first. So what we're going to do in this example is I'm not going to intervene. I'm going to press it and it's going to make a big display. So big that it goes below the text box, so we have to slide it up and down. So there's that multi-line property coming into play. Let's take a look at the code. So in this one, if you remember my second example in the intro, I start off with a counter. It doesn't have to always be the word counter. I'm going to use Celsius in this one, and then I work out the Fahrenheit. This line here, imagine the text box, okay? And what we're doing right now is adding Celsius and Fahrenheit at the top, and then this line here makes the computer go down one line. And this is all being stored in the text box. Now we've got our loop. Since I wanted to work out Celsius to Fahrenheit conversions from 0 to 20, this says while Celsius is less than or equal to 20, do the formula. And there is the formula to convert Celsius to Fahrenheit. And then for the first time, this is really weird. This is plus equal. We'll get more into this probably in the next couple of lectures. But what this does is attach itself to the previous answer. So this answer here, the actual Celsius now of 0, and the answer, whatever it happens to be, there, gets attached. And then it gets attached to the next one and the next one. So that plus equals is a way to make one gigantic list all in one shot. Some other little things that are in here, plus T. That's like a tab when you tab on your keyboard. And it will shift the computer over a certain number of spaces so it looks kind of nice when you display it. And there's our environment new line again, which makes the computer go down to the next line. Now, some other cool stuff. When I did the one with you guys, I had counter equals counter plus 1. I could do that here also. I could have Celsius equals Celsius plus 1. But here's a really cool way to say go up by 1, plus plus. Okay, and again, we'll talk more about this in a future class, but if you don't get this right now, stick with the counter stuff. But in this case, it would be Celsius equals Celsius plus 1. So in this loop, the computer is going to go over and over and over again. Okay, so there's a practical application using the while loop with counters. The last two examples I didn't mention in the intro, and they're kind of cool also. The last type of loop that we're going to look at in this lecture is called the for loop. Really neat. If you know exactly ahead of time what you want to start at and what you want to go to, this is usually the better one to use. And again, what's going on here? Well, this is saying start at 1, go all the way to 100, but plus 2 means go up by 2s. So 1, 3, 9, and keep going until you get to less than or equal to 100. And what's this going to do? It's going to add up the number cubed. So that's how you write down the exponent cubed. So 1 cubed, 3 cubed, all the way up. Okay, so this would be called the sum of the cubes. And again, this is an accumulator, so it would total up one answer to the next one. And actually, just so you understand this one, let's do this one in super slow motion. Okay, remember, super slow motion or stepping is kind of a neat way to understand what's going on inside the computer's brain. So we're pressing F11 all the way through here. It's going through all of these until we get to the good stuff. Okay, there's the screen popped up now. Now we're going to press this. And let's watch this in slow motion. So what the computer is doing, it's going to add up the sum of the squares of numbers. So when it starts up, I is 1, and 1 cubed is 1. And when we work out the sum at that moment is 1. Then we go back up and add 2 more to where we were. So now when we get to the formula, the number is 3. Now 3 cubed means 3 times 3 times 3, which is 27. So our last answer was 1 plus 27. Now the sum is 28. And what the computer does is keep doing this over and over and over again until you get your final result. So that's kind of like the inside look at what that program was doing. This last example is pretty cool too. This one demonstrates how you can do combinations of things. And I'll just run it for a second. So this one, it's kind of like the for loop because you're saying do 1s and then go 5, 10, 15, 20. Then do 2s, 5, 10, 15, 20. Whoa, it's almost like there's 2 separate loops working at once. And actually there is. What we did here is work out all the combinations of lengths and widths to work out areas for numbers 1 to 4 for the length and 5, 10, 15, 20 for the width. So how would you get the computer to do that? Well, this is kind of like a loop inside a loop. So there we're going to use again our third kind of loop called a for loop. So the first loop goes from 1 to 5 by 1s. The second loop goes from 5 to 20 by 5s. And then we work out the area and attach it to the text box. And there's some tabs to space it out. Okay, so that's the last example. Now, we threw a lot of ideas at you today. In the next lecture, we're going to take a break. We're going to look at a bunch of different problems. We're going to work on them together, so it won't be any new theory. So in recap, we learned today how to do user-controlled repetition and counter-controlled repetition, and this last idea of the double for next loops and for loops. Okay, so thanks for watching, and we'll get you really up to speed when we do the next lecture and lots of problems. Welcome back, and as promised, in this lecture we're going to move from theory to practice. So what we want to do is go through a series of problems today just so we reinforce the concepts that we learned last lesson. And make sure you download the practice sheet, and here it is right here. Okay, so make sure you've got that ready. And what we'll do is we'll do a selection of problems from each of the 3 types of looping structures we covered in the last lecture. Now, as I've mentioned before, instead of you building everything from scratch all the time, when we're faced with a little bit of a challenge problem, why not load in a program we've already worked with and use that as your guide? So I'm going to load this RepApp program in there, and I'm going to stretch it out a bit more. And what I'll do is I'll just add more buttons to this program. And when I look at a question, I'll go, is it like this one or is it like this one? And I'll modify that and help me do the solution. Okay, so like I said, we'll take one or two from each section and we'll take them up. So from this first section, I like this question right here. And it's very similar to this one. This one changed Celsius to Fahrenheit. This is going to change liters to gallons. Okay, so it says to create a program which will produce a table, right, showing liters to gallons for 20 to 60 liters in increments of 4 liters. And it gives us a bit of a hint. 1 gallon is 4.54 liters. Now, before we do the actual solution, there is a bit of math here to understand. If this question had asked to change gallons to liters, then we would multiply by 4.5. But it's actually asking us the reverse, liters to gallons. So we're going to divide by this 4.54. Okay, so I think we're ready to try the question out. I'll drop this part down and I'll add a button. And you're really going to see how I leverage what I've taught you to do this question. So this question, we'll call it the button liter gallon question, and we'll go down to text box, liters to gallons. Okay, and we're ready. And I'm going to do a lot of cheating here. I'm going to basically copy and paste this whole thing. I know it's not exactly the same, but it's pretty close, and then I'll modify it. And this way, I sort of ease myself into these questions. So I'm just going to paste it in here. Now this wants liters to gallons. So instead of Celsius, obviously, we're going to type in liters, and it's going to start off at 0. And this word is going to be gallons. And the text box, again, that'll be liters. And this will be gallons. Okay, so you see how I'm leveraging without having to reinvent the wheel some of the stuff I've already got. Now let's go back up to this question here, and it said I want to go from 20 to 60 liters in increments of 4. So 20 to 60 liters. So where it says Celsius, obviously I have to change that to liters, and it's going to be going up to 60. And starts at 20. So instead of 0 there, I'm going to start at 20. And it goes up by 4s. So down here, so this was the cool way to go up by 1s. I'm going to change it and do it the uncool way. We're going to learn the cool way later. So liters equals liters plus 4. And if you want to know the cool way to do it for this, it's plus equals 4. Okay, so we'll leave that in comments right now. We're not actually going to do it that way. What else have I got to change in here? Here, liters to gallons. So gallons are going to be equal to liters. And then we divide by 4.54, and there's a bunch of other decimals. I'm going to leave it like that. Okay, our last part is to modify this. That's not Celsius, that's liters. We'll tab over a little bit, and then we'll write down the gallons answer. And then we make a new line. Okay, so I think we're ready to go. I'm going to do a little save. You always get nervous when you do some stuff. And let's see what happens here. So we'll put it in the middle of the screen. We'll press it. Whoa. Didn't crash on us. 20 is nice. Ooh, these long numbers for answers. I don't like that. Let's fix that up a little bit. Okay, let's see if you remember how to format decimals. I'm going to sneak in here and put an N2. And what that does is make it to 2 decimal places. Let's see if that helps. Yeah, now it's nice. Okay, so there is a chart that goes from 20 to 60 by 4s and works out the conversions from liters to gallons. So there's our first answer. All right, on to the next category of problems. And again, if you feel like it, try the other ones too. I'm trying to do one of each kind so at least you have a basic idea of each category. Okay, so in this one, how about we do question number 1? All right, so this one basically says, create a program which repeatedly prompts the user to enter the miles and then outputs the equivalent measurement in kilometers. Okay, so make sure the miles entered are positive. Recall that 1 mile is equivalent to 1.61 kilometers. So this one's pretty straightforward. So if I type in 2 miles, it's 2 times that. If I type in 10 miles, it's 10 times that. So this is a times type formula. Okay, this one reminds me of this one. Okay, so when I start programming it, I'm going to beg, borrow, and steal from this one and modify it to match the miles and kilometers. Okay, so first thing I'll do is I'll make another button. All right, and we'll name the button BTN miles to kilometers, and we'll slide down to the text miles to kilometers. And like I said, this reminds me of this one right here. So I'm going to grab the whole thing, and again, we're trying to leverage what we already know and sort of ease our way into solutions so we don't have to reinvent the wheel. So we'll double click on here and we'll paste it in. Okay, now miles to kilometers, obviously, so it's not radius anymore, it's miles and kilometers. Now, I noticed the question said, write a program which outputs the equivalent measurement. Make sure the miles are positive. Okay, so I got to do a little bit of dummy proofing too. Anyway, we don't need this. Okay, so this is an infinite loop. We're going to ask the person to enter the miles. And it shouldn't say kilometers or area here. We'll say mileage or something. Okay, and this is obviously going to go into miles. Okay, so far so good. Now if the miles, like I mentioned in the question, they want a little bit of dummy proofing. If the miles is less than 0, which means it's a negative, yell at the person, say no negatives. If we're good, then we're about all of that. The formula is not that complicated. So the kilometers are going to be equal to the miles times 1.61. Okay, and then message box, the kilometers are, and then whatever that happens to be as the answer. Okay, and then we ask the person, do we want to do this again? Okay, let's do a save. Make sure that we don't lose it. We'll press start to run it, and miles to kilometers. So if I do 100 miles, that's 161 kilometers. Okay, and do you want to do this again? Yes, I do. Let's do 50 miles. How much is that in kilometers? 80 kilometers. And do I want to do this again? No, and we stop. On to our third category of questions. In this one, we look at 4 next problems, and basically in this one, I'm just going to type over this particular button because I notice most of these questions, especially the first 3, basically it's a slight modification of the answer to this question. Okay, so let's start off. This first one says, write a program which sums the numbers 1, 2, 3 all the way to 250. Actually, pretty straightforward. Let's go into here. So we say the sum, that's okay, 1 to 250. So that changes to 250. And we're going up by ones. So you change that to 1. It's nowhere near as complicated as this formula here. All we have to write down here is I. And what I want to do actually is I want to write this out the long way. This is kind of like the cool short way. I'm going to write this out like this. Okay, this is called an accumulator, and we're going to really focus in on this in our next lecture. But this is called an accumulator, and what it is, it's a way to add up a bunch of numbers. And basically, when I is 1, this says sum equals sum plus 1. So this box gets a 1 put in it. Then we go up by 1s, and now we're at 2. So sum equals sum. Well, it's a 1 there. And now I is 2. So 1 and 2 is 3. So the computer scratches that out and puts a 3 there. So that's what we call an accumulator. It's a little bit different than a counter. Counters always go up by a set amount. 1, 2, 3, whatever. This one goes up by whatever the number we happen to be on. Okay? So that's it. That's how you do the first one. And we'll give it a run. It'll just give us a number answer. Nothing spectacular, but you'll get to appreciate. If you added up all the numbers, and again, this print statement's wrong, 1 and 100. So really it should be changed to 1 to 250. So if you want to be really correct, let's change that to 1 and 250. Give it a run. Okay, so the sum of the numbers between 1 and 250 is 31,375. Okay, now I'm not going to change the print statements and all these other ones. I just want you to make sure you understand the idea behind them. So the next one says, write a program which sums up the odd numbers between 27 and 99. Well, that's interesting. How do you make the computer go up by odd numbers? Well, it's not as hard as you think. If you're at 27 and you're going to go to 99, right? So from 27, the next number would be 29. That would be the next odd number. All you got to do is add 2. And then the next odd number is 31. You add 2. So I think we're ready to go. We're going to go from 27 to 99 by 2s. Okay, so we'll drop this down. And in here then, we go from 27 to 99 2s. Okay, let's take a look at the last of these 4 loop questions. This one says, write a program which finds the sum of the squares of the numbers 4, 9, 14, 19, all the way to 39. So they start at 4, that's for sure, and they go to 39, and it looks like they're going up by 5s. So 4 to 39 going up by 5s. So let's take a look at the program for that. So 4 to 39 going up by 5s, but the sum of the squares. So now we have to resort to that math.pow bracket I comma 2, and that's how you do the power of 2. So that would be the sum of the squares, 4 to 39 up by 5s. We'll just give it a run. Not that the answer is going to mean anything, just as long as we did it the right way. Okay, so that's the answer. And of course, this is wrong for that statement, but that would be the answer. Okay, so that's some of the logic for for loops. Let's finish up with the last question, which is the actual real practical example in this series of problems. Let me make it a little bit bigger so you can see it better, and then we'll take a look at it. A delivery service charges its customers based on a weight of the package and the distance it must be shipped. It has divided the area it serves into zones. The company calculates the charge using this formula. So I guess cost is equal to 75 cents plus 3 cents times the weight times the zone. So they want us to print out a chart for weights of 2, 4, 6, 8, and 10, and zones 1, 2, 3. So this one reminds me of that combination question, right? So let's add our final button of these problems, and we will call this button BTN delivery. Okay, and we'll call this the delivery question. And like I said, it reminds me of this question right here, the combination question. So I'm going to grab all of this from there to there, and I'm going to copy it and add it into this button. Okay, so let me sort of refresh myself here on the exact specifics of the question. So it says that we need weights and zones, all right, and we're going to work out the cost. So weights and zones, and we're going to work out the cost. So instead of area, we're working out cost. Instead of length, it's going to be the weight, and instead of width, it's going to be the zone, and then of course the cost. Okay, so weights. So this changes to weight, and I'm actually just going to call it WT. WT. We'll change the other variables in a second. And zone, so that one I'll spell totally out. Zone. Okay, and there's that formula, which is cost, and it's going to equal 75 cents plus the weight times the zone times, I think it was 0.03. Let's remind ourselves if that's correct. Okay, and they want the weights to go up 2, 4, 6, 8, 10. So where it says weights, we're going to start it at 2 all the way to 10 by 2. So it's plus equals 2. Okay, and the zones are just going to go up by ones. So it's going to go from zone 1 to 5 by 1. So let me just check that to make sure. Zones only 1 to 3. Okay, so it's not a big problem. We'll change that to a 3. Okay, let's give it a quick run and see. Whoops, I see a mistake. Our print statements down here have to be correct. So that's going to be the weight. That's going to be the zone and the cost. And we can fix the cost up in a second if it doesn't look good. So let's do this last one. Delivery cost is 81 cents, 87 cents. So these are the zones, 2, and then 1, 2, 3, and 4, 1, 2, 3. So a neat little chart with all the different costs. So there you see a decent practical application of looping, in this case using the for loop in terms of making a chart for like a per later type company or a FedEx type thing. Okay, so hopefully by going through a series of problems this time, you got a better feel for what it takes to do an application involving a repetition structure. We looked at all 3 types. We looked at the user controlled, counter controlled, and then the for loop type question. In this lecture, we're going to focus in on the concept of counters and accumulators. Now, we've actually been using them before this lecture, but today we're going to take a look at some practical applications and get an in-depth analysis of how they work and why they work. Today we're going to use a couple of pre-made demos to illustrate the concepts of counters and accumulators and how they're going to be used to work out averages. Okay, so in your demos, there are 2 programs. One's more an enhanced version. We're going to look at both of them. Let's load up user-controlled repetition. And I'll just give you a rough idea what it does, and then we'll talk about how it works and discuss these counters and accumulators. So basically what it's going to do is ask a series of questions, enter a mark. So I'll type in 80. Do you wish to continue? Yes. Enter another mark, 67. So I don't know if you remember, we did an average program like this before, but we asked 4 times, give me a mark, give me a mark, give me a mark. This program, what makes it different is going to be that I don't know how many marks I'm going to type in. I might have a class of 50 students, 25 students. Whenever I decide I'm done, I'll say stop. Okay, so that's the first difference. Okay, and I'll stop right now after 3 entries. And it works out that the average was 71. And we're done. Okay, so now let's take a look at what was going on behind the scenes. Now, a little bit of math background, first of all. When you have to work out the average of a series of numbers, ages, heights, weights, whatever, you need to know 2 things. You need to know how many people you asked that question to, so the number of respondents, and you need to know like a grand total. And then to work out the average, you take that grand total and you divide it by the number of people, and then you get your average, right? So these are 2 different ideas. When you count the number of people, you're using a counter. When you do a grand total, you use what's called an accumulator. Okay, now let's take a look at the actual computer programming of those concepts. So, first of all, remember, we need marks, we need a counter, we need a totaler, we're going to work out an average, and we're going to ask the person, listen, do you want to do this again, yes or no? We're using an infinite loop, which you've seen me use before. Okay, so everything between there and there is going to get repeated a number of times. I'm throwing in an extra little bonus command in here. Don't use it that often, but there's another kind of loop called a do while. Kind of almost the same as a while loop, except the condition is at the bottom instead of the top. So this says do, meaning ask the person, do you wish to continue? While the response, whoa, what's this? Exclamation mark, equal sign. Well, what that means is doesn't equal. So while the response doesn't equal yes and doesn't equal no, keep asking the person. So this is kind of like a little bit of dummy proofing, which means if the person wants to be an idiot and type in X, Z, W, I'm not going to let them go. Until they give me a yes or a no answer, they're going to stay in this loop. Okay, so a little bit of extra. If you don't understand that, don't worry about it, but it's kind of neat to show you. Now, if they do say, no, I've had enough, get out. If they don't, then ask for the mark. Okay, remember we have to convert it to an integer, and I like still using int.parse, but you can use convert to 32 also. This is a bit more dummy proofing. Okay, we're trying to get more sophisticated now with our programs, more professional, as you might find in industry. So this is saying, listen, if this guy types in a mark that's less than 0, or, remember those two lines? That means or. So one or the other can be true, then the whole thing's true. So if he types in a number less than 0 or more than 100, again, he's doing something stupid. He's typing in -1 for his mark, or 200. No good. Yell at him again. Now if he passes both of those tests, we're finally down to actually doing the math. So that's our first person. That's how you tell the computer you've got a person, and you count it. Now, this is like the cool way to do a counter. The old-fashioned way, and I don't really care which way you would do it, counter equals counter plus 1. That's like the long way. This is the cool short way. The second line right here is called an accumulator. Let me clear the screen out a bit for you for a second to see the accumulator in action. This is an accumulator, and again, the long way to write this line is total equals total plus mark. And what the computer does is has a box in its memory that's called total. And as you type in a mark, what happens is it keeps it in here. So once you've got your first person, okay, and that actually is a box too, which we'll call count. So we've got one person. Let's say that person's marked 70. So right now in this variable called total is a 70. Let's say you got another person. Once you get a second person, the counter makes that 1 become a 2 because now you have 2 people. And let's say that person's mark is an 80. So total equals total. So it used to be 70 plus 80 adds up now to 150. All right, let me show you this in super slow motion just to make you really understand the concept. So I'm going to press F11 like I usually do, and we'll kickstart it and go into the program. Okay, so here we go. So press calculate, and this initializes all our values. Now we're in the loop, and this is going to ask us, do you wish to continue? I'll say yes. Okay, and I'll widen this a bit more so you can see it a little better. And what happens is here, my response is a yes. Okay, so that's good. It's a yes, and it's not a no yet, so I'm not going to exit. Now it's going to ask me for a mark, and I'll type in a 70, and I'll press OK. So now the computer's got in its brain a 70, and that's a good mark. It's not a negative or over 100. And now we get to this line, the counter. So now we've got 1 in the counter. This accumulates, and we've got 70 in the accumulator. Now we go back up to the top. It's going to say, do you want to do this again? Yeah, I'll do it one more time. So I'll press yes. Okay, and I'll press F11. I didn't press no, so I'm not stopping yet. It's going to ask me for a mark. This time I'll type in an 80. Okay, and obviously 80 is not a bad mark, so I'll skip down. Now the counter is going to be 2. And the total, remember it was 70. I'm going to add an 80 to it to get a grand total of 150. I'm done now. I don't want to do this again. So next time it says, do you want to continue? I'm going to say no. And I'm going to press OK. And then I'll press F11. This time I did say no. So it breaks and it goes down to the bottom. Now this line here, remember what that exclamation equal sign means? It says doesn't equal. So if the count doesn't equal 0, which means I had at least one person, I'm going to work out the average. And the average is the total divided by the counter, and it prints out the average of 75. So there is the entire thought process from beginning to end. We've taken the total, divided it by 2 to get our 75 average. So there is a typical application of counters and accumulators. Now we're basically going to do the same question again, but make it more sophisticated. And we're going to use those user-defined dialogues. So my second example here is called User Control Repetition Revisited. And we'll give it a run again. It's basically the same one we just did. We're going to press Start and slide it down here. And notice this time, okay, do you want to continue? Yes, I do. This time what it does is it pops up a user dialogue. Okay, that's the only difference. And you can type in your mark again and you press OK. And then it says, do you wish to continue? I say yes. Okay, and then I'll type in another mark. Do you wish to continue? No. And it prints out the average. Okay, so that's the only difference. And I'll just show you a little bit of the code to wrap up this little lecture. Okay, so again, we initialize all our counters and accumulators. We have our while loop. And the only difference is here that we use the show dialog. So we use the user input form, and then we check if they pressed OK, and we check if the student mark doesn't equal nothing, and then we take the mark, we check for 0, okay, and again down here we check if the counter doesn't equal 0. And again, if you don't get that, I don't know if you know your math, but if you try to divide something in math by 0, you're going to get undefined, or the computer is going to crash on you, okay? So what we're doing here is we're making sure that there's at least one person when we work out the average, okay? So we're trying to remove this possibility. If we do get that possibility, no marks were entered, and we'll try to exit gracefully. Another little reminder while we're here, in user input, remember that does that crazy stuff with those gets, okay? So we have a public string called student mark, and that's how we return the mark. Okay, so 2 simple examples, and what I want to finish up with is to show you if you really got motivated to write a program that involves now all the different ideas we've learned over the last 4 or 5 lectures, if statements, repetition, and that. And here is the actual question. So you'd want you to write a program which asks the user for their age and height. And the ages have to be between 13 and 18. When they give you that information, you have to sort of segment out the averages. So I want to know the average heights of all the 13-year-olds, 14, 15, 16, 17, all the way to 18. So there's a lot of things going on here. And what I'm going to do here now is I'm going to stop the video for a few minutes, maybe longer, and then I want you to come back and you'll see how I took up this solution. As I've mentioned before, almost all the solutions to all the things that I do in this lecture series are in those demos that I give you at each and every lecture. So the answer to the question is in this folder here called age height. Let's load it up and see what it looks like. So I'll give it a run first, and then we'll take a look at the code. So basically, we're going to use the full dialogue entry technique, user dialogues, everything like that. So do I want any more entries? Yes. There is our homemade input box. I'm going to type in an age. Now if I type in a 12 and then the height, I get an error, okay? Because I'm only accepting between 13 and 18. So I've got a nice dummy-proof program. Any more entries? Yes. Let's type in a legitimate one this time. Let's type in a 13-year-old, height 55. Okay, so it accepted it. Let's do another one. Let's type in a 14-year-old, height 67. All right, I'll type in one more. Let's type in another 13-year-old and height 68. Any more entries? No. And what it'll display, and I didn't have any 15, 16, 17, or 18, is each age and the average for that age. Okay, so that's what the question was intended to do. Now, how did I actually do that? All right, let's take a look at the code. And there's quite a lot going on here. Now remember, we're going to use the dialog to get, do you want to continue, yes or no? We're also going to use a homemade input box, so that's being set up there. And then we've got a bunch of things. We need 13, 14, 15, 16, 17, 18 for the accumulators and counters. So we need separate variables for the counters and accumulators, and we also have to work out all the averages. Now, it's proper form also to initialize all your counters. And now we get into our main loop. So we're going to use an infinite loop. We're going to ask the person if they want to continue. If they say no, we exit and we're out of the main loop. If they say yes, then we make the homemade input box pop up. Now on that homemade input box, we have a number of values. We have a box for the person's age, and we have a box for the student's height. If those boxes are empty, then we're going to tell them you're missing important information. If, in particular, the age one is empty, we'll tell them you're missing the age. In particular, if the height one is missing, we'll tell them you're missing the height. So lots of advanced dummy proofing techniques. Some more possible dummy proofing. If they tell us the age was less than 13, they tell us it was 12, or if it's more than 18, they tell us it's 19, we're also going to yell at them. And one more dummy proofing before we get to the actual calculations. If they type in a negative for the student height, then we're also going to yell at them. Now the moment of truth. We've passed all the different tests. Let's see if they're 13. If they're 13 years old, then I'm going to make the 13-year-old counter go up by 1, and I'm going to accumulate that person's height for the 13-year-old. And I do that for all the different ages, okay? So that's how you segment them off. You say, hey, are you 13? Great. Then I'm going to make the 13-year-old counter go up by 1, and the accumulator for that counter to go up by 1. And you just keep doing this over and over and over again. Eventually, the person says, I've had enough, and you break, and you go all the way down to outside of the loop. And now you do a bit of dummy proofing here also. Because remember what I told you before, if the divisor is a 0, then you can't do the math. Because if you try to do the math, it will crash on you. So I always check and say, hey, is there a 13-year-old? So C13 doesn't equal 0, that means there's at least 1, then work out the average. Otherwise, make the average 0. So there it is from beginning to end, the entire calculations, and then we print out the results. Let's review over here the user interface. Notice we have 2 boxes, okay, and their names are text age and text height. Then when you go into the underground for these, we have the public age and the public student height. So when we were referring to them in our main program, you'll notice that they were called input dot. Remember what we did up here? We said we had a user input called input. So to refer to those ages and heights, it was input.age and input.student-height. So much more sophisticated type answer than we're used to, but it's a nice way to review everything we've done. If statements, counters, loops. All right, so it'll give you a nice overview of everything, and hopefully you're ready to do our last topic in the unit on selection and repetition. So thanks for listening, and hope you got the basic ideas. This is our last lecture in the basics section. What we're going to do today is take a look at 2 controls that add to the usability, the user friendliness of a program. We're going to look at the combo box and the list box. All right, so I'm going to work through 2 examples. The first one we're going to do together as we get acquainted with the basic setup of a combo box and a list box, and then I'll have a nice little application to show you how it can be applied to real examples. Okay, so let's start off, and we'll make a new project as we always do, and we'll call this one combo. Now, I like to always explain the why of why you would want to use this control or any of the ideas that I ever teach you. And when you create a website, you don't want to depend on users typing in information the right way. Sometimes they spell it wrong and it could throw off your program. That's one of the reasons why I want to do a combo box. The second reason is it just makes it faster for users to use your program. If they can drop down and pick from a list, it's way faster than them having to type it in. Okay, so let's call this form combo. Okay, and we'll put the title on the form also, just to make it complete here. Combo box examples. All right, and we'll start off with the actual combo box. Now, combo box is right here, and we'll put it right in the middle of the screen. It's totally empty. Combo boxes should be called CBO, and then we'll just call it test. And we're not going to put any words in it right now. I just want to run it for a second just to show you what it'll look like. All right, there's going to be this box, and when you press this arrow down, a bunch of words, numbers, cities, whatever is going to show up there. Okay, now how do you fill in that combo box? And that's what I want to do next. And still no programming. We're going to do it in pure property settings. And let's slide down for a second while I remember. And I'm going to make the form pop up in the center like I usually do. Okay, let's go back to the combo box. Now in the combo box, there is a property called items. And if you press just to the right of this word collections, there's 3 dots. And this is where you can, there's several ways. One of the ways to fill in the combo box. And I'm just going to type in some city names. Okay, and I'm going to press OK. Now when we run it, watch what happens. The combo box has those city names. Isn't that cool? All right. Now when I pick one, how does the computer know I've picked one? Well, if this was part of a large program, there'd probably be something else like a button or something that would start the rest of the program. So let me just prove to you that we know what we've picked when we click on it. And actually, I'll put the button down here so it's not in the way. And I'm not even going to really name the button. I'm just going to go straight into here, double click, and I'm going to do a message box dot show you picked, and I'm going to write down the city you picked. Now the combo box I used, I called it CBO test dot text. That's all there is to it. Okay, that'll tell you what you picked in the combo box. Let's try it out. So if I pick Toronto and then I press the button, you pick Toronto. If I picked Montreal, and now for our American friends, if I pick New York, it says you picked New York. Okay, so isn't that cool? Very simple, not a lot to do. That's how you fill up a combo box and then see what you picked. And you see the whole point of it, right? It's just to make the user experience a lot easier for them. They just have to click from a bunch and that's it, not type in anything. Now, there are several ways to fill up a combo box. The second way is to do it right in code as opposed to typing it into properties. And by doing it in code, you can add to the combo box via a button or something else. Now, this second technique, what I'm going to do is I'm going to put it into form load. So as the program runs at the beginning, it's going to magically behind your back load up the combo box. And all you do to do this is you go CBO test dot items dot add, and then in brackets you write whatever you want. So you could type in some other cities, for instance. We'll type in Vancouver, and that'll fill up the combo box. Okay, we'll type in Buffalo. And that is the second way to fill up the combo box. That's via pure code. Now, if we run this program again, hey, there's the last 2 I just typed in, right? Okay, they got added in right at the beginning of the program start. Now, these were already there, so they got added to the bottom. And that's the basic idea of a combo box. Pretty straightforward, eh? And really neat. And then once a person picks whatever they want, it gets processed in the program via maybe it does some math or decides on some other situation. And I'm going to give you a practical example in a second. The second kind of design control that I want to look at today is called a list box, okay? And it's going to look a lot like the combo box. Here it is right there, list box. And I'll put it, you know what I'm going to do? Actually, I'm going to widen this a bit. And I'm going to put it over here. Okay, now list boxes should be called LST, and we'll call this one also test. Okay. List boxes, I'm going to widen it because they don't really drop down like your traditional drop down box. Okay, I'll run it for a second just to show you. It actually almost looks like a text box. And that's where the similarity kind of comes in. You know, when we did that one example a couple lectures ago where I had so much stuff in the text box, I had to add a scroll bar and the multi-line property. Well, you can use a list box like that. Okay, now watch. I'm going to fill this list box with stuff. Just numbers. A lot of numbers though. Okay, and this is where it ties in with what we've just finished recently, loops. If I wanted a fast way to fill this with maybe 1,000 numbers, it would be stupid to go into form load like I just did a few minutes ago and hand type every single number, because I could do it and that would be valid and it would work, but that would be, you know, very inefficient. So let's double click in here. We're going to go into the code and I'm going to say for integer I equals 1, I less than or equal to 1,000, I plus plus, which means we're going to go up by ones, and then we'll add some squiggly lines. And now what we'll do is we're going to add to the list box. And it's almost the same commands. Actually, it is exactly the same commands. The only thing you have to realize is when you're adding the I, which is going to be 1, 2, 3, 4, 5, make sure you convert it to a string. And that's it. That's how you can very quickly fill up the list box. Now, could you do that with a combo? Yes and no. If you were going to type in special cities, no, there's no kind of easy, slick way to do that. But if you're doing it pure numbers or a chart or something, yes, this would be a nice way to do it. Let's take a look at it when we run it. So now when I press this button, in a matter of seconds, we have the numbers 1 to 1,000 in the list box. Isn't that cool? Okay, now just like I did with this example when I said I pick Chicago and it tells me Chicago, how do you know if maybe a student or somebody wants to pick number 6 and use it to do something? How do you know it's been picked? Okay, let me show you that. Throw in one more button in here. And it's really easy. It's exactly almost like the other one. So we're going to double click here and I'm going to say something like message box dot show you picked number, and then we'll say lst test dot text. That's it, just like the combo box one, and we'll give it a run. So first of all, we have to create the numbers. There's the entire list. I'm going to click on 970 and that tells me that I picked 970. Isn't that cool? Okay, so these are two examples of controls that could make a user's experience nicer, okay, by either having them be able to pick from a list of words or pick from a list of numbers. Now this list box can also do other things, like you can display numbers and other results. And just to finish up this little introduction to list boxes, here's what you can do. In this list box, we could also attach, and I'll add a little space, like a math equation or formula or something. How about we take the math.pow, math.pow of I, comma 2. So we're going to square each one of those numbers, okay? And then we'll add another bracket there. And I think we're going to be able to run that. Let's see what it says. Okay, so it's looking for another plus sign here, because when we attach, you attach the blank to the math. Okay, let's give it a run now. Press this, and you have the number, and right beside it, the square of the number. So this list box can actually be used like that text box, and it's not as complicated because you don't have to add the sort of new line character at the very end to make the computer go down. It just does it automatically. Now let me see what it says if I click on here. So I picked 864, so it remembers the whole thing, the number and the answer. So there you have it. This is what it's going to help us become more user-friendly and create programs that are easier to use and quicker to work with. Okay. Let's finish this little lecture on controls called combo boxes and list boxes by showing you a little sample application. Going to go to projects. Now these are in the demos that you should download. Remember, you've done selection, user-defined dialogues, repetition, and this is the last one here, combo list boxes. Let's double click on it and we'll click on combo box demo. And very simplistic application, but it shows you how you could use this in real life. We're going to give it a quick run. All right, so here's a combo box and I get to pick an employee that works for me. And here's a little sliding, remember those scroll bars? This one's a vertical scroll bar and I can put down how many hours the person worked. Okay, and then here are some rates of pay. So let's say they get $9.50 an hour, and then I press compute and it works out the answer. So this is demonstrating how you could use it in a sort of simple salary type program where you're working out somebody's pay. Let's see what happened in the underground. So first of all, that's a combo box, obviously, and that combo box is called CBO employee names. This is just a regular text box, but it's being fed in by the scroll bar. And if you forgot how to do this, why don't we click on this for a second and we'll take a look at the code. So this one, the vertical scroll bar is called VBSHours.value. And remember, it is an actual number, so we have to put quotes on it. So this is another way to do quotes, convert to string. If this is freaking you out, it's not necessary. We can also do it this way, remember? And actually, this is my favorite way to do it. But either way will work, okay? So that'll take this and convert it to a string and put it into there. All right, next one, this combo box. How did it get filled up? Well, remember that trick I showed you a few minutes ago? Behind your back, when you are starting a program, in form load, what I did is I used a loop. Now this one has decimals, so I can't say for int I equals. So I said for double I equals 5.5 to 10, and we're going up by 0.5, so 50 cents we're going up by. And this fills up this combo box right here with numbers. All right, now the moment of truth. We are using the result of this box. Let's say it's 40, okay? And we're using the result of this box. So let's say we picked 9.5. Okay, we're going to times those two together and put the answer in here. All that magic happens right here. So let's remember, we got to remember what that box is called right there beside the hours. We've got CBO rate, okay, and then we're going to put the answer in here. So let me just check again. So that one's called text hours. This one's called CBO rate, and we're going to put the answer into text gross pay. So here we go. Okay, so remember, we've got combo rate dot text convert to double times text hours, and we're going to put the answer into here, and then that answer now is a pure number, and then to show it off with currency and put it back in the text box, we do the toString to text box. Again, if this is freaking you out, you don't like this way, we have another one called double.parse. Double.parse. Okay, and it'll work exactly the same way. So one more time, just to finish up, we pick a worker, we give them a set number of hours that they've worked, we pick a rate of pay, we compute, and we get our answer. Okay, so there you have it, a simple application of using combo boxes and list boxes. Okay, so hopefully that you've found that interesting and you can apply it to future ideas that we're going to talk about. And now we're going to go on to the next major section, which is problem solving. Really important set of ideas that make you plan out answers, just not go to the computer and start typing right away. So we'll see you in the next lesson. Welcome back, and welcome to our next section on problem solving. Problem solving is the process of finding certain information that is not known from a set of information that is known. In other words, problem solving is not an end result, but rather a process, okay? So problem solving is a very logic-based activity and requires structure, and that's what we're going to cover in this lecture today. We're going to look at specifically the software life cycle, and then we're going to try to go through all the steps that it would involve, from thoroughly understanding the problem, breaking it down into component parts, arranging a solution in a systematic way, and then translating the solution into computer language. A lot of times when students get excited about programming, they forget that we're just doing simple little programs. But if you have to attack a large problem, you can't go straight to the computer and start typing the code. You have to plan things out, and that's what we're going to endeavor to cover over the next couple of lectures. All right, so now let's look at this model that we're going to talk about over the next couple of minutes. So it's called a cycle because it has a beginning and an end, but then it restarts and goes again and again and again. So basically, in the first part of the cycle, you have what we consider the problem statement, where we have a problem that we're going to try to solve, we analyze it, we check what we need to do. Then we start to design a program, not right away going to the computer, but maybe on a piece of paper, we rough out a solution, we work out an algorithm, we look at various techniques. Then yes, we finally do code, okay? And then this is where you spend a lot of your time. You test out your code. You fix your bugs. You debug over and over again until it works. And then you basically have a system that works, but then you have to maintain it. You have to update it from time to time, add new features, and the cycle begins again. Okay, let's take a more in-depth analysis of this. So here are the 5 steps. I call them the 5 steps. So in step 1, you identify the problem. So sometimes somebody will come with you and say, I want a program to do this, or maybe you dream up something in yourself, okay? So you have to thoroughly understand what you have and what you don't have and how you're going to calculate it or get it from the program, okay? So that's called identify and analyze the problem. In step 2, like I said, you don't go right to the computer and start typing in information. What you do is you try to doodle it on a piece of paper, maybe draw out something ahead of time. And sometimes we call that fancy word develop an algorithm, a series of steps just in regular English right now, or pseudocode, sort of code. The one we're going to focus in on is called a flowchart. So we'll talk more about flowcharts in the next lesson, okay? Also, once you get a basic idea of what you want to do, you may want to doodle how it's going to look on the screen. You're going to have some buttons there, maybe an image there. So again, you're just doing something roughly sort of what it's going to look like as a computer program. Then eventually, yes, you do code, all right? And we have a basic idea of what we want covered, and we start executing the code. And code consists of various requirements. You just don't code. You have to also describe to yourself and other people that may come back and add to your code what you're doing. So you have to also include comments in a variable dictionary, and we'll demonstrate some of those ideas also in the next couple of lectures. Step 4, and this is the part that you spend a lot of time on, you have to test the program out. So you run it, you have an error, you fix it, you run it, you have another error, and you continue to debug the program as you go through it. And we'll look in the next couple of days at several types of errors that you can have and how to deal with them and how to fix them, okay? And several techniques. So again, these are just an overview right now of what we're going to do, and gives you a rough idea how you would attack a problem in a systematic way. Maintaining the program basically means updating it. And you guys know, by buying stuff on the internet and stuff, you always get updates to Windows, an iOS system, whatever. And those are maintained by programmers that say, we've had a complaint from a user, or they want this implemented. So that is the steps. And then you go back to the beginning and you identify and analyze the problem and fix that problem and figure out a way to make new updates and code again, and then test again, and then maintain it. So it becomes, as we say, the software cycle. In this lecture, we're going to look at one of the tools you can use to describe a solution to a problem. Sometimes we call this an algorithm. And this technique we're going to look at, called flowcharting, is not going to give you the exact commands you use to type in C#, but it'll give you a general overview of how to solve a problem and the steps that are going to be required. Now, there are a lot of freely available tools on the internet that you can download and install on your computer, or actually just play or use right on the web browser. The one I'm looking at right here is SmartDraw, which is a program you would download and install. And let me just show you what exactly a flowchart looks like if you have no idea what I'm talking about. So a flowchart is a description of a process that uses symbols like ovals and rectangles and diamonds to represent what a program's flow and steps are going to be. It doesn't give you the exact computer commands, as you can sort of see from the images here. Let me go back for a second, and here are some of the symbols you use when you do a flowchart. Okay, these are the most common ones, and we'll take a look at each one in a second. The second location that we're going to go to is a site called Gliffy, which I actually like because there's nothing really to install. You can play it right on the browser, and I'm going to use that actually for today's example. Okay, so when you start up Gliffy, it'll give you a rough idea that you're going to basically, from the left-hand side, drag and drop symbols over to the other side, and those symbols will represent actions that you're going to take in your program. Now, before we can actually start drawing in Gliffy or whatever program you want to use to create your flowcharts, let's make sure we understand the key symbols and what they represent. So the oval is a symbol we'll use always at the beginning of a computer program or a representation of a computer program. So you'll see when we do our first flowchart that we'll always start off with this, and we'll actually put down the word start. Okay, so that is kind of the formal way to start your flowchart. These other symbols will always be connected by the arrow. So you'll see a lot of arrows in flowcharts just because of the name, flow. This parallelogram is used to represent, like if you had a program where you say, hey, please enter your age, that would be represented by a parallelogram because that's input. Or if then you worked out a person's average and you printed out the average, that would be output. So again, you would use a parallelogram. The rectangular shape is used for a process. Let's say you do a math formula. That would be represented by a rectangle. And this one you see a lot of also diamonds. Those are like for if statements when you do decisions, okay? So those are going to be our bread and butter. There are other symbols that you use, but these are the ones you use most of the time. Okay, we're back to Gliffy, and now we're going to use it to create our first algorithm, a representation of a solution to a problem. And the problem we'll look at is, let's say we wanted to write a computer program that would ask a user for their age and then display the cost of a ticket to the show or something like that. And if they're 16 or under, we're going to charge them $10. And if they're over 16, we're going to charge them $20. Okay, so let's start off. And as we always do with flowcharts, we will drag a little oval shape. I'll make it a little bit bigger, and I'll type in the word start. Okay, so that's what you always do at the beginning. Now we're going to ask them a question. We're going to ask them the age. So that's called a parallelogram because that's an input. Now here is basic shapes. I'm going to press flowchart. This has all the ones that I really need. And there is the parallelogram, and we're going to drag it over here. And we're going to say enter age. Okay, whoops. Next, what we'll do is we got to make a decision. Next, our decision is going to be, are you 16 or under or more? Now, the diamond shape is used for decisions, so I'm going to drag that in there. And I'm going to say something like this. Age less than or equal to 16 with a question mark. And I'm going to slide this up. And one of two things is going to happen. Whether it's true, great. If it isn't, then something else. Now that means we're going to do a bit of math. Well, not really a lot of math, but we're going to assign the bill or the cost is going to equal $10 if it's true. And if it's not true, it's going to do something else. And the cost is going to be $20. Okay, now remember, rectangles are for sort of mathematical equations or assignments and things like that. Diamonds are for if statements. Parallelograms are for input and output. That's the oval shape to start us off. Okay, and once we're done these, we are going to display the result. And the result we'll put down here, and we'll say display cost. Now, we're not totally done, but this is the basic setup. We have to now join all these. And I like using from down here these arrows. They seem to be a little bit thinner and nicer, okay? So the way you put the arrow in, you go like that, and then you rotate it so it joins up like that. So there's the first one. And then we'll drag this one in here. Hopefully it sticks. And then we rotate it downwards. All right, the next part's the really cool part. We're going to press the arrow again. We're going to connect it there, hopefully. And then we're going to drag it to here. And notice how it sort of bends and it goes with it, okay? All right, then we're going to grab the arrow again here. Connect it there. Rotate it downwards. Okay, and there are a little bit nicer programs than this, but this is good enough for us. And then we'll do another arrow here. Rotate it downwards to make it look fairly straight. I don't have that steady of a hand. Okay, and then down at the bottom, we need an oval, which actually there's ovals here too, right? This is the more correct oval. I like this one better. And this will be to stop or end the program. And we'll grab another one of these arrows. Straighten that out. So that was pretty straight. Now there is one problem. Okay, so we start the program. We enter the age. We check if the person's age is less than or equal to 16. Now, how do I know this is the yes and this is the no? Well, I don't. So I'm going to press this letter A, and I'm going to say true. If that's true, we do this. And then automatically this is false. But if you want to write down the false here, you can write false here. And so it'll know that if this is true, we do this. If it's false, we do this. And then we display the cost. Now, there is one issue. This is in sort of la-la land. Like after you do the cost, how do you flow back to here? So I'm going to show you this other little thing that we do. I'm looking for a circle. I hope they have a perfect circle. Yeah, it's called a redirector. I'm going to drag this right here. Now that's way too big, so we can sort of shrink it a bit. And after the cost of 10 is assigned, I'm going to put the letter A in here, and it's sort of a redirection. And I'll show where we're going to go in a second. But I'm going to need a little arrow first. All right, and I'll rotate this down. And what this is telling us, after the cost of 10 is worked out, don't do this one, obviously, the 20, but put yourself over just around here, just before the display cost. So we're going to add another little circle here, and again, we'll shrink this down. This is a redirection. That wasn't one of the ones on the chart. Okay, and I'm going to type in the letter A in there. And I'm also going to put a little arrow. Now, if you want to, you can use the thicker arrows, but I'm sticking with these ones that I like. Okay, so it redirects to there. So there is your entire flow chart from beginning to end. We have a start. We enter the age using a parallelogram. We make a decision. Age less than or equal to 16. If it's true, then we charge them $10, and then we go to A. And then from A, it flows down to display cost, and we're done the program. If this isn't true, you're 17, 18, your cost is $20. And then we go down to display cost, and we end the program. So there is an example of using a flowchart. So if you've never used one before, it's kind of neat. Now, a more professional program certainly is this one called SmartDraw. This one's a bit pricey. They do have a free download, which you can try for 30 days. And it's a really neat program too, but you will use this somewhere along the line to help you do solutions to problems. Okay, so there is an example of how to use flowcharts. Hey guys, welcome back. And today, yes, we are going to go back to programming in C#. I know I get excited too to program. In the last two lectures, we've been doing a little bit of theory about how you attack a problem. And one of the things we mentioned during the last two lectures was that one of the steps in the problem-solving approach is to after you've actually started coding to spend a lot of time debugging, and that's what we're going to focus in today. So although we're excited, we're going to actually try to figure out how to get through problems today, how to fix your mistakes. And it's going to bring out one of the characteristics of a good programmer. You got to have perseverance. You got to have stick-to-itiveness. So I'm going to teach you some tricks of how to solve problems and not give up when you are faced with an error. Okay, so we're going to finish that today. All right, I've loaded up Visual Studio, and what I'm going to do is use the demo in today's lectures to be the basis for our debugging techniques. So let me go back up here for a sec, and we're going to go into my lecture demos, and the program we're going to look at is called Debugging User Controlled Repetition. And this might look familiar. It's a program we did in the previous lectures on repetition, and I'm going to use this as a basis for showing you how to debug your program. So let me just pop it up for a second. And if you forgot what this program is, I'll quickly give you a quick run for a sec. So it's the program where you basically ask the user, do you wish to continue? And then you entered a mark, and you kept on going. And then when you were finished, it worked out the average. Okay, so first thing, let's go into the code. There are basically three kinds of errors that you can make as a programmer. The first is the simplest one, and it's called a syntax error. That's where you type a special word wrong. So let me just, for the sake of giving you something really simple, I typed in while wrong. Okay, now obviously, as soon as I pressed run to start it, here's what would happen. All right, it would say an error, and always press no. And then down here at the bottom, it would sort of give me an idea what's wrong. So it's basically telling me the name Will does not exist in the current context. So it gives you a rough idea something's going on wrong here. So these are the simplest kinds of mistakes, hopefully, to pick up, because the computer basically stops at the spot where it happened. And that's called a syntax mistake. Okay, so now that's an easy fix. We press run, and we shouldn't get that error again, and it works again. Okay. The second kind of error is called a runtime error. And basically, the program runs, but through the process of running, either through something you type in or don't type in, an error occurs that you may not have considered. And the way I'm going to show you this one is I'm going to go into the code, and I've done this already. I have commented out most of the stuff down here, and actually I'm going to comment out this message box too. Oh, actually, do I need the message box? Yeah, I'll keep the message box. But I've commented out the if statements, and there's the average, and there's going to print out the answer. So let me give you an example of what's going to happen here. So when we run it right now, I'm going to type in things. Okay, and I'm going to type in no, and it works. So you're thinking, well, what's the error? I don't see any problem. Let me show you now the runtime error. What if I say no right off the bat, like I don't type in any marks at all? The average is nah, and well, that's kind of a funny way for the computers to say we just crashed, something happened. And if you remember something I mentioned when we did this lesson, right around here, what the computer is doing is counting. So as I say, yes, I've got a mark, I count it. But if I don't type in any marks, the count is 0. So when the computer comes to do this formula, it'll take 0, actually, because there's no total either, divided by 0. And in math, if you divide something by 0, it's undefined. You basically have crashed the program and gave it an incorrect response. Okay, this is called a runtime error. All right, so that's the second kind of error that happens when you don't consider all the possibilities, and then the computer crashes in some way. Okay, so obviously let's put these back so that it doesn't crash. So if you forget, why these were even in here, this was to take care of 0 in this case. So we're saying if the count doesn't equal 0, work out the average, otherwise say there's no marks. Okay, so that's the second kind of mistake that you can make in a computer program. The last one is the hardest one to find. All right, and I'm going to show you right now what I'm going to do. I'm going to reverse these two, and I'm going to have count divided by total. All right, and I'm going to run the program again. And I'll type in, I got a 90 and an 80. And I'm going to say, no, I'm done. And the average is 0.01. So I've done this for years with students, and they'll go, hey, sir, I got an answer. Great, my program works. Because you're so happy that everything's working, but it's not really working. That's an error. That doesn't make any sense. This is a logic error. This is the third kind of mistake that could happen in a computer program. This one's sometimes the hardest to figure out because, obviously I know where it happened because we just did it right in front of your face, but most of the time you've done something really slightly different and everything seems to be working perfectly, but the answer is way off. And you're wondering, what do I do? What did I do? So this now introduces some of the tricks that you can do to zero in on particularly logic mistakes, okay? The first one I like to use, and since I know the answer is wrong, I'm going to go over here to the side of here and add this little red mark. And that's called a break point or a break. And what happens there is when the computer is running, and it's running quite a bit, eventually it has to get down to here. When it gets down there, I'm going to stop the program. Well, I'm not going to. That little red circle is going to stop it for me. And then I'm going to investigate around the area where I think something could go wrong, what the values are. So let me give you an example how it works. So when you press run, see the program doesn't stop yet. I mean, it's going to be merrily going along its way. So you're going to type in yes, I got a 90, yes, I got an 80. And now I'm going to say, no, I'm finished. Now look at the program stopped. It doesn't print out an answer or anything. It just stopped right there. So what do you do when you're around here? Well, what you start doing is digging around and looking at different things. So you go, hey, what's the count? Oh, it's 2. That makes sense. What's the total? 170. Okay, everything's making sense. Average. Well, it says 0 there, or it's going to be something like less, like it's going to be a low number. So that's messed up somehow. Then you hover over the count. 2 divided by 170, and you go, does that seem right? Oh, it should be the other way around. And then you can get rid of this breakpoint. Now it's gone. And go, well, that should have been the other way around. That should have been total divided by count. All right, and then you run it again. I hope everything works then. And then you try it again. And this time it doesn't have the breakpoint, so 90. I think I typed in 90, 80. Okay, I think I typed in a 0 or something for the first one, but the average is 44.5. So it is now working, okay? So basically, that's one of the ways to do it. Now, there's another way that I think I've shown you in several of the other lectures, which I love, okay? And that's called stepping. That's when you go in super slow motion through the entire program, line by line, and you see what it's doing behind your back. And if you click on the debug menu and you're wondering, how did you know it was an F11? There it is right there. It's called step into. Okay. This other one we'll use later on in the course too, F10. And I guess you can use an F9 to do what I just did. That was called breakpoint. All right. And just for fun, one time, let's do F11 in this program. Okay. Remember, what it does is show you every single thing it's doing behind the scenes, even before it actually gets to the part where the screen shows up. Okay. We're just about there. All right, now this is going to make the screen pop up. Beautiful. We press calculate, and then each time you press F11, and it's initializing the variables. Now it's into the loop. We've started the loop. Press F11. This is going to make that little input box pop up. I'm going to type in Y for yes. Okay, and then I'm going to press F11. And my answer, which is a yes, does not equal no yet, so I'm going to continue. This is going to grab the mark. I'm going to type in a 70. Okay, and then the mark, which is a 70, is definitely not less than 0 and definitely not more than 100, so it's good. And we're going to count it, which means now I have one mark, and I'm going to add up the mark, which was a 70, and the total is 70. We'll go up one more time. Okay, and again, I'll say yes, I want to continue. Type in a mark. This time I'll type in an 80. Okay, and each time I'm pressing F11. This is going to count it and accumulate. This time now we have a counter of 2 and the grand total of 150. Beautiful. Go up one more time, but this time I'm going to stop. So this time I'll type in N for no. This time the response of no n equals n. So we're going to hit the word break and we're going to shoot down to after this little squiggly line right there. Now it says, is the count not equal to 0? Well, it's 2. So yeah, that's good. We're going to do this. So we're going to take the grand total of 150 divided by 2, and you get 75, I hope, and it's going to print out 75. Okay, so that's the second technique I like to use when I'm checking through my program to see if it works right and checking for errors. And that brings us to the end of this lesson. Thanks for sticking it out, for hanging in there, not giving up. Okay, that's one of the main characteristics. And onward to the next lesson. Welcome back. In this lecture, we are going to look at a programming technique called methods. And it sort of flows with this concept we're in right now called problem solving, because we're trying to be very logical, very systematic, very structured when we create solutions. So what methods allow us to do is become very organized in our programs. They're almost like programs inside of programs. They also are going to make our programs more efficient. Okay, to explain the why of why you would use a method, I'm going to start off with kind of a corny example, but it's going to prove my point. So I'm going to go to open a project, and we're going to go to our demos. And inside of the problem solving unit, which we're in right now, I want you guys to go into methods number 1 here, and we're going to load up this thing called song method. Now this is a very simple program. It's kind of stupid to even run it, but the coding's more important. Let's just run it for a second. It just basically displays a series of text, little song, and then it has the verse of the song. Then it does the second part. Okay, and it just continues throughout the entire song. Okay, so what's going on? Who cares about this? Well, let's go into the code actually. All right, so like I said, all this is doing is repeating some text to a song and then making a message box pop up, which is like the verse of the song. And then it adds more text to the song that was in a text box and then pops up, hey, aren't these the same words? Yeah, they are. Oh, these are the same words again. So it's always repeating the same verse over and over again. So there's where a light bulb should go off in your head. This is a classic example of where this new technique I'm going to show you called a method would come in handy. If you find yourself writing computer code that repeats throughout your whole program, you can take those snippets, 3-4 lines, maybe even more that repeat, and put them in a special section in your computer. And every time you need to recall them, you just call this special method. Okay, now how do you make this special method? Where is it? So here is basically the same program using this method. And what we've done is every place there used to be those 2 lines repeating the verse, I've now written this word verse bracket bracket. Now, what the heck is that? Well, I'm going to slide down to the bottom of the screen and I have hand typed the word private. I've hand typed the word void, and then I've hand typed the word verse. So I've made my own, what we call a method. And tell you the truth, you've been using methods all along, you didn't know them. These are called event methods, that they basically are automatically done for you by Visual Studio. So when you click on a button, it automatically makes a button click method, which has stuff in it. Well, what we've done now is created our own that doesn't depend on a click, and we've called it private void, and then you make up whatever name you want. And void means it doesn't return with an answer. It basically, you're doing something right at that method, and that's it. And what we've done is we've added those 2 lines that we used to repeat all through the song, and we've put them in this one section. Now, you won't really appreciate how this works until you actually step through it. So that's what I like to do. So, that's my favorite kind of trick. I'm going to press F11, and we're going to step through this program using the section with the methods in it. Okay, so program starts up. We'll put this in the middle of the screen, and I'm going to do this one with the method. So with the method, we work through, and these first couple of lines get put into the text box. Okay, so that's pretty straightforward. Now let me slide this up a little bit. And Now, here's what happens. When this method is called, it goes down to, it's almost like it goes to a different program within your program. And we slide down to verse. And now it's down into the method called verse. And it makes this first message box pop up. And we press OK. And then it makes the second part of the verse pop up. And we press OK. Now, after it's done, it returns to the place that it was called from. So when I press F11, watch where it goes. It goes back to here and then just continues on its merry way until it needs to be called again. When it's called again, it goes down here, does what it has to, and then returns to the place it was called. So in a kind of simplistic way, I know it's kind of a dumb example, you're starting to see the mechanics of how a method works and why it's good. Because let's say the verse was 20 lines instead of 2. Instead of repeating those 20 lines and all throughout your program, now you've put them all in one section, and every time you need them, you call them. It also makes your program more organized by doing this. Okay, so that's the why of why you use methods. Now, in a lecture a couple of lectures ago, we talked about flowcharting, and it's a good time for me before I go into a practical application of methods to show you how you would flowchart something that involved methods. So this is a typical game, a dice rolling game that you could flowchart, and it's a nice little review. There we have our oval that we always use when we start a flowchart. Initializing variables means we would keep track of the dice that we're going to be rolling, and you always use a rectangle for that. This is the new symbol. When you want to call a method, you use like a rectangle with 2 lines on the side. And what this does is, it says call the dice roll. So it would go over to B, and we would pick 2 dice between 1 and 6, the numbers, and then return. Okay, like we did in the example I showed you a few minutes ago. And then we would call decisions. So see how everything is becoming more organized? So what methods allow you to do is structure your program with little programs inside a program. So this one says call decisions. So after we've rolled the dice, we call decisions. Whoa, and this is another little program inside a program, a method. And it says, was the total 2 or 12? If it was yes, you win, and you get $10 extra, and you go down to D, and you return back to the main program. If it was no, then was the total anything else except 7? If it was, you broke even, and if it wasn't, you lose. The game's over. Okay, so after you return here, you check to continue. If the game was over, you end. If it wasn't, you go to A, which means you roll some more dice. So that's kind of a cool thing to see how a person creates the logic through a flowchart to play a simple game, and we just highlighted the new symbols to represent methods. All right, now let's look at more practical applications of methods. And again, we're going to base this on one of my demos, but you're going to use this in this lecture and the next lecture to solve a series of practical applications. So the one we were in right now was called song method. So I want you guys to load in simple methods, and we'll double click on it. And again, it doesn't do anything spectacular, but we'll use this as a basis for what we're going to do for the next couple of lectures. Okay, and just to show you what it does when you run it, it's going to ask for a number. So I'll type in 5. It's going to ask for a second number, and I'll type in 8. And it just works out what 8 times 6 is, which is 48, and prints out the answer. Okay, so the most important part is what you're going to see underneath. Okay, so let's double click on here. And this example is going to serve to illustrate 2 types of methods, the most classical kind. Methods where you go somewhere like we did with the song one and just do something. And the second kind, which is very popular, is where you go to a method and you come back with a mathematical answer or a string answer. Okay, so in this particular program, first of all, we're going to ask for 2 numbers using the input boxes. And then what you see here is kind of a new cool thing that we're going to start doing. You call a method, but hey, it's not just like, when I typed in verse and then bracket, bracket. This one actually has an equal and a result. So this one, I invented a method called multiply, and here it is down here. And I still use the word private, but instead of the word void, this one is going to return an answer. So instead of the word void, what you do there is you write down the kind of answer you're going to return with. This is going to return with numbers, integers. You could have double there, you could have string. The second thing that's interesting about this is when I got the two numbers from the person running my program, I'm going to send those down to my method. It's almost like you're bringing your shoes to the shoemaker, or your phone to the person who can fix a phone. So you carry things with you. These are things called parameters that we're going to fill in. So they don't have to match the names, okay? So even though this is called first number here, it's going to get put into where the x variable is, and second number will be put into the y. Simple formula, obviously. We take the x and the y, we times them together, and then we return the answer. So when we get 6 and 8 and we get 48, 48 will be the result, and we're done the first part. Now the next part, which is kind of cool. This method, hey, I don't see an equal sign on it. So this second method that we use is more like the one we did with the song, except it has parameters still in here, and we are going to call the display method. All right, so what happens with the display method is that down here, I have, again, something that catches the information that I need. I need the first number, so the display method takes it and puts it in there, takes the second number, puts it in there, and the result gets put in there. Now you notice this time I use the word void because we're not going to work out any math here. We're just going to take those results and display them on the screen. Okay, so those are the two types of methods that you can use when you create programs using this technique. Now, again, just like the last example, I'm going to show you in super slow motion how these work and how the numbers are being transferred. Okay, so I'm going to press F11 like I've done before, and we will go into the background. Okay, so when we press here, it's going to ask us for the first number, and we will type in a 6. Okay, press F11 again, type in an 8. And then, now here's what you got to realize. There's the 6. There's the 8. So when I go down here, this caught the 6. See how it says, okay, I'll take that and put it there. And this caught the 8. Now this works out the answer, which is of course 48, and then it returns it up to here. Okay, now it's not done that line yet. So after I press F11, it's done the line, and now it's 48. This now says, okay, I've got the 6, I've got the 8, and I've even got the result, 48. So let's go to the display method. And in the display method, these variables, which are just generic variables, you can make up any letters you like, are storing the results sent down to them, and then we print out the final result. And there you have it, the methods technique. Now we're going to use this as a basis of practice. So in our next lecture, I'm going to give you about 3 or 4 practical applications to try. Thanks for listening, and we'll see you in the next lecture. Welcome back. And now this is the next lecture on methods. And what we're going to do in this lecture is basically go through some practice problems. I'll do one to start us off, and then I'll get you to stop the recording, try the other ones, and then you can press the recording again and you can watch me take up the rest of the solutions. Now in the resources for today's lecture, you should have a PDF file that stores the problems that we're going to look at, and here it is right now. And what we're going to do today is just modify the program we worked on last lecture to create methods that will solve these problems. Okay, so what I've done is I've gone back to the program we worked on last lecture, and I've added 4 buttons. And each of these buttons is going to be the solution to one of the 4 questions that we're going to work on. So let's take a look at the first question. It says, design a method to calculate the volume of a box when the length, width, and height of the box are passed to the function. Okay, so hopefully you remember your volume formula, length times width times height. Okay, so that's going to be our first question. So let's pop this up, and problem number 1. Now, the reason I like using my old programs to help us do the new ones is I can beg, borrow, and steal from these ones, so I don't have to do a lot of typing. So I'm going to take this line in a few minutes or a few seconds, and I'm going to use it for the input. Okay, so this first question basically says, ask the person 4 questions actually. So we need, and let's make them all double. We're going to need double length, double width, and double height. And you might be wondering, why did you type width with the WD, why don't you spell the whole thing out? Or why don't you spell height all out? Well, actually, those are special words in C#, and we use them a lot when we do graphics. So for now, let's stick with the short form so we don't get into trouble. Okay, next thing we're going to do is we're going to ask the person for the length. So I'm going to paste this in. Now we got one issue. It says here, enter a sample, enter a number. So I'm going to say, enter the width. Okay, and this is going to be for our volume problem. And this is double, right? Oh, and this is length. Let me just change this to length then. Now, I like using the other technique, and first of all, this is not going to be an integer, so we have to say double. I like using this technique, double dot parse. Okay, the rest is okay. And now I'm just going to copy and paste this because it's going to be basically the same thing 2 more times. So we'll paste it in there and paste it in 1 more time. And of course, now we're going to do the other 2 components. I'll slide this back for a second. So we're going to do width here, spelt funny, okay, and height, spelt funny. Now in here, you don't have to spell them funny. Okay, you can actually spell them there because they're just in quotes. Those are literally what we're doing. Okay, they're not being stored anywhere. And this is the height. Okay, so now we've got our 3 components, and now the new stuff. What we're going to do in a second in here is write down the call to the method that will work out the volume. But why don't we create that method first? So you type in the word private. Now this answer, when it returns, is going to be a double. And we're going to call our method volume. Now it's going to accept 3 variables, and they are doubles actually. Okay, and double Z. And those are going to be like people that are catching the results, almost like a bat catcher in baseball. And that's where the answers are going to be from up here, sent down. Now, right now, it says a little error. You'll see how I fix it in a second. But it's got to have a special thing to return here. And it'll take care of itself when we add it in. And you know the formula. It's going to be double volume. And volume is going to equal x times y times z. But the last thing is really important, and that's why it's getting mad at me right now. I have to return this answer I worked out. Okay, and you notice that the little red line underneath the volume disappears. So this is really important. As soon as I add this word double or int or whatever, it expects you to return a value as opposed to the void command. All right, now we come back up here, and now we make a call to this. So we'll say double vol equals, and we call the volume method. So this is how you call it. You name it, and then you pass it the length, the width, and the height. And that is being sent down to this method we just created. And then at the very end, we'll do a message box.show the volume is, and then we will attach the answer, which is in vol, to string. Okay, so there is our first solution. So all these questions you're going to work on in the next couple of minutes are basically the same way. You're going to have to declare some variables that you're going to ask the person to enter. Then you're going to use an input box to get those pieces of information. Then I would stop and then worry about creating the method. And depending on the question, you're either going to come back with decimals, integers, or I think I've got a couple of examples where you come back with a word. So it's a string. So you can return anything, okay? So in here, you will write that down. Then here, you make up a name that you want to represent the method you're creating and fill in the parameters, or in this case, they're called arguments, for the number of things that you're sending down, okay? So if you need 2 things to be sent down, you need 2 things in the bracket. And if you have only 1, you only have 1. In here, you usually declare something because it's going to be some sort of formula you're going to work out. Work out the formula, and then make sure you return the answer. Okay, let's see if this actually works. Okay, so I'll press this, and I'll enter a length of 5, width is 6, height of 7, and the total volume is 210. Okay, which is correct. So that's basically how you attack all these questions. So what I'd like you to do now is stop the video and give the remaining 3 a try. Try your best, don't give up too soon, and then when you think you've got them all or you've gotten close but you don't know how much more to do, you can come back and watch me take up the solutions. Okay, welcome back. Hopefully you got some of them to work out. And I just noticed here, there's 5 questions, so I know the 5th one's a little bit challenging, but let's do it too. Let's do them all. I don't know if you did the 5th one or not, but let's throw it in there, and we'll quickly name it and everything else, and then we'll get rolling here with the solutions. So problem 5. So let's do them all. Okay, so problem number 2 says design a program that will determine whether a number passed to it is even or odd. Nice question. And then we're going to invent a method called even odd. And when we send it a number, it should come back with the word odd or even. So this one's going to return a string. That's what's going to make this a little bit different. Okay, so first thing, all we're asking for in this one is one number, and it's going to be like a regular number, an integer. Okay, and we're going to ask for a question. So I'm going to go up here, and I'm going to have to modify it slightly, obviously, but we'll grab it from here. Okay, so we'll come down here and we'll paste this in. And this one should just going to say enter a number. And we'll call this even or odd. And this one's an integer, so instead of double parse, we'll use int parse. Okay, and this isn't len anymore, it's number. Okay. Now, you'll see the green thing move away now that it's being used. What I'd like to do now is invent the even-odd routine. So we'll say private, and look at what I'm going to do here, string, because I want to return a word, even or odd. And then I'm going to call this even-odd, and then integer x. Now, let's see how good you remember some of this stuff. We did something a while back where you can figure out the remainders, because here's the trick. If you divide an even number by 2, you should get a number that goes in twice and no remainder. How about 8? Goes in 4 times, no remainder. So the key is it's no remainder. Now, if you have odd numbers and you take 5 divided by 2, it goes in twice with 1 remainder. So that's going to be how we're going to answer this question. We're going to work out the remainders, and depending on what I get, I'm going to say either the word even or odd. So first of all, I'm going to say string status, and I'm going to make it equal to 2 quotes stuck together. It's like saying the status is initially nothing. Okay. Then what I'm going to do is I'm going to go if x% equals 0, squiggly lines, then I'm going to say the status equals even. Okay, so that's an even number. And else, and there's only one other possibility for integers, else, squiggly line, status equals odd. All right, now we're not done, because you always have to do that thing where you say return. So you have to say the last line, return status. Okay, so there is that in action. Now what we have to do is send this number to the program. Now again, here I'm going to say string. I'm going to call it result in this one. And what we're going to do is we're going to call that routine and put the result equal to even, odd, bracket, and I'm going to send it the number, and then message box dot show the number entered is, and then plus result, and I don't have to put that to string because it's already a string. Okay, so let's give that a run and see what we get. So if I type in 15, it's odd. Okay, let's type in 4, it's even. Okay, so there's the second one done. Now question number 3, we kind of already used the idea in number 2. It says, ask for 2 numbers and then work out the remainder. So we're going to invent a method called remainder, and when it's sent 2 numbers, it's going to return the leftover when you divide 7, in this case, into 12. Now, some students would always say, sir, all you got to do is 12 minus 7, you get 5. Yeah, for that example, but what if I had asked you to tell me the remainder for 18 and 5? Well, you don't go 18 minus 5 to get the leftover. 5 goes into 18 3 times, 15, right? And 3 left over. Okay, so remember, we're not going to use minus. We're going to use, again, that percent sign. All right, so here is the solution to number 3. Now, I've already done a little bit of the prep work. I've declared the 2 numbers that we're going to use, number 1, number 2. I've declared a variable called rem for remainder, and I've written the input boxes to get the 2 numbers from the user. So now we'll do our standard technique, private. This time it's an integer that we're going to return from, and this one we're going to call remainder, and then bracket integer x, integer y. That's the first step. And then squiggly lines, we're going to say integer leftover, and we'll initialize it to 0 initially. And then the leftover is really just basically equal to the x percent y. And then the last part is we return the leftover. Okay, so that's how you invented the remainder method, and now we're ready to use it. So we're going to say rem equals remainder bracket number 1 comma number 2, and then we finish off with our message box. Message box dot show the remainder is, and we'll just move it right there, remainder to string. Oops, we're going to call it actually rem to string. Okay, so this one, once we knew the question from before that we had to use percent signs, should be fairly straightforward. Let's give it a run. So number 3, enter a number 12, and then 7, and the remainder is going to be 5. And like I said, it's not a subtraction, so this will prove it. 18 and 5, and the remainder should be 3. Okay, so there's the answer to that question. Now, this next question is pretty challenging, especially if you don't remember your mathematics. And what we're trying to do here is work out the cube root of a number. So like the cube root of 8 would be 2, because 2 times 2 times 2 equals 8. But how do you get the computer to work this out? I know there's a math dot square root, but there isn't a math dot cube root. So what you have to remember is that in mathematics, you can write fractional exponents. So 8 to the exponent 1/3 actually equals 2. So if we can use the math.pow, have the number and then comma this as the exponent, we'll be able to work out the cube roots. So let's take a look at the program. I've already prepped the easy stuff. I've declared my variables. I ask for a number. I tell the computer to go and get this cube root with the function that I've created, but I've left the one important part for us to do together right now. And the way we're going to work out the cube root is we're going to use the math.pow command, like I told you. We're going to take whatever number we get, and then we're going to put it to the exponent 1/3. But there's a problem here. If you remember your integers from before, what the computer is going to do when it gets to this line here is go, oh, 1 divided by 3 is a big fat 0. Why? Because 1 is a beautiful integer, 3 is a beautiful integer. So integer divided by integer is going to give you an integer of 0. So what do? Well, either to the top or the bottom, all you got to do is type in a decimal 0 or something like that, And all of a sudden now that's a double. And now our answer will work out to a double. Let's see if that actually works. Problem number 4. 8 is going to be easy, obviously. It works out to 2. Let's do a crazy one that doesn't have a nice number. Well, actually, let's do 27. I know that one's 3. Okay, and we'll do one more. 45. That definitely doesn't have a cube root, like a nice cube root. And you get that big long decimal. Okay, so there you have that answer. All right, on to the last question, which I actually wasn't going to give you, but let's do it anyway. So let's do the 5th question. This one basically asks to determine the cost of a package depending on its weight. So we're going to create a method that accepts the weight, and then we're going to have to, I guess, go through a bunch of if statements to figure out which category it goes into. And the last one is where it's too heavy. So by having this word too heavy, we're going to have to return strings instead of numbers, and then we could do something with them after, but that's the way we're going to interpret the question. Okay, so I've already set it all up for us, okay, because we're running short of time, but basically here's what happens. You're going to send some weight down, you're going to work out the cost. You ask the person for the weight, and the weight could have decimals. Then we create a method called package cost, which we will send down the weight to. And here is the package cost method. Starts off with initially a C, which represents cost of nothing. And depending on the if statement, 32 cents or 47 or 62 or 77 or 92 or too heavy. And that's why I had to return a string, because of this too heavy. So I made all of them with quotes. We don't really do any other math to these. We just say the result. So that works fine, okay? And remember, this is how you do compound if statements, where you say it's between this and that. Let's run it for a sec. So if I have a package 12, it's going to cost 47 cents. What if I have a package of 60? That's going to be too heavy. Okay, so it basically works, and there you have a nice little recap of a bunch of questions that are creating methods. Some return doubles, some returned integers, some return strings. Okay, so hopefully you caught that on, and on to the next lesson. In this lecture, we look at the concept of data files. This concept could be a course all by itself. To this point, all the data that we have used when executing our programs has been entered from the keyboard. Similarly, all the output that has been produced from our programs has been to the screen. You have to realize that not all the input and output occurs this way. In fact, the majority of input for a computer program comes from data files that are stored on a disk or a hard drive. When we create a document in a word processor, for example, we see it on the screen. However, if we want to store that information so that we can use it or edit it later, we have to output it to some secure medium. Once stored, the data can be accessed for further processing, used for input to programs, sorted, updated. You get the idea. Everyone using a computer deals with files. When you turn on your computer, the computer loads files. When you start a piece of software, the computer loads files. Can you think of any useful programs that don't use files? Files are a very important concept to understand, because any really useful piece of software uses them. Even your video games store your high scores. So, in this lecture, we're going to learn how to read data files, and we're going to look at some simple applications that use data files. Okay, we're going to start off and load in a demo program just to give you an idea what a data file does and how it looks. Okay, so in your demos for this lecture, we're going to go into problem solving, and there's a folder called IO streams, which stands for input output streams. I'm going to go in there and we're going to load in simple text file demo and load it up. Okay, so I'm just going to run it first, then we'll talk about what it does and how it does it. So somewhere on my hard drive, I have a list of information, and when I press this button, it takes that information and puts it into this computer. And here's another one that takes that information with their marks and works out their averages. Now, what you have to realize with data files is it's like having two separate programs. You have your C# program, so that when you save that on your hard drive, it's a bunch of files. And then there's a separate raw piece of data, which just holds people's names. Charlie, Sam, whatever, okay? So this program loads this data file in, and I'm going to show you the two different components right now. All right, I'm going to drop this screen down and I'm going to go to my hard drive, and this is where the program is that we're using right now, Simple Text File Demo. And in this folder bin and then in debug, well, that's pretty far in there, you notice there's a couple of folders, a couple of files. One is called text, friends.txt and marks.txt. Let's take a look at them. Look what happened when I started it up. It just started up Notepad. This is just raw information. Let's take a look at the other one. So remember how to get to it. Work through to go to your temp drive, go into your folders. Okay, so I'm taking the long way just to give you an idea. Then I went into my lecture demos, problem solving, and IO streams, and this is the program we're working in. And inside of there, and I know it's buried deep in there, is the debug folder. And here is the friends, and then let's go into marks for a second. This one, again, is raw information. There's no computer codes, it's just raw data, people's names and their marks. Okay, and you'll notice that after the last mark, there's a blank. That's really important when you create these files. You can do them by hand, you can load into Notepad. At the very end, you have to press enter to make this thing called an end of file marker. That's how the computer is going to know that I've gotten to the end of all the data. Okay, so don't press enter 10,000 times. Just press it once right after the last one to make that blank. And that's going to be important for the program. Anyway, so you see, this is raw data. Okay, let's get into specifics now. How did this program work and what's the actual code involved? So I'm going to click on Display Friends. And actually, the first thing I want to highlight is at the very top. And this you have to hand type in yourself. Since we are going to make a connection to a file, you have to add this special word at the very top called using system IO. And I told you already, IO stands for input output. So you need this, okay? So you have to put that in. Now, up until now, I haven't even mentioned any of this stuff up here because it's pretty well put in there automatically. But this is new. Make sure you put it in, okay? Next thing. When you double click here, you're going to have to make a connection between this program and where you have your data. Now, at home, you might have a C drive, a D drive. It depends how many drives you have. And how's a computer going to know? Well, I don't usually write down where your program is here in terms of C:/ whatever, if you even understand what that means. Let the computer figure it out. So I created a string here called startup path. And there's a special command called application startup path, and it'll just know wherever you saved your program how to get to that path. And it'll know how to get to the debug folder I showed you and everything, all because of this application.startup. So that's a very useful command, and that's how professional programmers make programs work from any hard drive that you install it on. The next thing I do is after that is I attach the startup path to the actual name of the file, and you have to use this little @ sign and put it right in front of the name of your file with the backslash, okay? And now what we have in there in F, and you'll see it when I step through it, is the entire path to the file where I've listed all my friends. This is a special new word, stream reader, and this is a variable that we're going to refer to as the object that references the stream reader. And F is actually the path that we're taking. And again, it's pretty weird stuff. It's pretty new. Like I said, this could be a whole course, and I'm just going to give you a little taste for it. I define a few variables which are going to remember the information that I'm reading in. Now, I don't know when to stop. So I'm going to have to figure out, is it time or is it not? Is it time? Is it not? And I'm going to create a variable which is called a Boolean. I think this is the first time we've ever used Boolean. And Boolean are either true or false. And that little not sign that we've used before, like not equal to, if you put that in front, it says, well, it's not true, which means it's false, then keep doing this. The instant that it becomes true, stop. Okay? So not finished just basically implies if it's false. Okay? So what does it do? Well, the best way for me to explain this next part is to actually step through the program. Okay, so we'll start it up. And I'm pressing F11. Remember, it's my favorite little trick to show you in super slow motion what's going on behind the scenes. And this is the best way to understand what some of the commands are doing when we're running this program. So I press display friends. So the first thing the computer does is find the path to your hard drive. Now look what it does after it does it. Whoa, look at all that long. It knows exactly in that subfolder. You saw me work my way down. It knows the exact path to get to, and it's so big it's totally off the screen a little bit. Then what we do in the next line is after that entire path, we attach the actual command file, friends, to this long string. So F is, if we could see it way over on the right, would have as its last component attached to it the word friends.txt. So this saves us having to try to write down for every possible case where our program could be. It'll know every time we install it. Then the stream reader wakes up, and now we are ready to roll. And we initialize all our variables, and right now finished is false, so we're obviously not finished. Until it's true, we're not going to be finished. This is the key line. This is how you read an entire line of data that's stored on your hard drive. And let's see what it read in. Tom. Okay, great. Now, is that line equal to nothing? Remember I told you to press enter after the last name to make like a blank? Well, to the computer, that means null. Well, we're not there yet, obviously, so we're not finished. And what we're basically doing right now is just going to list them all back to the screen. So that word Tom is going to get attached. We're going to go down a line and then continue. Now we go back up to the top, and we're not finished yet, obviously. And now we're going to read in another line. And this time we're reading Mary. Mary obviously is not equal to nothing. And we attach her and we keep going. I'm going to go through this fairly quickly until we get to maybe the second last or last one. Let's see where we are now. Okay, so now we're on Lauren. Attach her to the list. Ah, finally got to the end. This time I read in a null. So this time I set finish, the variable Boolean, to true. And let's see, it's going to go back up one more time, but this time it's not false, it's true. So now we can close the connection between our program and the hard drive that holds the friends.txt file, and finally we can display the results. Okay, and there's all my friends. The second program does basically the same thing, okay? And that one I won't step through, but let me quickly go through it with you. This one here is basically the same thing. And what we do in this one, and everything looks the same, In this one, because we're reading in two pieces of information at once, I thought I'd be kind of cool here and show you how to use a method. Remember those method things we did? And I'm going to pass it the stream reader. And down here is a method called read data. And what it does is does two things. Now, it doesn't return a variable, but because these variables were declared up here, so the entire world would know about them, it's going to know what the results are when I come back from that method. Now, when I come back from the method, if either one of those two, the name or the mark, is a blank, then we're finished. If we're not finished, let's do some math. And again, we just finished doing methods, so this is kind of cool. Instead of you doing the math right there, have a method do the math. And look what happens down here. Because we're working out a person's average, or a bunch of averages, we're going to count, and then we're going to total up the marks, okay? And then reattach them all. And when we're totally done, when we've read the last person and their mark, we're going to close the file and work out the average. So that's where you get this result right here. Okay, it's going to load up here. And when we press this, there's the information about the people, okay? And the line that was doing that, if you're not sure how come it was doing that, this information came from that line. That was attaching all the information. These two lines were working out the totals for us so that when we're finished reading every single person, we would work out the average and then display it. Okay, and there is a data file program that loads in information that's totally separate from your main program. Now, once you have a basic idea of data files, there's all kinds of incredible applications that you can do. I'm just going to give you one for an example. We're trying to apply for a credit card, and we've got a list of information about a bunch of people, and then we're going to spit out accepted, rejected, whatever case. And very quickly, I've got this example that I've gotten out of some information that I got off the internet. And this is one of the eligibility requirements for a credit card for, let's say, Best Buy or whatever. So in this particular situation, it says that to be accepted for a credit card, you have to have a salary over $25,000. Or if you don't consider that one, you can have over $20,000 salary and pay rent less than a quarter of a month's salary. Or have an annual salary over $15,000, be living at the same address for 5 years, and have an annual salary of at least $10,000. And be living at the same address for at least 5 years and be employed at the same job. So there's all these different requirements, okay? So this is an application that would be a classic application for a data file, okay? And here is some information that we would want to load in. Now, it'd be stupid to do this with input statements, especially when you're debugging the program, because you would have to type all the information in. If you made one mistake, you'd have to type it all in again. So the neat thing about data files is also that once you type them in, they're there forever. You start polishing your program. If it crashes a million times, great, fix it up, but you never have to retype this in. So let's take a look at where this information is and how we're going to use it. Now, on your hard drive, again, and I'll work my way down where you have the demos for this lesson. You're going to go into, this time, credit card app, and I want to go into this folder, in the bin folder, debug, and there is the credit information. So I put it sort of single file. That's one person, everything about his yearly salary, the rent, the years living at the same address, number of years working. That's one person, and that's his number, sort of employee number. There's the second person. There's a third, and it goes all the way down. And remember what I told you, after the last one, you always put a little blank line. You can sort of see it there. I'll move the screen up a little bit, and you can see where it is. Okay, so that is the last person right down at the bottom. Okay, with that knowledge, let's take a look at the program. Okay, so this works out credit card applications. So I'm just going to run it for a second to show you what it looks like. Credit card status, so it has the employee number, salary, all that worked out, okay, yearly salary and everything else, and accepted. 2 people got rejected. Okay, so let's take a look at this solution. Okay, very interesting problem. Let's take a look at the code. So first of all, let's slide ourselves way up to the top for a second, and remember that we need to physically hand type that in. All right, and then for the rest of the program, let's take a look at it. Credit card status. First of all, you should know that we're going to be using some variables that we want the entire world to know about. So I declare them outside of this button. Okay, so they're not inside the button, they're outside of it. This is how we're going to make the computer point to where it is on our hard drive when you're saying what this. We have to know exactly where that credit information is as a text file. Okay, and then we start our loop. And we use the same technique as we used before. We pretend at the beginning that it's false. So while it's not true, meaning it's false, let's read in the information. So here is the method to read in all that information. So this one has quite a few things to read in. It has 5 pieces of data. After we read in those 5 pieces of data, we check one of them. We don't have to check all of them. If one of them is equal to a blank, it means that we're probably at the end and we're finished. If it's not equal to a blank, then what we want to do is have another method. This is cool. And this method is going to return an answer. So it's good practice to show you the second kind of method, the one that returns an answer. Now this one is a little bit tricky. You had to read the entire documentation from before. Remember all these different rules for credit card? You know, if you have a salary over $25,000, that's one condition. Or $20,000 salary and pay rent of less than a quarter of a month's salary. So all these different conditions are all going to be taken up by this set of if statements. So here initially the status, we don't know it yet. And then we check if the salary is greater than $25,000. Yes, hooray, you get accepted for a credit card. This one's kind of tricky. You make over $20,000 and your rent is less than a quarter. That's how you say a quarter of your monthly salary. So salary divided by 12. And then there's this one where you make over $15,000 and you've been living at the same place for more than 5 years. This one over $10,000, living at the same place for 5 years, and employed at the same job for at least 3 years, you get accepted. If you fail all of those, your status is rejected, and then we return. So when we return to here, we will have in the variable s your status. And then we attach all that piece of information to this variable called contents. And this plus equal means keep attaching, 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 so they get one gigantic answer, as you see when we press this status. Okay, so this is a practical application of data files. Lots of advantages to it. The main one when you're debugging or testing is that once you are typing this information in, you don't have to type it all in again. If you make a mistake with your program, you can just load it in. So this is just scratching the surface of what it takes to do a data file program. We'll revisit this later on in the course. And like I said, this could be an entire course all by itself. Okay, so hang in there. We got one more lesson to wrap up this unit on problem solving. Take care. Hi guys, welcome to the wrap-up lecture on our section on problem solving. What we're going to do over the next couple of minutes is just review all the different ideas that we covered in this section. And I'm going to throw at you a kind of a neat problem dealing with forensic science that you may want to do as a challenge that will incorporate all the ideas we covered in this section, from using flowcharts to creating programs using methods and maybe even using data files. Okay, so let's get started. During our last lecture, our second example was this one dealing with the credit card applications. And I think this one's going to serve as a nice little source of review. So I'll use this as the basis of my review, and then we'll give you that nice little forensic science problem. So in this question, if you think back, the first step in the problem-solving process would have been to try to understand what all of this kind of confusing rules are. So this would have been the step one. This would have been to analyze the problem, right? And try to put it into your own words, try to reason out all the different things. And if you were looking at this as a problem, you would have sort of underlined the key things, and there was about 4 or 5 different components of what it takes to get accepted for a credit card. So you would have analyzed that step. If you were in a group of people, you might have brainstormed to figure out what did you want the program to look like, and that would have been the first step. Then you would have flowcharted the solution, and that would have involved using maybe that Gliffy program I showed you on the internet, and you would have sort of sketched out a rough idea of how you'd want to do the program. And again, without getting too specific, remember we use symbols like that for the oval, which would start the program. And this program would involve input from a database or a data file. So you would read in the info, okay? And again, you're being very generic here, not too specific. Then it would get a little bit more serious, because after you read in the data, you would have to determine whether you get a credit card or not. And I would use a method. So this would have been the symbol for the method, and we would have said credit status or something like that. So what you would have done as your next step is to flowchart a rough idea of your solution. Okay, then it would be time to program. And we did the solution to this. And let me just drop this down here for a second and show you the code again. What I've done is I cleaned it up a little bit. If you remember this the last lecture, I had 2 other buttons here. I just have this one now. And let's just run it again for a second to show you how it worked. So we basically, when we pressed here, we got all this credit card status. Now, as a professional programmer, what you also need to do when you think you've got it working is to comment and document your program. And that's one thing I have not shown you up until this sort of wrap-up lesson today. So what I want to do is I'm going to go into the code for a second and define the 2 other areas that you need to understand. So usually at the very top of your program, programmers use a section called a variable dictionary. And what they do in that section is they don't just declare the variables, but they describe the purpose of each and every variable in the question, okay? So for instance, they would have a section, contents. This is a variable used when reading in the data file, okay? And then another one underneath that, app number. This is the applicant's number. So what you're doing in this variable dictionary is you're being very definitive. Now, obviously, some of these words are obvious, but it doesn't matter. This is the applicant's yearly salary. Okay, so you still have to write down everything, and we call this a variable dictionary. So you would do this at the very top of the program, make it look nice. I'm not going to do the whole thing, but I see some students over the years, section it off really nice like that. And remember, anything in those double lines, which are comments, nobody, the computer doesn't look at it. It's just you, the user, that would look at it. If you worked for a company and you left and you went for bigger and better things and then somebody else came in to take over your spot, this would help them understand all the different variables and techniques you used in your program. That's called a variable dictionary. Also, in the program, you should add lots of comments. Now, this one doesn't have any comments. So here we would set up path to data file. So you're in not every single line, but at number of locations within the program, you make a few comments to tell the user and to remind yourself what you were trying to do. This is the main loop that reads the data in. Okay, then down here, this method reads the actual applicant's info. This one right here, this method determines the status of an applicant. And if you wanted to, you could get even crazier in here and add some comments. Like you could add a comment right there. The quarter calculation is to determine the monthly salary. Okay, now you can be as specific as you want. You can write whatever you want, but this is what a good program would do. It would have a nice section at the very top telling me everything about all the variables used in the program. I didn't do them all, but you would write down every variable and the purpose of it. And then it stops throughout the program. It doesn't have to be every line, but every sort of major section, make a comment to remind you and then a future user, if somebody does have to update your program, what is going on at those spots. So that's called the documentation. Now this program, I think, runs fairly clean, but then we learned other tricks. Remember how to step through a program if we had to, how to add breakpoints, and that became the testing section. And then you would, have the program ready to go. Now, if you forgot about files or you want a little quick refresher, remember we also stepped through the program. Remember F11 was a way to see how the program worked in super slow motion. Love this technique, okay? And you notice it skips over the comments when you do the stepping. And then when you press this button, it basically runs and executes the entire program. I'll slide this up a little bit so you can see it a bit better. Okay, so this would take up all the code for it. This would go down to read data. This would load in everything about the person. Okay, so we're stepping through it. So it has the application number, the salary, the years employed. And I'm going to do this one because I want to show you the credit status routine. So now we go to credit status, and that's a method. Okay, another thing that we covered in this unit. And the method returned after we figure out what's the status. So there's a status is nothing at the beginning. So is this first person's salary over 25? No, it isn't. Okay, so it's not the first one. What about this one? Yeah, it's that so far is good. Let's see if it, no, it didn't match that one. It's definitely that. And residing, he's right on 5, so he's not going to get that one. So he skips that one. What about this one? One of these have to be true. His salary is definitely over 10,000. Years residing is equal to or greater than 5, so he's going to pass that one. And years employed 4. So this one had to match all 3 of them. Had to be over 10, had to be at least 5 years at the same house, had to be at least 3 years at the same place. So bingo, this is the one that gets accepted. So see how it sort of cascaded its way down. We finally got one. It goes to status accepted. Okay, and we go back up to the top. This returns the variable s as accepted, and then we display the result on the screen. Okay, and it would go through all the other people just like that too. I'm not going to go through all of them. Okay, but it would go through every step like that, and then it would display the answer up here. Okay, so that is beginning to end, all the various stages. You analyze the problem. Once you analyze the problem, you sort of get an idea of how you're going to do the solution. There's several techniques. We like to use the flow chart. Then you would do a rough interface, and this one's pretty basic. It's got a button and a text box. And then you would start coding, as we did. You would debug if necessary. You would add your documentation, as I showed you right now. And these are the prime steps of creating a proper piece of software. Now, here's my challenge to you, and we're not going to take up the solution because there's so many different ways to do it and so many neat ways to apply it. But here's an interesting question I got out of a book somewhere. And, all these forensic shows are on TV. So I thought, it'd be kind of cool to take a look at a problem from forensic science. So supposedly, bad situation, you find a dead body or only a part of a dead body, and you're trying to estimate the height of the person, male or female, right? So these are the body parts that you may have found. Okay, and depending on whether it was male or female, you may not even know that. But if you do, there are different calculations based on what you found. And according to this book, here are some of the formulas you could use. And basically, if you found the femur of a male person, if you knew the length of that femur, you would times it by that number, add 69, and that would be the height of the person in inches. Okay, I think it's inches. Okay, yeah, or it's actually in centimeters. It even says here centimeters. Okay, so this would be the male calculations depending on which bone you got. Same with the female, depending on which bone you found. This would determine the height. There's also another calculation if you had an idea the age of the person. The height actually decreases by a rate of 0.06 centimeters per year. So that shrinkage must be considered. Now, I've given this to students in my high school classes over the years, and they've done some neat applications. I've seen students do a user interface where they have an image of a skeleton, and then you click on the body part that you found, and then it asks you a series of questions. I've seen other students store all this information in a data file. I like actually in this one to use input boxes or text boxes, have a nice screen display where you can do these calculations. These are obviously going to involve if statements to figure out which bone type you have. It's also going to involve some math calculations. These I would think you would try to put into methods like the male method and the female method. So there's all kinds of neat ideas that you could apply in a sort of practical application that involves forensic. Okay, so I'll leave you with that. And so ends our problem solving unit. I know it's a little bit dry, some of this material. You want to get back into the programming, but it was a necessary thing to show you, and that all good programmers learn. If you end up going into software engineering or anything like that, they beat this to death. You've got to always plan your solutions out. Just don't run to the computer and start typing. So at least if you learn that mindset, you're going to be in good shape. So thanks for listening, and on to the next section. In this lecture, we're going to look at object-oriented programming. Now, this topic in and of itself could be 7 or 8 different courses. And because this is just an introductory course, we're just going to give you a little taste for what's involved, what it is, and how you can be used in our programming. Okay, so what is object-oriented programming, or as we're going to short form it, OOP? Well, it's a totally different way to program. It's quite different than what we've been using up until now. I'm going to try to draw some analogies, but for the most part, it's going to focus a lot on these things called objects, okay, which we'll talk about as we go through it, as opposed to what we've been doing up to now, actions like clicking on stuff and the logic behind how to do certain types of commands. The objects basically model the system. So when you program in this new thing called object-oriented programming, you really have to sit back and really plan out how you're going to attack this problem by using this model called objects, okay? And these objects are going to be designed to interact with each other. I've drawn up this little chart here just to give you a difference between the two types of programming, what we've been doing up to now and what we're going to try to introduce in this lecture. So what we've been doing up until now is called procedure-oriented programming. Basically, you start with an idea and you sort of work your way down from the beginning to the bottom, okay? As opposed to object-oriented, where you don't really even think that way. You just think of everything as objects. Like if you're going to do a program about cars, you have a car object, and then it has tires, and it has a door. So there's a different way to approach it. Sometimes the program we've been called is called structured programming, okay? And object-oriented programming really concentrates on what that object does, what its properties are, what are some of its methods. Some other differences between the two types of programming. The procedure-oriented programming, the program we've been doing up until now, basically follows the rules. You govern it by giving it an algorithm, okay? And you basically identify tasks, things you have to do, and how something has to be done. Whereas the object-oriented programming, it sort of hides how an object performs its tasks. That's called encapsulation. We're going to learn that word later on. And you have to identify the behaviors of this model or this particular object. Okay, so a bit more theory, but what I'm going to do first is I'm going to go into Visual Basic and I'm going to show you how you've already been using object-oriented programming and you didn't even realize it. See, when you add buttons to the screen, this button here is like a template of all buttons you could ever create. So when you press it, you don't always make the exact same button. Sometimes you make them a little bit smaller, sometimes you make them a little bit bigger. So what you're doing by making these copies of this master button is that you're making what's called an instance, or you're making an object, okay? So when you're pressing these controls and dragging things on the screen, you're actually making kind of copies of the master one. And here's some of the terminology that matches what you're doing here with theory. So what you're actually doing is creating something from a class. So that's the really big word in object-oriented programming, classes and objects. So a class is like a template, and from which similar objects called instances are created. And when you create this instance, you use the operator new. And we've actually done this and you didn't even realize it. I don't know if you remember when we did that thing with the form, and then we would say something like, so form test, and then you went x equals new form bracket test. You were using object-oriented programming. You didn't even realize it, okay? So you had the class called form, and you were making an object called x, which was going to be a copy of that form. Another analogy, if you're still kind of out of it, the class is like your mother, okay? And then your mother gives birth to kids. You can give birth to your sister, a girl, and give birth to a brother, a boy, and certain heights. You'll be slightly different heights, hopefully the same eye color, maybe the same hair color, but they all come from a master class, your mother, okay? And you guys are instances of your mother, or your parents, obviously, and you're called the objects based on coming from your mother, okay? Which brings us to objects. Objects are instances of a class, okay? And then they have properties that we're going to talk about, variables, methods, and things like that. Down at the very bottom is something we're going to do right now with an example. We're going to create our own class, okay? And you're going to see as we create our class, there are certain properties of it. It has always these things called fields or variables. We're going to have properties in all our classes, methods, and constructors. This thing down here we won't take a look at until the next lesson. But now let's actually stop and create our first object-oriented programming by creating a simple class. Okay, so first thing, let's clear this out and actually formalize this procedure. So we're going to close the solution and we're not going to save it. And we'll create our project. Now, I'm going to call this OOP, Object-Oriented Program, and I'm going to press OK. And I'll call this form OOP, just to be consistent. I've been trying to do that in all the lectures. Okay, and we'll formalize the title on this to say OOP
example, and we will use the class button to create an object, an instance of that, and we will call this button the tester button. You'll see why in a few minutes. And we'll call this the OOP tester. Okay, we won't put any code in here yet. We will do that later on. Here's the new stuff now. What we're going to do now is create, you know how we created a new form? We're sort of going to do something like that, but we're not going to make another form. We're going to make a class. All right, so when you look over here after we get finished, there's going to be a new thing here that's going to represent a class. And I'm going to look at the simplest thing I can think of, a box. Okay, so we're going to work with a box, and I'm not a great artist, but a box is going to have length, width, and height. And what we're going to do is we're going to make a class called the box class, and maybe find the area of a box or the volume. So we'll figure out a couple of things for it. Now, first thing, like I said, is we're going to create a new thing. And when you click on Add, New Item, last time, or the last couple of times, we've always picked Windows Form. We're not going to do that this time. This time we're going to pick Class. Okay, and then down here where it says Class 1, we're not going to call it Class 1. We're going to call it Box, because this is going to be a class for a box. And then we're going to press Add. Whoa, this is a different screen. It doesn't even have a user interface. No, it isn't. This is just pure code. Okay, so this is now the class called Box, and we're going to make lots of room, because what we're going to do in here in a few minutes is define the entire class Box. Okay, now in no particular order, but I like to be, fairly consistent. What I want to do always first at the beginning is define my fields. So when you create a new class, you have to say, what are the components that make up this object? It's a car, is it a human being? Well, in this case, it's a simple box. So fields are the fancy words for variables in object-oriented programming, and we try to hide them from the outside world. So we always use the word private. And then, obviously, I told you before, a box is going to have a length. It's going to have a width, which I will misspell, okay, because I told you it's a special word in the computer. And it's also going to have a height, which I will also misspell, okay. So actually, yeah, without the T on it, just like that. Okay, so that is called your fields, your variables that make up this animal, this object, this class, this template, okay. The next thing they usually do, we've actually done. We did this when we did those user-defined dialogues. We're going to do something that's called properties, and actually I should make that comment here. They're called different things in different languages, but in C# they're called properties. So we're going to have something that lets the inside world in. It lets the inside world come in and get stuff from here or put stuff in here. And you actually do say the word get, okay? And you say return length, okay? The length is the stuff that we've made private, all right? So we don't let them get in this way, but they can come in using this public way to get in. And sometimes we call this an accessor. And this other one uses the word set, and we usually call this a mutator. It's because it changes stuff, okay? So it's actually the reverse of an accessor, okay? So now the other ones are exactly the same. And so what I'm going to do is I'm going to basically copy and paste 2 more times. And these ones are going to be for the other components of this class we're creating. And this one is going to be for the width. So obviously I need to change those to match. Okay, now if you're wondering, how come you're spelling them different in different situations? Well, let's make sure you understand what's going on here. This is how the outside world's going to get in. So from the outside world, they're going to name them with these. Inside this world of the class, this is what they're really called. So when the outside world comes in, we're going to return what's in the inside world. Kind of a weird way to work, right? But that's how you work, because these are going to be private. And there's a word for that called encapsulation, which we'll talk more about in the next lecture. Okay, let's finish off this last one. This one right here is called height, which I'll spell that way. Okay, and we're going to return the inside world's name for height, like that.
Okay, so this almost makes this completely done, what are called the properties, which we sort of did before a little bit, not as detailed as this, obviously. The next stage is what we call the constructor or constructors. It could be more than one. When we do some more advanced versions, we will take a look at more than one constructor. This is how you give birth to an object of the class. So first of all, because the outside world has to get access to it, you say public and then box is the name of our class. And then this is what's going to get fed into this class that we're going to use to let the outside world in when we create our class. Okay, and then squiggly lines. So again, same kind of idea. This is how the outside world is going to get in officially at the very beginning when we create our class. Okay, and that's a letter L, not a 1, if you're typing along with me. Okay, one more thing that most classes have are methods. Now, I'm only going to do one method here, but there would be lots of methods that may have things that you want done to, in this case, a box, later on a car, or some other class or objects that you want to work with. So this is one of the ways to do methods in the class. Now let's, what should we do? Maybe we'll do the volume. Yeah, we'll work out the volume of a box. Okay, and then again, we'll squiggly line it. And let me see, to work out the volume of a box, we're gonna do the math where you go length times width times height, right? And then we'll return that answer to the outside world. So you say return width times height times length. Okay, so that's basically it. And these are the inside names. Remember, this is the inside names. So quick recap. When you create a class, it always has a certain format. You have at the very top, and this is done for you in C#, the word class and the name of the box, and it's always capitalized. Then the first part is always the variables that make up your class. Then some properties that you want to maybe change about your variables. Now, you don't have to necessarily do this. If you don't want these to be accessed by anybody or changed, then you don't need to put in the properties, but you definitely need to declare the variables you're going to use. The constructor is how you give birth to this class and make it an object, and that's when you're going to make it an instance of the class. And the last thing is things that you may want to do, some formulas associated with a box that you may want to use. So how does the outside world get into using this new class called box? Well, let's double click for a second. And to give birth to the box, and it's almost like what I sort of squiggled on the screen a little while ago, the box class right there, then you make up any variable you want. We'll call it B1. If you remember that other one, I had form, test, and then space X, and X was the object I was going to create. Well, this one I'm going to call it B1 for box 1. Then new, and it has to be in small letters, box, and then in this case bracket, because we're going to feed our class 3 numbers, okay? 2, 3, 4, okay? And actually you don't put a comma on the last one. So this is going to give birth to a new object called B1. Now once we have B1, we can print it out, do stuff with it, and how about first of all we show off to ourselves and everybody else that we actually now know what those variables are. So we're going to say something like the width is, and then I'm going to say plus. And remember, now everything we do is we do it with the name B1 because that is the object that refers to the master class. So you can't use capital box, okay? You use B1. Now look what happens when I type in dot after the B1. It actually pops up all this stuff. So what do I want it to say? Well, there it is right there, width, okay? So I'm going to double click on it. It sort of knew, hey, inside the class, there is something called width. All right, let's just for fun, just run that for a second, just to give you an idea what it does. Okay, and when we press it, basically going to say the width is 2, which is right, because we fed it 3 numbers, 2 for the width, 3 for the, I think that was the height, and 4 for the length. Okay, so that is how you use it. Okay, let's do a bit more. We will create another instance of this box. Okay, so we're going to create an object called B2, and we're going to feed the class 3 numbers again. I'm going to go 3, 4, 3, 5, and 6. Okay, and then semicolon. So now there's a new object called B2, and this time how about I sort of refer to the volume. Now how do you do that? Well, remember, everything we do now in this one is referred to as B2. And we actually have, and there it is right there, volume. And that will access the volume method that's part of this class via the object now called B2. Now, hey, it's yelling at me. Well, I'm doing the formula right, but remember, volume comes back as a number. So don't forget, and it even tells you down here, cannot convert double to string. So we have to do that part where you do the to string. So dot to string, bracket, bracket. Okay, and then we give it a run. So this one's actually going to have 2 sets of answers. It's going to give us the first answer, which was the width, and then it's going to tell you the volume of 90. And then we could have written it a more descriptive way, but 3 times 5 is 15, times 6 is 90. So that is the volume. So there you have it, your first taste of object-oriented programming. Now you might say, really, I could have done this in a lot shorter. This is like overkill. And you're right. For small, little, simple problems, object-oriented programming isn't very efficient. But when we scale to huge, multi-line, thousands and millions of lines, if you've programmed in this paradigm, this object-oriented programming, it'll make things a way, way shorter. It's almost like, you know how we did methods before, and when we found stuff repeating, we could put them in a method to save space? It's the same kind of idea, but even bigger. Okay, so you don't see the potential of this until you start making gigantic programs. But in this course, because it's just a basic introduction, all I wanted to do was give you a taste for the terminology, how to code simple things, and we will kick it up a little bit more in our next lecture, but we'll stay basically with a couple of simple little examples to show you how it works. Okay, so thanks for listening, and we'll see you in the next lecture. Welcome back, and this is the second lecture on object-oriented programming. What we're going to do in this lecture is, first of all, take a look at a simple application that incorporates some of the object-oriented programming ideas. Then we'll review all the basic concepts we learned in the previous lecture, and then we'll finish up with some more advanced techniques. We'll talk about encapsulation, we'll talk about static methods, and we'll talk about inheritance. So what we'll do first is we're going to take a look at a nice application that incorporates some of the OOP ideas. All right, here's my simple application called Calculator. I'll give you a quick run to show you what it does. Basically, you can type in any values you want in here, and then you get a choice of 4 operations, and then it just works out the answer. So something that you could have easily done without knowing any object-oriented programming, but I thought I'd take something simple like this and show you how you could apply the knowledge of what we learned in our last lecture. So, first of all, I decided to create a class called Calculator. And I'll show you the class very quickly. You don't need everything that I showed you in the last lecture. You don't always need to declare fields or properties. You can just have methods in your class, and that would classify as a proper object-oriented programming. So what I did in this example is I have this class called Calculator, and I made 4 public methods. One is called add, which accepts 2 values that it's going to be fed in from the main program, and then it returns obviously the addition or the subtraction or the multiplication or the division. That's it. That's a class. So let's go back to the main form and show you the underground workings of the program. So first of all, that little text box there has a name. I want to make sure you understand what the names are. So that's value 1 box. That is value 2 box. That is going to be the result box. Okay, this is a combo box. All right, and it has been fed various values that are going to be part of the choices. So if you press here, you will see that it has add, subtract, multiply, and divide. So it's a little bit of a review of how to use combo boxes too. Now, when I press calculate, that's where the dirty work happens, right? So what happens first of all is I take whatever in those 2 boxes and I initialize my result to 0. That's obviously going to be the result of those 2 numbers being added or multiplied or whatever. This is the new stuff. This is what we learned last class. I'm going to give birth to a new object. by making an instance of the calculator class. And now everything I'm going to refer to is going to refer to calc.something. Some other neat things here that I haven't shown you up until now. I could have used if statements here, but there's a neat new command called the switch command, which is very similar to if. And basically it takes whatever you have in the combo box. So you have one of 4 operations in the combo box, and it has, instead of the word if, it says case add. And if that's true, we're going to do those 2 lines. If it has subtract, or it has multiply or divide, you're going to do whatever it says. Now, what's it going to do? Well, remember, we've made now an object called calc, and I'm going to say calc.add, and that refers to the method in the class that handles addition. And it's going to feed that method 2 values that I've had in each of one of the 2 text boxes, and it'll come back with an answer. If the word said subtract in the combo box, I will feed those 2 numbers and subtract the results. And then at the very end, once I have my result, I will take that result, convert it to a string, and put it back into the result box. So it's kind of cool, right? Let's just for fun show you what this does in super slow motion. Remember how we do that F11 all the time? So let me just give you an idea of what's going to happen here. Okay, so we're working our way through all the different controls on the form. Okay, this all happens in the background. Okay, and we're almost ready to start the program. Okay, and here we go. So I'm going to type in a number here. I'm going to type in a number here. I'm going to choose, let's pick add this time. And I'm going to press calculate. Okay, so now we're back to coding. So the computer stores these results. Okay, and 23 in there, 24 in there. Now, this is going to create an object. Now there's an object in there, okay? And the switch command basically says, okay, what did the guy press? All right, and we've got one of the choices, and the first one was obviously add. So that's the correct answer. Now let's go and see what it does. It goes to the class called calculator. It goes to the add method in the calculator, works out the answer, returns here with the result of 57, and then it breaks. It goes down to the bottom, and then it prints out the final result in the result box. Okay, so there it is in slow motion with a result of 57. All right, let's focus in on the last part of the lecture now. Quick review. So remember, when you create your own class, you always include, or not always, but most of the time you include fields, and those are the variables at the top. You include properties that have those words get and set. Usually include methods, and you usually have a constructor which kickstarts the whole object creation. Now, what we're going to do in our last example is we're going to start covering these ideas, and by way of the example, I'll always refer back to these. And the first idea I want to talk about is encapsulation. So let me pop up the program we're going to look at. So this example, it's on your hard drive, and I can reopen it if you want, but it's called First OOP Demo, and I've got it open and ready to go already. Now, basically, what this program does is deal with a few ideas related to a car, and actually I'll show you the car class right now. So I said to myself, what do I want to know about a car? So this class car, I said, let me know about the make of the car and the year. Now notice the way I've written make in small letters and year in small letters, okay? Now, I use the word private because I only want this class to know about those 2 variables. I don't want the outside world to know about them. The way the outside world is going to get into these variables is through the properties that are public. So in essence, I've hidden it from the outside world. And this idea is encapsulation, okay? It's almost like we treat the most important part of your class as a black box. It's almost like, would you, if you had a TV nowadays, need a screwdriver to get to the back to control the controls? No. You access it using a remote control or buttons at the front, and they do all the magic work. You don't want anybody fooling around with the inside pieces. And that's what happens too with classes. You don't want important variables to be destroyed by outside users. I'll give you, for instance, I'm going to go back to the form tester for a sec, and I'm going to comment out all of these for a sec. Okay, and I'm going to comment out this one and this one. So I've commented on almost everything. And I've created an object of the class. And now what I want to do is I want to type in, oh, it won't even let me. So I'm trying to make the small letter. I'm trying to go into the small letter and then type in like the make Camry or something. And then semicolon. Okay, so what I'm trying to do is access the private variable that's inside my class, and it won't let me. It gives me an error. Like if I run this, it's going to give me an error. Let me hover over this and see what it says. Car.make is inaccessible due to its protection level. Beautiful. So in essence, you're seeing it right there. I've protected those variables from the outside world, and that's the concept of encapsulation. Okay, so there's our first idea, and now I know this doesn't work. I'm going to rub it totally out, and I will wake up these other ones in a second. Okay. Anyway, let's go back to the car class for a second. So that's the first idea I wanted you guys to know about. Second idea, constructors. Now, if you don't include any constructors in your program, this one that you're looking at right now is automatically the one that gets created. It's just a generic one. It doesn't get fed in any numbers, and that's the one you use. But you can have more than one constructor in a program. Here's a constructor also, okay? But this one accepts 2 parameters. So how can you do that? Well, you can have as many different constructors as you want. This cool thing that you can do in object-oriented programming is called method overloading, okay? That's where you have a method with the same name, but with different parameters, stuff in the brackets, okay? So this one has 2 things, this one has none. You could have other ones that have more or less, okay? So this is a very cool concept. Same name, different variables. Now, how does that change the program? Well, when you go to Form Tester, you'll notice that in this one here, I use the generic constructor that doesn't accept any variables. So how do I feed information in there? Well, I have to physically access it using the properties, okay? These are these things right here. So what happens with these properties is that when you feed in the information, it uses this set command. So it takes the value you sent it and stores it into make, which is the private variable. It stores the year into year, the private variable. But this is how you get in. This is the public way to get into these particular variables. And then the last part basically accesses the display and it prints out the result. Okay, so if we ran this right now, here's what you would get. So you would press the test class and it would say car make is Toyota year 2007. Okay? Now, let's go back to our tester program and take a look at another situation. So we've done the first one where we create an instance of the car class and we feed in the information. But remember, using method overload, we have another type of constructor as part of our car class. So I'm going to activate these 2 lines now. And in this particular constructor, we are allowed to feed it the 2 important pieces of information, the make of the car and the year. And then this one accesses the display and prints out the result. So when I run this, you're going to see the first answer first, obviously. And move this over here. So that'll print out the first one, which was the Toyota 2007, and now it's also going to have the Honda 2006. Okay, so there you see the second situation. And while I'm here, I'm going to quickly make this go in the middle of the screen. Okay, now let's take a look at the third situation. And the third situation brings up our next new idea. This idea of a static method. And you'll notice in this one, which makes it different than the first 2 that I've done with you, there's no like car C equals new car or car R equals new car. It just says car dot. That's interesting. How do you do this thing? Well, this is a special kind of method. Does not need to be instantiated to get kick-started. It just works right away. Let's go into the class and take a look at how you do that. So down as we work our way down, and I commented it out, now I'm going to make it wake up. We have this thing called public, and you give it a name like this one, void display. I call this one void other display, but I put one other word in front of it, static. And just by doing that, you have activated what we call a static method, and it does not require instantiation. So when I run it now, you'll see three answers. You're going to see the first answer with the Toyota 2007, then the Honda, and then just this little print statement. This display did not initially have to be instantiated. So there you have the next concept, and that was called a static method. Kind of cool. We're going to see it again later on in a future lecture, and you'll see how it's used. Now the most complicated idea that I'm going to teach you in this introduction to object-oriented programming. See, once you create a class, you can create what's called a subclass. Like a car is a car is a car. It has four wheels, things like that. Well, how about a minivan? A minivan's like a car. It's just bigger, might have more tires, but usually has four also. Might be able to hold more people, but it basically is part of the same family of an automobile, so to speak. Okay, so watch what I'm going to do. I'm going to activate this now. This is how you tell the computer that you're creating a class based on another class. Okay, so we're going to create this class called the minivan class. All right, let's take a good look at this. So I've defined now a class called minivan, which is a subclass of the car class. And just like my other class above, I can create some variables, okay, which we call fields. So I'm going to add one new field. So what we're doing with inheritance is we're saying, keep some of that old stuff. Like I don't want to redo all that again. And I'm just going to leverage that power of all the other things I've got in the first part of my car class, like the make and the model, the year. Okay, so I'm going to leverage that. So keep all of those, take those along with me, and add one new one, passengers. Okay, so that's the first thing. Then I create a constructor for the minivan class, and I create another field or a property. And this is how the outside world's going to get in. And remember, I'm also still going to have available to me the make and the year, because when you make a subclass of a major class, it begs, borrows, and steals everything that belongs to the one above it. Okay? Last thing is, I'm going to create another method called display, but hold it. It already has a display here. So how's it going to know which one's which? Well, we got to do something special, okay? And right now it's yelling at me with these two things. So when you start creating subclasses or classes via inheritance, you can't use private anymore. You have to use another special word called protected. Same kind of idea. The outside world's not going to know about it, but we have to do an extra level of protection called protected, and you'll see in a second that those red lines now are gone from here. Okay, so let's give this one, actually we're going to stop first. Let's give it a run after I show you what I'm going to add here. I have to uncomment some lines. So in this last demo, I'm going to make an instance of the minivan class. Okay, so I'm going to access the make, year, and the passengers, and then I'm going to print out the display. Now remember, display, which one's which? Well, it's going to use the minivan class or subclasses display, not the display that belongs to the car class, okay, which is very cool. And these two guys, they weren't really part of this class that I made. I begged, borrowed, and stole them from the car class, but that's what you can do with inheritance. Very cool concept. All right, so let's just see if it actually works. So that's the first question. That's the second one. That was the one about the static methods. And now the minivan class. Car make is Chrysler, year is 1999, can hold 7 passengers. Beautiful. So there you have the third idea in object-oriented programming, or the fourth idea I wanted to show you today. Let's do a quick recap so we remember all these different words we learned in this particular lesson. So in these advanced concepts today, we talked about encapsulation, which is a way to hide details of an object from another part of a program. The object can only be accessed through its access methods. Remember those accessors and mutators, the properties that have the get and set words? We also talked about static methods. You don't need to make an instance of the class to use them. You can just use them right away. Car dot whatever, and you can access it right away. Method overloading is where you have two methods of a class that have the same name but different parameters. Okay, and then we finished off with inheritance. Okay, so there you have our second and final lesson for now on an introduction into object-oriented programming. Now we will hit some of these ideas again in future examples as we do more complicated work. Okay, thanks for listening, and on to the new section. Welcome to the next section of the course, Working with Strings. In this section, what we're going to do is focus in on how to manipulate strings, anything with quotes on them, rearrange letters, all kinds of different manipulations. Now you might say at first glance, who cares? But as you're going to see as we get to the third and fourth lessons of the section, there's all kinds of neat applications that you can work with once you feel comfortable manipulating strings. The most important of which is cryptography, the science of rearranging letters so that nobody knows what you're talking about, encryption. We're going to take a look at some simple ones that involve credit cards. Okay, so that's where we're going to go with this next section. Okay, to get us started, we're going to use a couple of demo programs to get us used to some of the commands associated with strings. So hopefully you've unzipped the demos for this particular lecture, and we're going to start off with string intro. Now in and of itself, this program doesn't do anything magical, but it's going to introduce some of the key commands that we're going to use for the remaining lectures. Okay, so let me pop this up for a second. And this will introduce you to, in a kind of a simple application, the main commands when working with strings. So I'm going to type in Hamilton, Ontario, all right? And then the first command associated with strings is the .length command. And basically what it does is it figures out how many characters are in that string. Now it includes the blank in the middle too. So when I press length, that 16 represents the length from the H in Hamilton to the last O in Ontario. This next command, substring 4. Now the way that strings are used, even though we numbered them 1 to, in that case, 16 in terms of length, when the computer starts pulling apart letters, it assumes that the first character is actually 0. So the H in Hamilton is 0, the A is 1, the M is 2, the I is 3, the L is 4. So this command here basically says, starting with the fourth character, which really is the fifth, take them all. So when I press this command, it's going to grab the L all the way to the very end. The next one is your bread and butter. This is the command you'll use probably 99% of the time when you're manipulating strings. So it has two parts. It's called the substring command, and the first number represents where to start. So where to start grabbing letters from your string. The second number is how many to take. Now, you always got to remember that 3 doesn't really mean 3, it means 4 because we start at 0. So this is going to start really at the fourth letter. So H is 0, A is 1, M is 2, I is 3. So starting with the I, take 5. So it'll take the I, the L, the T, the O, and the N. That's 5 characters, okay? So that's going to be our sort of bread and butter command. And let's just make sure that that's right. Okay? Some other ones that are kind of cool, and I'm going to have to modify this to prove it to you, is there's a command called .starts with, okay? And if we press it right now, it's going to say false because Hamilton does not start with that. But let's call this, for the sake of doing something, Saint Ontario. And then if I press ST, it says true. Ends with an F. Again, this is going to say false. If I add an F to the end of that and I press this, it's going to say true. They're used once in a while, these type of commands. Index of J. I've got to put a J somewhere in there first, and it's a capital J. This is kind of a useful command. I use it every once in a while. It'll figure out the first occurrence of the letter J in any string that you're looking through. And in this case, it says 5. So S was 0, T was 1, period was 2, the blank was 3, the O was 4, and the J was 5. And that's how you get a 5. This is kind of cool. Puts everything in capital letters. This one puts everything in small letters. And this one's pretty powerful. I've used it every once in a while when we're doing coding. This replaces the first occurrence of E with an X. There's only one problem. There's no E or anything like that in there. So let's type in something. Some thing, okay? And there's the E, and when I press this, it's going to replace it with an X. All right, so those are some of the cool different commands that are going to be used over the next couple of lectures. But your bread and butter are actually these two. This to find the lengths of what we're going to be working with, and this substring. Those are going to be your bread and butter. Now let's take a look at a practical example. Now this next example, we're going to use it to do some of the work I'm going to assign you after I finish. It's going to be like little practice problems. So it's called letter count. So let's load it in first. And this one we're going to look at the code and everything else because we have to now understand how these commands work. So for instance, first one basically asks you for a string. Okay, and give it a second to start up here. And I'm going to type in New York. And when I press OK, it pulls apart every letter from New York and then redisplays it on the screen. Now, big deal, right? But that's the beginning steps of how we're going to pull apart information. And trust me, I find this the most exciting topic because when we get to the end, some very, very practical problems that happen today, you know, in the world of security and everything else, where you have to encrypt stuff, this is what you need to know to do that kind of stuff. So let's go into the underground and see exactly how we work with this. So first part is we're going to ask for a sentence, a word, whatever. We're using the input box, so we're going to get the answer from the person and store the answer there. Okay, now what we're going to do next is we're going to start pulling apart letter by letter. So we need to know how many letters are in the sentence we're pulling apart. So for New York, we have to know that New York has 1, 2, 3, 4, 5, 6, 7, 8 letters. Okay, now how you pull each one of them apart, we're going to use our for loop, which I love using, very simple to use, and it's going to start at 0. So actually remember, 0 is the first letter, so the 0 is the N in New York, and let's go all the way to less than 8. So what's less than 8? 7 is. Okay, so this is going to go 0, 1, 2, 3, 4, 5, 6, 7. Okay, and you could have put 7 there, but you'd never try to assume you know how many letters are in the sentence because it could work for anything, right? Now here's your bread and butter. Okay, remember I told you the two bread and butter commands. There's the length command, .length, and now here's that other one, substring. Now look how this one works. Let me clear the screen a little bit. Okay, substring basically works like this. We're going to pull apart from New York one letter at a time. So first the letter is I0. So it's saying, okay, start grabbing from letter 0 right here. Okay, and how many are you going to take? 1. Not 2, not 3, just the letter N, and that's it. So after we pull that letter out, we attach it to the text box. Okay, so the N goes right there in the text box, and we do a new line. So we go down to the next line. Then I becomes 2, okay? Or not 2, 1. We're at 0, it goes to 1, which now puts us right there, okay? And we take I is always the position where we are. And how many do we take? 1. So we grab the letter E, and the E gets put there, okay? So that's the process of pulling apart stuff and then doing something with it. Now, once you feel comfortable pulling apart stuff, you can put things in any order you want. So in this one, when I type in New York, it's going to reverse all the letters. So it's going to start at the end of New York and then go to the beginning of New York. Okay, so nothing spectacular there, but let me show you the code very quickly. All right, same as before, you ask for a sentence with the input box. You figure out how long the sentence is. This time you start at the end -1. Now realize, when the computer works out the length of the sentence, it's 8. But remember what I told you? You actually go from 0 to 7. So you start at 7 and you work your way back to 1 backwards. Okay? And if you forget what that is, this is how you tell the computer to subtract 1 from what you were at. So you remember how you go I plus plus goes up by 1, I minus minus goes backwards by 1. Okay, and the rest is straightforward, the same as before. Very generic, very simple programs. Now let's take a look at a sort of a semi-practical example. Let me do the last example. This last one says type in a sentence. Hello there, how are you doing? Do you get this example? Pretty long sentence. When I press OK, it comes back and says there were 2 letter A's in that sentence. Okay, so kind of different. Let's take a look at how you do that. So what this does is calculate or determine or count the number of whatever you want in your particular sentence you input. So in this particular example, just like before, I'm asking for a sentence. This time though, I'm going to do one extra thing. I'm going to count the number of a particular letter that there is. So right away, I figure out how long the sentence is. I start from 0 to the last one. Remember, less than. This is how you pull apart one of the letters of the sentence. This checks if it actually equals the letter A. If it does, you count it. Okay, let's see if you've caught on to what we've just covered. In this particular lecture, I have a PDF file which lists 3 problems I'd like you to try. Now, what I do is I would do it right in this program we just finished going through, okay? So add 2 or 3 more buttons and then give yourself half an hour, maybe a bit more, and give them a try, and then come back to the video and we'll take up the solutions. Okay, let's see how you did. Now, if you used this as your guide, I think you'd be in great shape. So the first example says, write a program which accepts a sentence and then determines the number of vowels in it. So we're looking for A, E, I, O, and U. So if you follow that logic, this is like this one right here, the letter count. And what I did was I copied this entire thing from beginning to end, and I put it all here, and then I made a couple of small changes. We're not just counting the letter A anymore, we're counting vowels. So I called that variable count vowels. And then this line right here is the big change. Is it an A? And those 2 lines mean or. Is it a letter A, or is it an E, or I, or O, or U? If it's any one of those, I'm going to count the vowel. And then you can print out the sentence, right? And then right here, instead of count A, would be count vowels. Okay, and let's give it a quick run to make sure it works. Okay, this is an example of vowel counting. Press OK. So there was 12 vowels in that sentence. Okay, so that's the answer to the first question. Now this second question, if you tried it or you got it, it opens up a whole can of worms, and really it might not be really a fair question at this level, but we'll give it a try. We're looking for the word the in a sentence. Now the, if it's all by itself, great, but what if it's in the word them or in the word there? Is that going to be counted also? You might have to. So this is a tricky question. There's so many possibilities. What I'm going to do is I'm going to actually look for the word the when it's all by itself like that. So really, I'm going to be grabbing not 3 characters, but 5 at a time. And if I see it all by itself like that, I'll count it. I don't want to count this one right here. But there's so many other things that could mess this up. But anyway, that's what I'm going to follow with. Okay, so let's take a look at the code. So just like the other ones, it has the same look and feel as this one. So I went here, copy and pasted again, and I put it in here. But now the part that's a little bit more challenging. So count the, that's kind of weird, but we'll put it like that. So for I equals 0 to the length of the sentence, and we're going to grab at that point, but we're going to grab 5 things. Now we're going to have to be careful here, because when we get near the end, we might go past what we're trying to do. So I think we're going to have to subtract 4 there to take care of that. Well, we might be on the right track by doing that. Now we're looking for the, and remember, it's blank like that. So we're grabbing 5 letters at a time, and if we happen to grab the, we're going to count it, and the count name is going to be like that. And down here, we're going to change that. But do you see, this opens up a big can of worms. The most important part of this solution is, did you get this logic? Either the 3 or the 5. Okay, let's see if I can get one of these to work. And I'll do a really simple example. Here is one with the all by itself. Now I wonder if we're going to crash or not if we go too far. We'll see in a second. No, we got lucky. It works. Okay, so that one is how you worry about getting the word "thes" from a sentence. Quite challenging, but at least gives you a basic idea of the logic that you had to follow. Now, this last example is a bit of a challenge because it's not like the other two. Although I'm going to copy this same program again, I'm going to have to make quite a bit of exchanges this time. First of all, you input any string, and what they want you to do is pull out the middle one. So a number of things have to happen. First of all, we have to make sure that this has an odd number of characters, because if there isn't, you're not going to be able to find the middle. So if it's 3, it's right in the middle. If it's 5, it's right in the middle. If it's 4, what do? So I have to make sure the person only enters in odd length strings. Then we got to figure out kind of a formula that'll pull out. Like for 3, it's got to be able to go to this position right here. Okay, so we're going to have to sort of invent a formula. So there's a number of challenges that we got to work on. Give this a shot. So first of all, I did copy and paste in the programs we've been using, but made quite a few changes. So first of all, I kept the sentence word, even though we're only going to ask for a word. This is new, okay? I am not going to let this person leave until they type in an odd numbered string. So the way you do that is, there's a, you know that while stuff we did before? This is kind of like the reverse of that. It says do while, so keep doing this while the sentence length %2, oh, what's that? That's that remainder stuff. So if you divide the length by 2 and you get a 0, that means you've been typing in an even numbered length string like 4, F-O-U-R. That's 4 letters. That's no good. You have to type in something with 5 letters. Okay, so until you do that, I'm going to keep asking you. Eventually you will type in something with an odd number of letters, and then we continue with the rest of the program. For the rest of the program, now I know the length. I hope it's 5 or 6 or 7, or 9. And then, we got to figure out a formula now. So let me doodle a little bit here. So what we're going to need to do now is, if it has this, like 3, I got to be able to grab this location. So this one's 0, that's 1. So somehow I got to invent a formula so that when I know the length is 3, I grab 1. So we got to sort of do a little bit of calculations. Okay, I hope you can follow this logic, but here is what I consider to be a solution. So like I said, if it's 3, we want this answer right here, 1. So what we're going to do is we're going to take the length, which I'll just shorten to L for now, plus 1. Okay, so the length was 3 plus 1 is 4. Divide that by 2, and you get 2. So yeah, we're taking the second one, but it's not really called the second one when we grab it. It's called 1, so we have to take 1 off of that. Let's try a 5 example. So this one has 5. We're going to grab that one, so it'd be 5 plus 1 is 6, divided by 2 is 3, but 0, 1, 2, so we take away 1. So yeah, that's going to work. So here we go. So we're going to take the length of sentence, all right, plus 1, and divide it by 2. We're going to have to use brackets. And then minus 1. And then how do we pull out that character? Well, now we're going to have like a string. So this is middle letter. Actually, we should have called this integer. And then we'll call it middle position. And that's going to be equal to what we took out here. So middle position is going to be the sentence. Substring. Okay, we're going to start at middle letter, comma 1, and then we'll pull that out. So this right here is going to have to be middle position. Okay, let's test it out very quickly. If I typed in new, it should come back with the letter E. If I typed in York, it's going to ask me again. If I type in help X, that should come back with the letter L. So it works. Okay, so there you have the solution. I have to wrap it up right now very quickly, but there it is right there, and I made sure I added this. So if you were checking your video a few seconds ago, I forgot to add this string. So there is kind of a more complicated solution. Welcome back to our section on strings. In this lecture, we're going to look at string accumulators and concatenation, two kind of fancy words that are going to allow us to pull apart strings, which we learned in our previous lecture, and now rearrange them in any kind of order we want. And this is kind of like the next logical step before we can do things like encrypt codes, figure out if codes are valid and things like that. So this is what the focus of this lesson is going to be. Now our base of operation for this lecture is going to be the demo program that you should download, unzip, and it's called String Accumulators. Now before we get rolling, let's talk about the two words we're going to work on today. First thing is 1 plus 2. You know that equals 3, right? But when you start putting quotes on numbers or words, something funny happens. It's not 3. 1 plus 2 with quotes on it is 1, 2 with quotes on it. So this operation of adding strings, the fancy word for that is called concatenation. Okay, so we're going to be doing a lot of that today. We're going to be rejoining things we pull apart. And for the most part, we're going to try to rejoin words and numbers, and codes obviously usually are numbers, so we'll deal with numbers a lot too. But the first word we need to know is concatenation. That's joining together strings. The second thing is accumulating. And if you remember this from before, total equals total plus number. What that does is basically add up a bunch of numbers and gives you a grand total. Well, let's pretend instead of total we had S total, which is like string total, equals string total plus, let's call this word or letter or something like that. This is going to be a string accumulator, and what it's going to do is give you a grand total of letters that we're joining together. So we're going to sort of add up stuff again, but it's not going to give you a grand total. Instead, it's going to give you one gigantic string that's all joined together. So that's called a string accumulator, and you're going to see both these ideas in today's lesson. Okay, let's start off with the first example, and I'll give it a run just to show you what it does first. So when I type in a word like yes, it's going to print the word backwards. All right. Now what makes this different is it's actually going to store it in a variable and sort of keep it as a total, but in terms of words. Let's take a look at the code. Okay. So first thing you'll notice is this is new. You know, when we did math with totals, we always had the total start off at 0. Well, now we're going to total words, but when you have words or strings being total, you don't say equal to 0, you say equal to nothing, which is two quotes stuck together. This line asks for the word, obviously, and then what we start to do is we start to pull apart the word backwards. Now, if it was the word yes, which was in quotes, okay, we would need to start here on the yes, okay, on the S of the yes. And remember, this is 0, this is 1, this is 2. The length of this is 3, but really we start at 2. So that's why you see word length minus 1. So we're starting right here, and we're going to work our way backwards. And as we pull apart things, like we pull out the S, we're going to join it to this accumulator, which is a box in the computer. And the first time through the box, we'll have the letter S. Then we'll join that letter S to the E. Now, when you join the letter S to the letter E, remember now, that's called concatenation. You have in this box after SE. And then when you get to the Y and you pull it out and join it to this, that's how you get that set of strings. Now, as I like to do, we're going to try to step through this and demonstrate it in super slow motion. Okay, so I'll press F11 and work my way through, and hopefully we can get this to pop up the right way. Okay, working out to the beginning. Okay, so this makes the program run, and I'll ask for the word, and actually I'm going to pause this here so it shows up properly. So we're on this line right now of input, right? And we're going to pop it up and ask for the word. And I'm going to type in Y-E-S. Okay, and then the computer goes to the next line. So right now the word has that value in it. Word length of the whole word is yes is 3 minus 1, which is going to be 2. And we work our way through now. This is going to pull out a letter out of that word. When it pulls it out, the reverse now has S in its brain. Okay, now we're on I. We're working our way backwards, remember? So now it's going to be 1. Okay, and we work through, pull out 1, 1, okay, which is the E, and now we have SE attached to reverse. And one more, we're on now 0, I hope. Okay, we'll see it when we get to this. There's 0. We're going to pull out the first letter now, which is the Y in yes, and now we've attached them all, and we've concatenated and created a totaler, accumulated values with strings. Okay, so that's the basic idea. Now, kind of boring in and of itself, and what we're going to do now is apply this knowledge to some applications involving numbers. And again, we're going to be doing some sort of mathematical gymnastics with numbers. We're going to rearrange them, flip them around, add them together, all kinds of weird stuff. And what I want to do right now with you guys is this first one right here. And then after I'm done, we'll take a break and I'll get you guys to try questions 2 and 3, and then we'll come back and take them up. So let's take a look at this first one. It says, if you're given a number, print it out forward and then backwards and then add them together. So let's say a person types in 234. I want us to create the reverse number, which we kind of already know, I just showed you. But now what I want to do after you've got the original number and the reverse number, I want you to mathematically, because I was just telling you that when you add strings, they join together. How do you then untake the quotes off? Well, I'll show you in a sec, and you add up whatever you get as the answer. Okay, so let's take a look at how you do that. Now remember, let this program be your base of operations when you start doing the other practice problems. But here we are now in the first problem application. Okay, so first of all, you're going to ask the user for a number, and then you are going to work out the reverse number. So here I do that right there. I have an input box that asks the user for a number. And you just saw me do this a couple seconds ago. This works out the reverse number. So where is the extra stuff that makes this a little bit more challenging question? Well, it happens right here. Now that you've got this original number from the person, which would have been, let's say, 234 or whatever. Let's make it 237. Okay. This right here reverses those. But remember, they have quotes on them. Okay. So how do you add them together? Well, you got to remember stuff we did a little while ago. We got to scratch these out. We don't want these anymore on here because we want to add them up. So this takes the quotes off, and then we get whatever the answer happens to work out to as a total, and then we print out our result. Okay, so not that bad, but this is giving you a taste for what you're going to do when you start manipulating things and rearranging things. Okay, let's give it a run just to show you what it does. Okay, here we go. So application, and I'll type in 456, and we're going to display the result right here. Okay, and if you're wondering, how did I do that? Basically, it's just this line right here. So number, okay, so number 456. Then I make the computer go down a line, and then I print out the reverse. Then I go down a bit more of a line, and then I do the total, which was done right here. Okay, so that's kind of cool. And that's the next step in manipulating numbers as we get to actual practical applications. So take a break now and try those 2 questions, then we'll come back and take them up. Welcome back. So how'd you do? Did you get them? Let's start off with number 2, and let's go through the logic and figure out if we can get this to work. So we're going to ask for 2 6-digit numbers. So it's going to be like a lot of this one. And from each number, we're going to form a new number from the 2nd, 4th, and 6th digits. So we're not doing backwards this time. We're going to go forwards, but we're going to skip the digits and take only 2nd, 4th, and 6th digits. Same with this one, and then add them together. Okay, it looks pretty straightforward. The only thing that could mess you up is when you do your loop, you're going to go from 0, 1, 2, 3, 4, 5. So even though I say take the second digit, you're really taking digit position 1, digit position 3, and digit position 5. So you had to realize that, because that's how strings are worked out in that substring command. So make sure you realize that as we go through the steps. Okay, let's pop this up, and I'm going to beg, borrow, and steal like I've done before from this question. Okay, and we'll copy, and then of course we're going to have to change what we need to work on. So we'll paste that in there. Okay, so we're going to ask for two numbers, so we're going to have string number 1 and then string number 2, and then we're going to have reverse 1 and string reverse 2. Hopefully that makes sense to you. Okay, so it's pretty close to what it was before, but that's the technique. Now we're going to have to ask two questions, so we're going to ask question number 1, and then I'm going to just copy and paste that, obviously, to save some time. And we'll paste that in there. Okay, so that's number 2. Okay, looking good so far. Now we're going to have two of these lines, two loops, where we're going to pull apart stuff. So like I told you before, even though we're taking the 2nd, 4th, and 6th, it's not really 2nd, 4th, and 6th. So it's really the first one, or first position, 0, 1, so it's the second one. And then we go all the way to 5, so less than or equal to 5. And then we're going to go up by 2, so plus equals 2. All right, so hopefully that makes sense. So we're taking 1, 3, 5. Okay, now we don't call it reverse anymore. And actually, they're not really reverse, are they? But I'll stick with that name because it's just easier to save me a bit of time. So you notice how I have reverse plus equals? If you still don't get that, you can go like this. Okay, and then this is number 1. I like it. Okay, now this is basically correct. So let's just paste it, and obviously we got to do almost the same stuff, but for number 2 now. So this is reverse 2. We're going to put reverse 2 and number 2. Okay, so this is taking it and making a new number. And why is it yelling at number 2? We'll figure out in a second. Okay, number 2 up there, yeah. Okay, so we'll continue from there. Now what we're going to do is add our reverse 1 to reverse 2, and then we display our results. So we're going to have our original, so now we're going to have reverse 1, reverse 2, and then our total. Now let's give it a run and see if it works. Okay, got mad at us for one thing. So number 2. Now why is it yelling at number 2? So there's number 2 up here. Okay, it's yelling at number 2 because I copy and pasted, but I didn't change that to that number. Okay, I think we're ready to run it. Let's give it a try. So I'm going to type in 6-digit number. So 1, 2, 3, 4, 5, 6. That'll be my first 6-digit number. And my second 6-digit number, 1, 2, 3, 4, 5, 6. And then we press OK. And now those are the new form numbers and what they add up to. Okay, so there it is. Hopefully that made sense. Very logical, systematic way to approach that. The trickiest part was in here. Okay, realizing that even though they wanted the 2nd, 4th, and 6th, the way the computer does strings, it considers the first one position 0, the second one position 1. So that's why we had to start from 1 and then go 2 more over and then 2 more over. So 1, 3, and 5. Okay, now let's take a look at the second one. You should remember from problem solving that first thing you have to do when you read a question is, do you actually understand it, and could you do it on a scratch piece of paper before you can even program? So question number 3 says that there's this driver's registration number. So depending on what country you're watching this from, you may not have this, but I'm using it from Canada. Anyway, let's pretend this is a driver's registration number that you would have on your license. And it says that to see if it's valid, what you do is when the digits are totaled, so this is going to be a string actually initially, but when we pull out the 9 and add it to the 4, add it to the 8, all the way to the 3, when we add up all those digits, whatever we get, let's pretend we get a 70. That answer has to be evenly divisible by 7. So that one is actually right. It goes in 10 times with nothing like, oh, bingo. So it would be a valid number. So that's the kind of logic we're trying to do in this question. Now let's apply it and program it. Now this question is not really like the other two. So I kickstarted it, but really I didn't copy and paste any of the original questions. So we're going to ask the user for the registration number, and we're going to work out a total, and then we're going to have to do some thinking. But that's the first part, so that's not too bad. You just use the input box that loads it in. Now the part that we got to work out. So we're going to do integer I equals 0, I less than, and the reg length, okay? And then the last part is I plus plus. Okay, so that's the first part, and then squiggly lines. That starts us off, right? Now, the total. Total equals total plus, now we're going to pull apart something, right? We're going to pull apart one thing at a time from the registration string, I comma 1. Now, it's getting mad at me. I know exactly why. Because when I pull this apart, it's going to be something like, if the number was 9, 7, whatever, when I pull this apart, I'm going to be pulling apart a quote 9. But what the heck? I'm doing math here. I can't have a quote 9. So somehow I got to be able to scratch that off before I total it. So now I've got to do this. I've got to do int.parse bracket, put another bracket all the way at the other side. And what that's doing is kind of like doing two things at once. This part in here is pulling apart the 9 with quotes on it, and this is taking the quotes off so I can total it up. So that's it for that stage. The decision I have to make. If the total %7 equals 0, which means that I divided it by 7 and it came out to perfectly, no remainder, nothing left over, then message box.show valid. And then the other case would be invalid. So else message box.show invalid. Okay, let's give it a run and try it. And I'm not even going to type in that big long number. I'm going to do something I know for sure works, even though it's stupid. 7. That definitely works, right? Valid. Let's do another one. 7, 1. That's 8. Definitely doesn't work. Okay, so do you see what it's doing? It's going to add up all the digits and then divide the answer by 7 to get a valid or invalid. Now we're getting close to, this I just made up, but we're getting close to what happens in real life. There are real driver's licenses, social insurance numbers. We're going to look at some product codes, Visa, where they do this kind of manipulation and they do some math at the very end to see if it's valid or invalid. So now you're getting a taste for a real application. Okay, and that's what we're going to do next. In this lecture, we combine the previous two lectures' ideas and now apply it to a practical application. What we're going to do in this lecture is look at product code verifications using a check digit scheme. Sounds kind of complicated, but we're going to look at some sample applications that incorporate the knowledge that we've learned and use it to figure out whether a code that a person types in to order a particular product or use their credit card is actually a valid number. So it's going to be kind of neat, and that actually shows you how it might work out in the real world. Okay, so we'll use an actual demo that I've typed up already as our base of operations. Then you're going to do a problem and use this as your sample example. Okay, so if you loaded in the demos for today's lesson, we're looking at credit card validation. That's just a generic name. It's actually not for credit cards. It could be for product codes, any type of validation that we're going to look at. Okay, now before I actually show you the example, what I want to do is show you the code behind this, or the theory behind this example. So what we're going to do today is called code validations. And a lot of account numbers, bank accounts, Visa accounts, codes that are in the books, UPC codes, all these different things, they follow a scheme. And usually what they use is either the first number or the last number is called a check digit, which is used to determine whether the actual number is valid or not. So this is one that I got out of a magazine several years ago. Doesn't necessarily mean you're going to be able to order something illegally using American Express or anything, but I just wanted to give you an idea of the way these schemes work. So this is an account number, okay, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. Visas might have 14, 15 digits, but this one has 10 digits. Now what they do is they use the last 9 digits, okay, and what they do is they double every one of those digits, okay, and then whatever it adds up to, they remember it. And then what they do is they go, if the first digit of the sum of the last 9 digits doubled is the check digit, so see that first digit, does that match that digit? If it does, it's valid. Okay, so a little bit different. Now there's ones that are a lot more complicated than this, but this will give us a taste for what's involved when people validate codes. Okay, so with that knowledge, let's now take a look at the program to solve that. So just to review again, here's an account number we're going to type in. We're going to start from really the second digit onward and double them all. And as we're doubling them, we'll add them up. So it's like that license one we did in the previous lecture, the registration number. Okay, so here is the code to do this. Now I start off and I initialize the credit card number or product code number, whatever you want to call it. I'm also going to need an accumulator that's going to add up all those 9 digits, the last 9 digits. I use a little bit of dummy proofing here. I'm going to ask the person to type in the number, but it better be 10 digits. So if it's 9 or 11, I'm not going to let them stop. They got to do it again. So I use that do while technique where I figure out the length of what they typed in, and if it doesn't equal 10, it keeps going around and around and around and around. Now remember, we want to do the digits, the last 9 digits, right? So remember how things go. The first digit is actually 0 to the strings. And then really that's the second digit, right? So you notice here my loop goes from 1 to not quite the length of the number. So when I do 10, which is the last digit, it's actually 9, right? So from there to there. So hopefully you've started to figure that out. And that's always the part that confuses a lot of students. I mean, how come the first thing isn't the first thing, okay? And they've used always this 0 as the first, so that throws things off. Now, what do I do as I go to each one of these 9 digits? That's pretty straightforward. You take that credit card number and you pull apart each character and you take 1 digit and you double it. Now, notice the order that I've done things in. This inside part pulls apart the digit. But remember, the digit that I'm pulling apart is actually not a number. It is a string. So when I'm typing in that big long number, it has quotes on it. So what this does is pulls apart that digit that I require, not the 8, but the next one after it, and then I take the int parse of it. So when I pull out whatever that number is, let's say it's a 4, that takes the quotes off, scratches those out, and then we double it mathematically. You can't do that until you take the quotes off, right? And then this plus equals is the cool way to accumulate. And again, if you don't get that still, here is the other way to write this, and both ways are okay. Okay, so just repeating that total, which I spelled wrong, over again. Okay, so total 9 digits equals total 9 digits plus that. And this will accumulate the grand total. Now here's the part that starts to get a bit tricky. So we've got our answer now, which when you total it up, and you saw the one I had on the screen a few minutes ago, it comes out to 84. Okay, so this right here comes out to 84. The entire credit card starts off with 8 and then a bunch of other numbers. It doesn't matter what they are, but just realize that the first digit of this credit card is 8. And we've got right now total digits 84. Now, first thing you should notice is this has quotes on it and this doesn't. Okay, so how are we going to try to say, hey, do you look like this guy? All right, so we got to do a bit of stuff. So here's what you do first. You take that total digits you just got and you convert it to a string. So that line right there puts quotes on it. Now I'm getting a little bit crazy here. I'm doing two things at once. I could have done it in one step. I could have done it in two steps. I did it all in one step. So this puts the quotes on it. Then what's this do? What this does is say, go to the first character, 0, and take 1. So after all of this crazy line, in here is now 8 with quotes on it. Now, how do I take the 8 off of this one? This one's a bit easier. This one's called credit card, 0, 1. So this one will also have in quotes 8. Hey, that's what we want, right? So now we basically say, hey, listen, is the first digit of the 9-digit total equal to the first digit of the credit card? And if they are, it's valid. If it isn't, it isn't valid. Okay, so now we're starting to get a bit more complicated. These are kind of the things you have to reason out when you do the credit card. Now, just because you understand this one doesn't mean you'll understand the next one. What you basically have to do is always realize there's going to be some kind of mathematical manipulation. Could be totally different. And then this part is always the tricky part, figuring out how to match their schemes. What's so special about their check digit? And some check digits are at the front, some are at the back, sometimes they're even in the middle, but mostly they're at the beginning or the end. Now, with this knowledge, what I want you to do is stop watching the recording for a couple minutes and try the second problem that I have in the PDF files for today. So this is question number 2. It's kind of like the one we just did. It's a slightly different scheme though. And also the check digit for this one is at the end, not the beginning. So we're going to take a break for a second, spend half an hour, whatever it takes to try this question. And this is actually from a real company. Now, this is a Canadian company that makes meats, hot dogs, hamburgers, stuff like that. And this used to be their product code designation. So when you would order stuff, you would type in a product code on their website or by phone, and they would type it in, and then they would say, oh, that's not a valid product code. We don't have anything that follows that scheme. So you're not going to be able to steal hot dogs or hamburgers. This is a very basic thing, but this is how they used to order their products and check if it was a valid order by checking the scheme. Okay, so kind of interesting. Give it a try, and then we'll take it up. Okay, what do you think? Do you think you got it? Let's take a look at the solution and see how it compares to yours. So, because you might not be sure of yourself, it's okay if you copy this entire thing. I told you everything's going to be different for every case, but it doesn't matter. Copy it all, and then we'll try to modify it. Now, string credit card, it's obviously not going to be a credit card in this one. We're going to call it maybe product code. Okay, it doesn't matter actually what you call it, but it doesn't matter. Total 9 digits, that's going to be different. Let's pop up the question again. And it says you type in a 5-digit number and then you times these things out. The first one by 5, the second one by 4, 3, 2. Don't touch the last one. Okay, so it doesn't matter what we really call it, but let's call it total 4 digits. Okay, we'll initialize it to 0. Here is where we ask for the code. Okay, so we'll type in the word product code. All right, and this one's, we're not going to let them get out of here until they type in a 5-digit number. Can't type in a 4-digit or 27 digits or whatever. And this, of course, has to be also product code. Okay, so far we are kind of using the question from before. Now it gets quite a bit different. So this is where it's going to change. Let's take a look at what their scheme is. So somehow in a loop, we're going to tell the computer to start from the first one to the fourth one. First one to the fourth one. How do you say that? Well, the first one is actually 0. And we're going to go to the, so 0, 1, 2, 3. So we're going to go to 3. 0, 1, 2, 3. And let's rub this out. So 0, 1, 2, 3 is 4 things. There's 5, but you don't touch the last one, right? So 0 to 3. All right, we're going to go up by ones, and we're going to do some sort of totaling of digits, okay? And we're somehow going to grab stuff, but here's where it gets different. We're not going to times it by 2. Like every one of them in the last question, we always times by 2. In this one, we're going to need sort of like a
a number that keeps changing. So I'm going to do this word called int multiplier, and I'm going to start it off at 5. Now, when I do the first one, it's times by 5. So I'm going to put the word multiplier right there. But then, after I'm done that one, I don't times it by 5 again. So let's go back. So the first one I times by 5, but then I have to go down to 4. So how do you tell the computer, listen, whatever your multiplier used to be, make it 1 less? Well, there's a cool way. You can go minus minus, or if you still don't get that, you can go multiplier equals multiplier minus 1. So that'll become a 4 instead. Now, did I spell multiplier wrong over here? Multiplier. All right, and multiplier with a T there. And now we're good. Okay, so that'll do the calculations for us. So far, so good. Now, of course, got a little mistake here too, credit card. This one is now called product code. And then we're good there. Okay, so far, so good. Okay, now we got to do some math. When we get that total worked out, in this case it's 75, we have to divide it by 11 and just keep the remainder. So remainder, remember that remainder stuff? Let's pop this back up. So this stuff actually now we're going to get rid of because we don't need it. So the next thing we're going to do is work out the remainder. So integer remainder is going to be equal to the total 4 digits percent 11. Kind of weird. You're taking the remainder when you divide it by 11. Okay, so that's good. Now, what am I going to do with that number? Well, it says here, after you get the 11, keep the remainder only, which is 9 in this case, then do 11 minus 9, which is 2. Whoa, that's really weird. So let's go back. Int calculated check equals 11 minus remainder. And that's going to give us 2. And now what we're doing is to finish up. We got to figure out a way to take the number we just worked out, 2, and see if it matches the last digit right there. And that's the last part of the problem. Okay, so let's create a string called check, and it's going to be equal to the product code.substring. Now we're going to take one character. It's going to be in position 4, not 5. Remember, we start at 0 and we're going to take 1. So that's going to give us our product code. Okay, and we've already got the calculated check, but we're going to call it the string calculated check, because you got to compare apples to apples, oranges to oranges. So if one's just a number and the other one's a string, you got to either make both of them numbers or both of them strings. So string calculated check, if I spell it right, calculated check is going to equal the calculated check to string, bracket, bracket. Now we have apples to apples, oranges to oranges, and we're down to the home stretch. Now we're going to say if check equals string calculated check. All right, so if those two match, message box.show valid, else message box.show invalid. Okay, let's give it a run, see if it works. So I'll do one that I'm just going to make up and I don't think it's going to work. Okay, that's invalid. Then there's the one that's on the sheet, 43982. I'll give that one a try. Just give it a run again. So this one's 43982, and it should say valid, and there it is. Okay, so the tricky part is always the last part. The first part usually not too bad. In this case, it was a little bit trickier, but it was pretty basic from the ones we did. This is where it started getting crazy, and they make up their own rules. These are pretty advanced things that are done by companies. So in this one, we had to figure out the leftover from 11, then take that 11, take away the leftover,
and that was supposedly the magic number. And then remember, you were comparing the 8, whatever, that big long product code or whatever the product code was when this one started off with a 5 or whatever, or 2, and you were comparing that last digit this time, not the first digit, but the last digit. So somehow you had to grab the last digit. Okay, remember it's a 5-digit number. So the last digit would have been in position 4. So that's why we did 4, 1. And we compare it to our calculated check digit, which was here. The only problem was, remember, this had quotes on it. So whatever the last digit was, let's say it was 2. Our number was a naked number 2. So we had to say to string to make it with quotes, so that this one would match that one. Okay, so that's where it gets a little bit crazy, and each question is going to be different, so you have to understand, you have to be flexible and understand that part. Okay, so there is a practical application. Now, to wrap up our last lecture, I'm going to give you one for a credit card company. Kind of a neat question, a bit more complicated. We're just going to introduce it, and we're going to basically go through one question in the last lecture. A very practical example for a credit card. Thanks for listening. We'll see you in the last lecture. Welcome back, and this is our final lecture in this section on strings. And what we're going to do in this last lecture is go through actually a very practical question to do with credit cards. And what we're going to do is try to validate a basic credit card. We'll give you a little background, then we'll go through the program. What I'll do is actually I'll pose the question to you, let you stop the video, try it out for a while, and then we'll take up the result. Okay, here's a brief intro. Most credit cards nowadays have 16 digits, and then they also have that 3-digit special code, but all these numbers mean something. And this is really interesting, and I'm just going to give you a quick little overview before I let you try the question. So all these numbers mean something. So like the first digit is the major industry identifier, okay? And it even tells you what they stand for. So 1 and 2 are airlines, 3 is travel, 4 and 5 is banking, 6 is merchandising. So all these numbers mean something. So that number there means something. Also, to us anyway, this last one's really important. That's our check digit. And that's going to be the most important part of validating this credit card. We're going to compare our results to that last digit. And other things that are in there, the first 6 digits are the issuer, okay? So obviously the major credit cards are Visa, MasterCard, Amex, Discovery, and those tell you who it's from. So really interesting article. You can go through the rest of it yourself, but let's focus in on now the bottom part, which tells us how this card is going to be validated. So very quickly, I'll go through it with you and then I'll let you go and try it. So after you have a program that inputs this 16-digit number, you start from the right-hand side and you go 1 over and you double all of those digits. Now after you double those digits, you're going to have a bunch of numbers. These are all the doubled digits. And then the ones you didn't double, you're going to remember those too, because what you're going to do is add the double digits to the numbers you didn't double, and you're going to get a final sum. In this case, the sum is 70. Then what you do is you divide it by 10, and if there's no remainder, this is a valid credit card. So I think you guys can do it. All right, so we'll take a break. Give it a try, and then when you think you've got it or you've had enough, you can start the video again and we'll go through the solution. Now, as usual, what you should do for this example is use the program we worked on in the last lecture and just add a button. So before we get really rolling, if you're stuck or you still want to give it a try, why don't you use this as your guide? Okay, let's really analyze now exactly the scheme for validating this credit card, and we'll sort of break it down so we can program it. So first thing is, we know that we have to start from here and double every other one, but you know what? We can still start from here. We know exactly what we have to do. So there is position 0. So we're going to use 0, and then this is going to be 2, 4, 6, 8, 10, 12, and it looks like we're going to go all the way to 14. So that's what we're going to do right there. So we're going to go from 0 to 14, and we're going to double all those. And the other ones, 1, 3, 5, 7, 9, 11, and 13. and there's even a 15. We're just going to add them up. Now there's one little extra trick though. When you double those ones we were talking about, if you get a 2-digit number, what they want you to do is take each little part of that digit and add them together. So 1 0 is still going to be 1. But 1 4, 14, they actually want you to take the 1 separate and the 4 separate and add those together. Same with this 18, the 1 separate and the 8 separate. So that's the little challenge because the rest of it to me seemed pretty straightforward. We've done ones where we double stuff already, and then this last part's going to be easy. We're going to take the 70 divided by 10, and if we get no remainder, great, then it's a valid number. Okay, let's take a look at the program. Now, as I mentioned before, I'm going to use this one we did from the last lecture, and I'll double click on it right now. And I've already set it up, and we're just going to work through it. I have this up here to remind me the basic construct of the program. We're asking for a credit card, so we have a variable string, credit. Here's our basic little simple dummy proofing where we ask the person to enter the card, and this one has to be 16 long, so if they don't type in something with 16 digits, I ask them to keep typing it. Now in this question, we're going to work out a grand total, so that's there, right there, but we're also doubling stuff, and it's important to know that when we double stuff, hey, if I get something like 10 or above, which means it's a 2-digit number, I got to do some extra stuff. Okay, so this is really the hard part of the loop. The rest of the loop isn't too bad. So the first part where you double everything, as you saw me do, we're going from 0 to 14 by 2s. Okay, so what we do is we take that digit that I happen to be on at that moment in time and double it. Now, when I double it, if it's less than 10, so it's, whatever, 1, 2, 3, 4, 5, 6, 7, 8, 9, I just add it together. No problem. Don't worry about it. But if I end up getting something like, when I double it, 18, which is a 2-digit number, then I got to do some extra stuff. First of all, because doubled 18 is a pure number, and now I'm going to have to pull these babies apart, I have to put quotes around these guys. So the first thing you see me do here is take the 18, let's say in this one, and take the number and double it by putting it into a string. Okay, so now we're going to, just with that number that's doubled, so like that 18 I just had on the screen a few seconds ago, but it has quotes on it. Now what I'm going to do is in here, start from 0 and go to the length. Now it's going to be 2, I know, but we're not going to assume that. And remember, it's not really 2. This is position 0 and this is position 1. So this loop's going to go from 1 to less than 2, which is a 1. So 0 to 1. And what it's going to do is add up these 2 digits. It's going to add the 1 to the 8 and add it to the total that's already running along here. Okay, so now that takes care of all the doubling and the crazy stuff right here. Okay, so this is where we had to put strings back on this double total and then tear it apart again. So it's kind of tricky, that part. The other part's pretty easy. The remaining parts, 1, 3, 5, 7, 9, 11, 13, 15, we don't double those, we don't do anything special. All we do is take them and add them to the totals that we've already been working on. And then the last step is really easy. All we do there is do the remainder based on 10. Okay, it's time to test it out and see if it actually works. And the one number that we do have that we know works for sure is this one. So we'll test that out and hopefully we've got it working properly. Okay, so this one should be valid. And there it is. Okay, so a little bit of a challenge. What made it a challenge was this part in here. So you see how you start using all these crazy things with strings to manipulate them, rearrange them, do some crazy stuff like add together the ones that were doubled. And this is the complexity of cryptography. And this is just scratching the surface, obviously, because this is an introductory course, but at least it gives you a feel for what would be involved in that kind of security system, or in this case, just a little validation system. Okay, thanks for listening, and hopefully you found this topic and unit very interesting. Okay, we'll see you in the next section.